All right, let's take a look at the practice test. For the instructions, we're asked to find the vertex form and state the vertex. All right, for the first problem, we have f of x equals 3x squared minus 24x plus 38. So the idea is we're going to start with something in this form. So f of x is equal to ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x, and c is your constant. And we want to put this into what we call vertex form. So this is f of x is equal to a times the quantity x minus h squared and then plus k. So there's lots of reasons to do this. One reason is it's going to help us when we go to graph parabolas. This is going to be in the next section. But the idea is that once you put it into vertex form, by simple inspection, you can get the vertex. So here, if I have it in this form, I can say the vertex is going to occur at h comma k. So this h right here, that's the x coordinate. This k right here, that's the y coordinate. We want to do one example where we use completing the square, although it's very tedious, just so that you get some practice with that. You might be asked to do that on a test. And then after that, we'll just go with the vertex formula, which is a lot easier to use. So to get things started, let me just write this. So f of x is equal to 3x squared minus 24x plus 38. The first thing you want to do is group your variable terms together. So I'm just going to put some parentheses around these guys right here. And then you want to make sure that when you're completing the square, the coefficient of x squared is 1. In this case, it's not. It's a 3. So what we're going to do is factor this out. And I'll go ahead and say that we have f of x is equal to, pull out the 3. And so inside you'd have x squared right there, and then minus what's going to go right here. Well, just think about 24 divided by 3 is going to be 8. So we'll put 8, and then we have the x there. You can check that. 3 times x squared is 3x squared, and then you have minus and minus, and then 3 times 8x, that would be 24x. So this is what we want. So then after that, you have your plus 38. So hopefully you remember how to complete the square. You're going to look at the coefficient for x raised to the first power. In this case, that's negative 8. You're going to cut it in half and then square it. So let's go ahead and say that we have negative 8 times 1/2. And then we're going to square that. So this is equal to negative 8 times 1/2 is negative 4. That would be squared. This would give me 16. So this is the tricky part. Because we're working inside of the parentheses here, we're just going to add it and subtract it inside the parentheses so that we don't end up doing something illegal. So let's go ahead and say that we have f of x is equal to 3 times the quantity x squared minus 8x plus 16 minus 16. So plus 16 minus 16 is 0. I have not done anything illegal. Then on the outside of the parentheses, I have plus 38. Okay, here is the part where it's very easy to make a mistake. What you want to do is realize that this part right here is a perfect square trinomial. That is going to factor into x minus 4 quantity squared. But the problem is I have this extra minus 16 here. So what I want to do is move that outside of the parentheses so that these guys are grouped together. So what you'd want to do is distribute the 3 to the negative 16 to move it outside. So I'm going to go ahead and say that we have f of x is equal to 3 times the quantity x squared minus 8x plus 16. You can close that down, but again, distribute the 3 to the negative 16 there. So let's go plus 3 times negative 16, and then you have plus 38. So now we'll write f of x is equal to 3 times, this right here again will factor into x minus 4 quantity squared. So x minus 4 quantity squared. Then you're going to have 3 times negative 16, that's negative 48. So minus 48, and then plus 38. To finish this up, you're going to do negative 48 plus 38, that's going to be negative 10. So let's say that we have f of x is equal to 3 times the quantity x minus 4 squared, and then minus 10. So if we match this up with the form that we talked about earlier, the f of x is equal to a times the quantity x minus h squared, and then plus k. Well, in this case, you can say that your h is just going to be 4, right? This matches perfectly. X and x, minus and minus, and then this h here is just going to be 4. So h equals 4. K is equal to, again, you can go plus negative to make this match. So k is just going to be negative 10. So I'm just going to go back to this being a minus here. But you would have h being equal to 4 and k being equal to negative 10. So for the vertex, if you want that, it's going to occur at 4 comma negative 10. Because again, it's h comma k. H is 4, k is negative 10. So that's all we're really doing here. I'm going to erase this, and we're going to do this problem again, but just using the vertex formula. You're going to see that's a lot quicker. All right, let's go back up here. and I've erased everything, and we're just going to start the problem over. So when you think about the vertex, again, this occurs at h comma k. And when you think about the vertex form, you have your f of x is equal to a times the quantity x minus h squared, and then plus k. So the idea with the vertex formula is that you can find h as being equal to negative b over 2a. This negative out in front causes a lot of sign mistakes. So a lot of times what I'll suggest to somebody is put the negative out in front and wrap this with parentheses, and that will help to stop sign mistakes. Because what ends up happening is if you plug in a negative somewhere there, a lot of times you disregard this negative and you end up with the wrong answer. Then when you think about your k, it's just equal to f of negative b over 2a. So you could really just say it's f of h. That's a quick way to put it down. I like this notation a little bit better. So basically you just go through and calculate your h and your k. You can plug it in there and then plug it in here, and you can get your a from right there. Again, your a value here is going to be the coefficient for x squared, so that's just 3. Your b value here is the coefficient for x to the first power, so that is going to be negative 24. You don't really need the c here. It's 38, but you don't need it for this formula. So what we're going to do is just plug in. So we can erase this a here and go ahead and put the 3 there. So that part's done. We need to figure out the h and the k. So let's put h as being equal to, again, the negative of, what is b? b is negative 24. And then this is over 2 times a. a is 3, so this is 2 times 3, which is going to be 6. Let's just write that in there now. And so what is negative 24 divided by 6? That is negative 4. So this is equal to the negative of negative 4, which we know is positive 4. So our h is going to be equal to positive 4. So let me erase that and put this as a 4. You can get rid of this and put this as a 4 here. And now k would be equal to f of, what is h? That's 4. So f of 4 is what we need to calculate. Let me get rid of this, and let me throw a 4 in there so that part's done. Let's go f of 4. This would be equal to 3 times, you'd have 4 squared, like that, minus 24 times 4, and then plus 38. Let me fix that. So let me slide down. I'll come back up in a moment. 4 squared is 16. So let's say this is equal to 3 times 16. And then minus, you'd have your 24 times 4, and then plus 38. Well, what is 3 times 16? That is going to be 48. And then minus 24 times 4, that is 96. And then plus 38. Well, 48 minus 96, that's going to be negative 48. And then you have plus 38. So this becomes negative 10. So your k, which again is f of 4, is going to be negative 10. So over here, again, you can go plus negative 10 or just write minus 10. And then right here, let's put negative 10. All right, so the vertex again is h comma k, so 4 comma negative 10 in this case. And then the vertex form, you have f of x is equal to 3 times the quantity x minus 4 squared minus 10. All right, for problem 2, we have f of x equals x squared minus 18x plus 91. So once again, we're trying to find our f of x is equal to a times the quantity x minus h squared, and then plus k. So this is the vertex form, and you also want to find the vertex. So the vertex is going to occur at h comma k. We put a little border here. First off, what is a? A is the coefficient of x squared. In this case, it's going to be a 1. So let's put a 1 there. Then what is b? B is the coefficient of x. So in this case, because you have minus 18x, you could really write that as plus negative 18x. So let's say b is negative 18. Now you don't need c, so don't worry about this. Again, your formula, this is something you just want to memorize or maybe write down for your notes. Your h is equal to negative b over 2a. But again, I always put the negative out in front of some parentheses so I don't make a sign mistake. So the negative of b over 2a. So what is b here? Again, that's negative 18. Let's just replace that. What is a here? A is 1. So 2 times 1 is just 2. So this would end up giving me the negative of negative 18 divided by 2. That's negative 9. The negative of negative 9 is positive 9. So h is positive 9. So let me put that right here. I'll replace that right here. And I'll replace that right here. We already know what a is. A is 1. So let me erase that. You can either put a 1 there or just leave it off. It doesn't matter. I'm just going to leave it off. And now we just need to figure out what is k. Well, k is f of h. h is 9. So f of 9 is equal to what? So let's do f of 9 down here. This is equal to, you would have 9 squared. So 9 squared minus 18 times 9, and then plus 91. Let me slide down here a little bit and say this is equal to 9 squared is 81. And then minus 18 times 9, that's 162, and then plus 91. 1. So this right here, 81 minus 162, that's negative 81. And then you have plus 91. And so this is equal to positive 10. So f of 9, we can erase this and put 10. Let's just erase this and put k is equal to 10. So we can erase this here and put 10, and then erase this here and put 10. So your vertex is going to occur at 9, 10, and then your vertex form is f of x is equal to the quantity x minus 9 squared plus 10. All right, let's take a look at problem 3. We have f of x equals 2x squared minus 8x plus 10. Once again, we want f of x is equal to a times the quantity x minus h squared plus k. The vertex is going to occur at h, k. So what do we know at this point? We know that a is equal to, it's the coefficient of x squared, so that's 2. b is equal to, it's the coefficient for x. So again, you could write plus negative 8 there. So let's put negative 8. Again, don't worry about c, we don't need it. And so if you want your h, this is equal to the negative of b over 2a. Again, I'm just going to wrap this in parentheses so I don't make a sign mistake. So the negative of b over 2a. And then your k, if you want to write that now, that's f of h. So what is b? B is negative 8. So you're going to plug in a negative 8 there. What is a? A is 2. So 2 times 2, let's just write that now. That's going to be 4. Negative 8 over 4 is negative 2. So this would be the negative of negative 2, which of course is positive 2. So h is 2. So I'm going to put a 2 there, and then I'm going to put a 2 there. Okay, let's get rid of this. And we can just write that h is 2. And k is f of h. So that means it's f of 2. So you're just going to take f of 2 and say this is equal to 2 times, you're going to have 2 squared minus 8 times 2 plus 10. This is equal to, 2 squared is 4, so this would be 2 times 4 minus 8 times 2 plus 10. 2 times 4 is 8, and then minus 8 times 2 is 16, and then plus 10. Well, 8 minus 16 is negative 8, so you have negative 8 plus 10, which is positive 2. So let me get rid of this, and we'll say k is also equal to 2. The a is going to be 2. Let me go ahead and replace that now. And the k is going to be 2. So let me replace that here, and then also here. So your vertex form is f of x equals 2 times the quantity x minus 2 squared plus 2. And then your vertex is going to occur at 2, 2. All right, for problem 4, we have f of x equals the negative of x squared plus 4x plus 4. All right, let's come down here and write that we want f of x is equal to a times the quantity x minus h squared, and then plus k. Then we want the vertex, which is going to be at h, k. So at this point, we know that a is the coefficient for x squared. You have a negative out in front. I would write this as negative 1 times x squared. So the coefficient for x squared is negative 1. So a is negative 1. And then b is the coefficient for x to the first power. So in this case, that's 4. Your h is given as the negative of, you have b over 2a. Now, b in this case is going to be 4. And a in this case is going to be negative 1. So let me write this is negative 1 like that, and close that down. So this becomes the negative of, well, if you think about 2 times negative 1, that's negative 2. So this would be 4 over negative 2, and 4 over negative 2 is negative 2. So this is the negative of negative 2, which is 2. So h is going to be positive 2. Okay, let me get rid of this and put a 2 here. So let me fill some stuff in. So a is negative 1. You could put negative 1 there or just put a negative, whatever you want to do. And then h is 2. So let's just plug that in there. And then also we're going to plug that in there. Now k is equal to f of h. In this case, h is going to be 2. So it's equal to f of 2. So let's figure out what is f of 2. And this equals, here's where you have to be very careful. This is negative 1 times x squared. So negative 1, let me put times, your x is going to be 2, and that's squared. If you were to plug in a negative 2 squared here, that would be wrong. You don't want positive 4 as your answer. You want negative 4 because it's negative 1, or you could say the negative of whatever x is being squared. The x is 2. It's not negative 2. So it's 2 being squared, and then you want the negative of that. So pay close attention to what you're doing there. So then we have plus 4 times 2, and then you have plus 4. And so this is going to be equal to, again, 2 squared is done first. That's 4. So let me write negative 1 times 4 like that, and then plus 4 times 2, and then plus 4. And this equals negative 1 times 4 is negative 4, and then plus 4 times 2 is 8, and then plus your 4. Negative 4 plus 8, that's positive 4. and then plus 4, and of course that's going to be 8. So your k here, which again is f of 2, that's going to be 8. So let me erase this and put 8, and then let me erase this and put 8. So the vertex form here is going to be f of x is equal to the negative of the quantity x minus 2 squared plus 8. The vertex is going to occur at 2, 8. All right, let's take a look at problem 5. So we have f of x is equal to 1/3 x squared minus 4x plus 21. So we want to find f of x is equal to a times the quantity, x minus h squared, and then plus k. So this is the vertex form. And we also want to find the vertex. So the vertex is going to occur at h, k. So a here is equal to what? It's the coefficient of x squared, so that's going to be 1/3. B here is equal to what? It's the coefficient for x, so here that's going to be negative 4. And then your h is equal to the negative of b over 2a. So your h would be equal to the negative of, what is b? B is negative 4, and then over 2 times a. So this is 2 times 1/3. So this equals the negative of, you have negative 4, let's write that as negative 4 over 1, and then over 2 times a third is 2/3. Let me make this fit here. So this would be equal to, we'd have the negative of, I'm going to write negative 4 over 1 times the reciprocal of this. So this is 3/2. And let me close that down. So this would be equal to, this would cancel with this and give you a 2 up here. So negative 2 times 3, that's negative 6. So this would be the negative of negative 6, which is 6. So that's your h. Let me go back up, and we're just going to say that this right here is positive 6, and I'll replace that right here, and I'm going to replace that right here. Now your a is 1/3, so let me go ahead and write that in right there. Okay, when we talk about the k, this is f of h, and h in this case is 6, so it would be f of 6. So what is that going to be? Let me come back up. So f of 6 would be equal to 1/3, and then times your 6 squared, and then minus 4 times 6, and then plus 21. So let me do this on this page here so we have room. So 6 squared would be 36. So this would be equal to 1/3 times 36, and then minus 4 times 6, and then plus 21. So 1/3 times 36, that's the same thing as taking 36 and divided by 3. That's going to be 12. So 12, and then minus 4 times 6 is 24, and then plus 21. So 12 minus 24 is negative 12, and then plus 21, this is going to be positive 9. So coming back up, this right here, this f of 6 would be positive 9. So let me erase this and erase this. And so the vertex form is f of x equals 1/3 times the quantity x minus 6 squared plus 9. And then the vertex occurs at 6, 9. All right, for problem 6, we have f of x is equal to negative 18x squared minus 144x minus 279. So again, we want to figure out the vertex form. So f of x is equal to a times the quantity x minus h squared, and then plus k. We also want to figure out the vertex. So this is going to occur at h, k. So looking at what we have here, we know that a is the coefficient of x squared. In this case, that's negative 18. Then your b is going to be the coefficient for x to the first power. So in this case, that's going to be negative 144. And then your h is equal to the negative of b over 2a. And let me just write that h is equal to the negative of, your b here is negative 144. And then over 2 times a, your a is negative 18. Okay, so this is the negative of, you have your negative 144 over 2 times negative 18, that is negative 36. So this would be equal to the negative of negative 144 over negative 36, that's positive 4. So we want the negative of 4, which is just going to be negative 4. So let's come back up and write this as negative 4. So let me replace this with negative 4. And this one right here, again, it's a little bit tricky. You're going to have minus a negative 4, which is plus 4. So you could write minus a negative 4 if you want, or you could just write plus 4. That's what I tend to do. So that's really up to you. It's going to be personal preference. It's correct either way. Then for your a, that's going to be negative 18. So you can put negative 18 right there. Let me make that a little bit better. Okay, let's figure out k now. So k, remember, is f of h. So we can say that k is equal to f of negative 4, since h is negative 4. And so what is f of negative 4? So f of negative 4 would be equal to, this would be negative 18, and then times you have this negative 4 being squared, and then minus you have 144, and then times negative 4, and you have minus 279. So this would be equal to negative 4 being squared. Again, the negative 4 is wrapped in parentheses. That's positive 16. So this is negative 18 times 16, and then minus 144 times negative 4, and then minus 279. Okay, so this is equal to negative 18 times 16. That is negative 288. Then for this one, we can just say this is plus negative, and then just go negative 144 times negative 4. That's going to be positive 576. Let me make this better here. And then you have minus 279. So this is equal to negative 288 plus 576 is going to give me 288. And then you have minus 279. So this would be equal to 9. So coming back up here, k again is equal to f of negative 4, which is going to be positive 9. So let's erase this and put a 9, and let's erase this and put a 9. So f of x equals negative 18 times the quantity x plus 4 squared plus 9. That's the vertex form. And then the vertex occurs at negative 4, comma 9. All right, for problem 7, we have f of x is equal to negative 2x squared plus 9. So this one looks a little bit odd because you don't have your bx term. In other words, when you look at f of x is equal to ax squared plus bx plus c, well, in this case, you could really rewrite this and say f of x is equal to negative 2x squared plus 0x plus 9, if you want to match this up. So that's going to allow you to use your formula. Let me get rid of this. And you can just work off of this. Remember that your a is equal to the coefficient for x squared. In this case, that's negative 2. Your b is equal to the coefficient for x. In this case, that's 0. So we're going to put 0 there. And then your h is equal to the negative of, you have your b over 2a. Well, what's going to happen here is that b is 0. So 0 divided by something that's not 0, the denominator would not be 0 here, you would get 0. So you can just say h is 0. You can skip all of that and say h is 0. Then if you want k, that's going to be f of h, so f of 0. So what is f of 0? F of 0 is equal to negative 2 times 0 squared plus 9. Well, 0 squared is 0. 0 times negative 2 is 0. So really, this is just going to be 9. So k is 9. Okay, so we have all the information we need. So the vertex form again is f of x is equal to a times the quantity x minus h squared, and then plus k. The vertex occurs at h comma k. So we know h is 0. So let me erase that and put a 0 in there. I'm going to put in a 0 there. And we know that k is 9. So let me put in a 9 there, and let me put in a 9 there. And then a is negative 2, so let me put that in there. X minus 0 is just x. So really, you could write this, let me scooch this down, by saying f of x is equal to negative 2 x squared plus 9. Now, some teachers want you to write it like this to emphasize the h here is 0. So that's really up to your teacher. But again, this is going to be something that's personal preference if you're self-studying. So I'm just going to say that we have f of x equals negative 2. Let's go times the quantity x minus 0 squared plus 9, where f of x equals negative 2x squared plus 9. Either way you want to write it. And then the vertex here would be at 0, comma 9. All right, for problem 8, we have f of x is equal to negative 1/3 x squared plus 6x minus 32. Okay, so once again, we want to find f of x is equal to a times the quantity x minus h squared, and then plus k. And we also need the vertex. So again, this is going to occur at h comma k. Let me put a little border here. And we'll say that a is equal to, again, it's the coefficient for x squared. In this case, this is negative 1/3. Your b is equal to, it's the coefficient for x, that's going to be 6. And then your h is equal to the negative of, again, your b over 2a. So h is equal to the negative of, for b, you have 6. This is over 2 times, for a, you have a negative 1/3. Okay, let me extend this a little bit better here. So this would be equal to the negative of, you have, let me write 6 as 6 over 1, and then over 2 times negative 1/3 would be negative 2/3. Let's close this down. So you're going to have the negative of 6 over 1 times the reciprocal of this, which is -3/2. So this would be equal to, if you think about this, the 6 would cancel with the 2 and give me a 3. 3 times -3 is -9. So this is the negative of -9, which equals 9. So your h here is going to be 9. So let's come back up and just say that this right here is 9. So I will replace this here and then also here. For your a, it's -1/3. So let me replace that right here. So -1/3. Okay, we need to figure out k. And again, when you think about k, this is equal to f of h. In this case, h is 9. So this is f of 9. So you would have f of 9 is equal to -1/3, and then times 9 squared, and then plus 6 times 9, and then minus 32. So this is equal to -1/3, and then times, you have 9 being squared. So this is 81, and then plus 6 times 9, and then minus 32. So if we have -1/3 times 81, that's going to be -27, and then plus 6 times 9 is 54, and then minus 32. So this equals -27 plus 54, that's going to be 27, and then you have minus 32. So this is equal to -5. So k is going to be -5. So let me replace that here. And again, you can go plus -5, or you can just go -5. Whatever you want to do. So this is your vertex form. F of x equals -1/3 times the quantity x minus 9 squared minus 5. And the vertex occurs at 9, -5. All right, for problem 9, we have f of x equals 10x squared plus 6. So once again, we want f of x is equal to a times the quantity x minus h squared plus k. So that's the vertex form. And then we want the vertex, which is going to occur at h, k. Let's make that h better here. Let me put a little border. And what's our a in this case? A is going to be 10. What's our b in this case? Again, when it sets up like this, it's going to be 0. You could write f of x is equal to 10x squared plus 0x plus 6 if you need to. So then what's your h? Well, in this scenario, your h is going to be 0. Because again, it's -b, and b here is 0, so the negative of 0 is still 0, over 2a. Let me actually write this out. If you put -b over 2a, again, you can do it like this. 0 divided by something that's not 0 will always give you 0. So this right here, I know it's going to be 0 in this scenario. And I know for k, it's just going to be this constant right here. Because if I plug in a 0 there, so f of 0, that's how you find k, it's f of h. So f of 0 there, plug in a 0 there, that's going to go away. You're just going to have 6. So when it sets up this way, there's really not a lot of work to do. So what you would do here is say the vertex is going to occur. Again, your h is going to be 0. And your k is going to be 6. So it's at 0, 6. Your a here is 10. Again, that's the coefficient for x squared. Your h here is 0. And then your k here is going to be 6. So again, depending on your teacher, they may want you to write it like this. So it's clear, this is h and this is k, your vertex form. But some teachers would prefer for you to simplify here. X minus 0 is just x. So you could really just write this by saying that the vertex form is the same as this. So f of x is equal to 10x squared plus 6. So if you're self-studying, you could write it like this or write it like this. Really, it's going to be up to you. All right, for problem 10, we have f of x is equal to -8x squared plus 80x minus 194. So let's write what we're trying to find. So again, the vertex form f of x is equal to a times the quantity x minus h squared, and then plus k. So we also want the vertex. So that occurs at h, k. So let me put a little border here and put that our a is equal to, again, the coefficient for x squared, which is -8. Our b is equal to the coefficient for x, which is 80. And then our h is equal to the negative of b over 2a. So this one would be pretty easy. We can just do it here. So b is 80. Let's plug that in there. And then a here is -8. So this, let me slide down a little bit, and I'll just put the -8 right there. I'll extend that and close this down. 2 times -8 is -16. So this would be the negative of 80 over -16. So 80 over -16 would be -5. So this would be equal to the negative of -5, which of course is 5. And I'll just say that this is 5. So I'll erase this and put a 5, and I'll erase this and put a 5. For your a, that's -8. So let's put that like that. Now for your k, this is going to be equal to f of h. Again, h is 5, so f of 5. So what is f of 5 here? This is -8, and then times 5 squared plus 80 times 5 minus 194. I think we can do this here. So 5 squared is 25. You'd have negative 8 times 25, and then plus 80 times 5 minus 194. So what is negative 8 times 25? That's going to be negative 200. So you have negative 200, and then plus 80 times 5 is 400, and then minus 194. So this would be equal to negative 200 plus 400, that's 200. So you can have 200 minus 194. Let me fix these zeros here. And so 200 minus 194 is going to be 6. So K would be 6. So let me erase this, and I'll put a 6 here and a 6 here. So this is your vertex form. F of x equals negative 8 times the quantity x minus 5 squared plus 6. And the vertex occurs at 5, 6. All right, let's take a look at the practice test where the instructions were asked to sketch the graph of each. All right, let's take a look at the first problem. So we're given f of x equals x squared plus 12x plus 35. So if you're asked to sketch the graph of a parabola, typically you're either going to use graphing transformations or you're going to use that step pattern. So we talked about both of those in the lesson. So it's really up to you which one you want to choose. I think the step pattern is usually faster. It's not always the case, but usually it's going to be the better choice. So for the first one, I'm just going to do it both ways, and then I'll just kind of alternate based on the problem. So the first thing you would want to do for either scenario, you would want to write this in vertex form. So that is f of x is equal to a times the quantity x minus h squared, and then plus k. Okay, let me put a little border here. So you need to figure out what is a, what is h, and what is k. So we know that a is just the coefficient for x squared. In this case, it's understood to be 1. You can put a visible 1 there just for clarity. So a equals 1. Your b, which is something you're going to need, that's the coefficient for x to the first power. So here that is 12. And then you need h and you need k. So this comes from the vertex formula that we talked about in the last section. So h is the negative of b over 2a. So b here is going to be 12. And a here is going to be 1. You can just erase it. So negative 12 over 2, that is negative 6. Okay, so h here is negative 6. What is k? K is f of h. In this case, h is negative 6. And all you have to do is plug in here. So f of negative 6 is equal to negative 6, make sure to wrap that in parentheses, squared, and then plus 12 times negative 6, and then plus 35. We know that negative 6, again, if it's wrapped squared, that's going to be positive 36. So this would be equal to 36, and then plus 12 times negative 6, that's going to be negative 72, and then you have plus 35. So 36 plus negative 72, or you could say 36 minus 72, that's going to be negative 36, and then you have plus 35, and of course, negative 36 plus 35, that's negative 1. So k here would be equal to negative 1. All you have to do once you have this information is just plug in. So a is 1. You could put it there if you want, or just erase it. You don't really need it. H is going to be negative 6, so be very careful with how you write this. This is x minus your h. Again, h is negative 6, so we'll write it like this. So x minus a negative 6, this is quantity squared, and then plus your k. K is negative 1. So in this form right here, you can just say that the vertex is going to occur at h comma k. So h is negative 6, and then comma k is negative 1. So let me actually change the form over. We know that x minus a negative 6 would be x plus 6. So this is x plus 6. Again, then this is quantity squared. And then plus negative 1, you could just write this as minus 1. So this is how I would write it. You just have to understand that if you want to grab the x coordinate for the vertex, this has to be in the form of x minus some number. So you have to change this back over to x minus a negative 6. So that quantity squared. Okay, so let's look at graphing transformations first. You would compare this to the squaring function. We're already using f of x here, so let's just say g of x is equal to x squared. So compared to this, what's happening here? Again, on the inside, you have to undo things. You have plus 6, so to undo that, you need to subtract away 6. So that's going to give me a shift to the left by 6 units. So we're going to say that we're going to shift left by 6 units. Then second, we have this minus 1 on the outside. That's just going to shift me down by 1 unit. So shift down by 1 unit. What I would do to make some points in order to sketch the graph, just follow this right here. So in other words, on your g of x is equal to x squared, you have some x comma y, and that's going to go to, when you have f of x is equal to the quantity x plus 6 squared minus 1, where you're going to do what to x? You're going to shift left by 6 units, so that's x minus 6. You're going to do what to y? You're shifting down by 1 unit, so that's y minus 1. So hopefully you know the points on g of x equals x squared. It's something we've worked with a lot. So you could say something like 0, 0. So that's the vertex here. When we go over here, it's going to be 0 minus 6, which is negative 6, comma 0 minus 1, which is negative 1. So negative 6, comma negative 1 would be your vertex, which we found earlier. Then if you take something like negative 1, comma 1, that is going to be negative 1 minus 6, that's negative 7, and then comma 1 minus 1, that would be 0. Then you have something like 1, comma 1, that's going to go to, you have 1 minus 6, which is negative 5, and then comma, again, 1 minus 1 would be 0. Then let's take negative 2, comma 4, that's going to go to negative 2 minus 6, that's negative 8. And then comma, you have 4 minus 1, that is 3. Let's just do one more. So 2 comma 4, this is going to go to, you have 2 minus 6, that's negative 4. And then 4 minus 1, that's going to be 3. So again, this is one way you could do it. Typically 5 points is enough to graph a parabola. Okay, so let me come down here and paste this in. So this is going to be our graph. So we have negative 6 comma negative 1, that's your vertex. Then you have negative 7 comma 0, so that's going to be right there. You have negative 5 comma 0, so that's going to be right there. You have negative 8 comma 3, so that's going to be right there. And then you have negative 4 comma 3, so that's going to be right there. So let me get rid of this, and we can label this. So we could say that this is going to be the graph for f of x is equal to the quantity x plus 6 squared minus 1. Now you can get additional points going if you want. Again, if you had taken something like negative 3 comma 9, and again, you take the negative 3 and you subtract away 6, that's going to put you at negative 9. If you take the positive 9 and you subtract away 1, that's going to give you 8. So if you go 9 units to the left and 8 units up, that's going to put you right there. So that would be another point. Let me label it right here on the inside. So negative 9 comma 8. And of course, you're going to have this point right here, which is going to be negative 3 comma 8. And that's going to come from 3 comma 9. Again, you're taking the x coordinate, you're subtracting away 6. 3 minus 6 would be negative 3. And then that 9, that y coordinate, you're subtracting away 1. 9 minus 1 is 8. So that's how you get the negative 3 comma 8. So again, you can use graphing transformation to do this. This is one approach. Now, the other way would be to use the step pattern. That's pretty straightforward. Typically, that's the faster way to do this. So you still need this guy in vertex form. That way you can get the vertex. That's your first point. And then from there, you're using that pattern. So it's 1, comma 3, comma 5. Let me make the 5 better. Comma 7. And this continues forever. You typically just use the 1 and the 3. Sometimes you use the 5. But essentially, starting from the vertex, you're always going to move 1 unit to the right, and then you go up by the next number in the pattern. So right here, you're going 1 unit to the right. So the x value would now be negative 5, and you're going 1 unit up, so the y value is 0. Again, I'm using that. Then once I've used this one, now I'm going, let me just mark this out as I go. Now I'm going to the 3. So I'm always going to go 1 unit to the right. 1 unit to the right, so now the x value is negative 4, and then I'm going 3 units up. So 1, 2, 3. So if you look, now the y coordinate is going to be 3. Now you can mark this one out. So now I'm going to go 1 unit to the right and 5 units up. That's the next number right there. So 1 unit to the right, now the x value is negative 3, and then 1, 2, 3, 4, 5. So the y value is now 8. So again, now you can mark that out and you would go to 1 unit to the right, 7 units up if you wanted to do that. This is the pattern that you would use. Let me erase this real quick. If you want to do it that way, to get these points over here, remember that your parabola is symmetric with respect to the axis of symmetry. Again, some books call that the axis of the parabola, and that's going to be the line x equals negative 6. So it's always x equals h. H in this case is the x coordinate for the vertex. Let me go ahead and sketch that in. So this is your x is equal to negative 6. Again, that's your axis of symmetry. So what happens is if you look at, so this right here, just look at the x, don't look at the y because the y is going to be the same. How far do I have to go horizontally to get from right here to right here? Well, it's 1, 2, 3 units. In other words, right here, the x value is negative 6. Again, because we're on the line, x equals negative 6. So here, the x value is negative 3. So I had to travel 3 units to the right to get over here to an x value of negative 3. Well, on the other side, again, I have to travel 3 units, but in the opposite direction. So 1, 2, 3 units to the left. So now the x coordinate would be negative 9. The y coordinate of 8 would be the same. So it would be the same thought process here. So if you look at this, I would go 1, 2 units to the right to go here. So I need to go 1, 2 units to the left to go here. This one is 1 unit to the right. So here we go 1 unit to the left. So that's how you get those points over there. So the step pattern is another way to do it. A lot of times that's going to be a lot quicker, but if you want to use graphing transformations, that's another solid approach. All right, let's take a look at problem 2. Here we have f of x equals x squared minus 6x plus 8. Let's first start with the vertex form. So f of x equals a times the quantity x minus h squared plus k. Let's put a border here. So we have a is equal to, the coefficient for x squared is just a 1. Again, you can write that in if you want. Let's put a 1 there. B is equal to the coefficient for x to the first power. That is negative 6. H is equal to negative b over 2a. Well, here's where you have to be very, very careful. You are plugging in a negative here for b, and you have a negative out in front. I'm just going to highlight this. A lot of times I'll wrap this with parentheses, and I'm going to replace this with a negative 6. Then 2a. Well, a is 1, so you can just erase this. So this would be negative 6 over 2, that's negative 3. So this becomes the negative of negative 3, which of course is positive 3. So let's put a 3 right here. And then k is going to be f of h. H is 3, so this is f of 3. So we're just going to plug in here. So we're going to say f of 3 is equal to, you would have 3 squared minus 6 times 3, and then plus 8. Well, 3 squared is 9, and then minus 6 times 3 is 18, and then plus 8. 9 minus 18 is negative 9. So this is negative 9 plus 8, and negative 9 plus 8 is negative 1. So k here is negative 1. And you can erase a. You could put a 1 there if you want, but it's just not necessary. For h, that's going to be a 3. And then for k, that's going to be negative 1. So let's just write minus 1. So let's just do the step pattern on this one. It's pretty straightforward. We're just going to say that the vertex is going to occur, again, at h comma k. So that is 3 comma negative 1. And then from there, you could just use your pattern. So let me go ahead and grab this. Let me paste this in. Let me go ahead and label this real quick. So this is f of x is equal to, you have the quantity x minus 3 squared, and then minus 1. Now, when we look at the vertex, that's 3 comma negative 1, so that's right there. So that would give you that point. The additional points, again, you use that pattern. So it's 1 comma 3 comma 5 comma 7. Now, when I go 1 unit to the right, the x value is now going to be 4, and then I go 1 unit up, the y value is going to be 0. Again, once you use it, you can just mark it out. Then from there, I'm going 1 unit to the right, so the x value is now 5, and then 3 units up, so 1, 2, 3, the y value is now 3. So I would mark that out. My personal opinion is 5 points is enough to get a parabola, so you would get these other two, and I'll do that with the axis of symmetry in a moment. But if you want to do this one, you can. So 1 more unit to the right, so that's going to give me an x value of 6, and then we're going to go up by 5. So 1, 2, 3, 4, 5. That's going to be right there. Probably should use a different color for that. So let's put that like that. So the y value there would be 8. So maybe I'll change this labeling and put it like that. So I can put this point right here, which would be 6 comma 8. So 6 comma 8. If you want these points over here, again, you can use the axis of symmetry. So that's going to be x equals 3. So this is x equals 3. That's your axis of symmetry. And just like we talked about in the last problem, if you're starting with, let's say, this point right here, well, if you're on this line, your x value is going to be 3. So I'm going 1 unit to the right here to get to an x value of 4. So to reflect, I want to go 1 unit to the left over here. So that would give me an x value of 2. So that's how I get 2 comma 0. Similarly, right here, I'm going 1, 2 units to the right. So to get this point, I'm going to go 1, 2 units to the left. And then right here, I need to go 1, 2, 3 units to the right. So I need to go 1, 2, 3 units to the left. So that would give me that point right there, which is 0 comma 8. All right, let's take a look at problem 3. So we have f of x equals 2x squared minus 32x plus 126. So for this one, because the coefficient of x squared is not 1, I'll just do it both ways. I'll use graphing transformations, and then I'll do the step pattern. You have to make a modification when the coefficient of x squared is not 1 to your step pattern. So we'll talk about that in this problem. So here we have f of x is equal to a times the quantity x minus h squared, and then plus k. Let me put a little border here and put that a is equal to, again, the coefficient for x squared, so that's 2. B is equal to the coefficient for x to the first power, so that's negative 32. H is equal to the negative of b over 2a. Well, b is negative 32. So be very, very careful. Let me go ahead and highlight this so we don't make a sign mistake. So this is negative 32 that I'm plugging in there. And then 2 times a is 2. So 2 times 2 is 4. Well, what is negative 32 over 4? That's negative 8. So this would give me the negative of negative 8, which is 8. So let me get rid of this, and let me put an 8 there. K is equal to what? Again, f of h is 8, so f of 8. So f of 8 would be equal to 2 times. You have 8 squared minus 32 times 8, and then plus 126. Definitely one I would just use a calculator for, but let's just go through this. So 8 squared is 64, and then you could do 64 times 2, that's 128. And then you have minus 32 times 8, that's going to be 256, and then plus 126. So 128 minus 256, that's negative 128, and then plus 126. So negative 128 plus 126, that is negative 2. So k is equal to negative 2. So we're going to say that a is 2. We're going to say that h is 8. And then we're going to say that k is negative 2. So you can write minus 2 there, or plus negative 2, whatever you want to do. So we know that the vertex is going to occur at h comma k. So h is 8, and then k is negative 2. So we're going to use the step pattern in a moment. Let me go ahead and grab this real quick. And let me come to the graph, and I'm just going to drop this off right here. So the vertex is at 8 comma negative 2. But we're going to go back up, and we're going to do this with graphing transformations. Let me get rid of this. So let's say that you have over here, your g of x is equal to x squared. And again, you'd have stuff like, let's say 0 comma 0. You would have negative 1 comma 1. You'd have 1 comma 1, and you'd have negative 2 comma 4. And then you'd have 2 comma 4. So we know these points already. You realize that you have, on the inside here, x minus 8. So to undo that, you want to add 8. Always on the inside, you need to undo things. So the first thing is I'm going to have a shift right by 8 units. The second thing is I'm going to do my vertical stuff, and I'm going to do that in the correct order. Remember, vertical follows the order of operations. So you want to multiply by 2 first, then subtract away 2 second. So in other words, I want to do the vertical stretch by a factor of 2, followed by my shift, let me make this better. So down by 2 units. So this is going to be for g of x. What's going to happen is this is going to go to, well, in terms of x, you're shifting right by 8 units, so x plus 8. In terms of y, you're multiplying by 2 first, so 2y, and then you're subtracting away 2 seconds, so minus 2. So this right here, 0 plus 8 would be 8, and then 2 times 0 is 0, and then 0 minus 2 is negative 2. We already know the vertex occurs at 8 comma negative 2. This is the vertex here for g of x equals x squared. This is the vertex here. When we go to f of x equals 2 times the quantity x minus 8 squared, and then minus 2. So then going here, you would have negative 1 plus 8. That's going to be positive 7. And then 2 times 1 is still 2, and then minus 2 is 0. Now this y coordinate here would be the same. The x value is going to change. 1 plus 8 is 9. So now you have 9 comma 0. And then for this one, you have negative 2 plus 8. That's going to be 6. And then you have 2 times 4, that's 8, minus 2, that's going to be 6. Again, for this one, the y coordinate is going to be the same. For the x value, 2 plus 8, that's going to be 10. So again, this is one way you could do it. Let me go ahead and grab this real quick. Come back down here and paste this in. So again, you have your vertex, which is at 8 comma negative 2. Then you have a point here, which is 7 comma 0, a point here, which is 9 comma 0, a point here, which is 6 comma 6, and a point here, which is 10 comma 6. So one way to do it. The other way, again, let me go ahead and label this. So this right here is f of x is equal to 2 times the quantity x minus 8 squared, and then minus 2. Another way to do it is to use that step pattern. But this is the tricky part here. Normally it's 1, 3, 5, 7, so on and so forth. But that's when the coefficient for x squared, or the a value, in this case it's this number out in front of these parentheses here, that's when that's 1. If it's not 1, you have to multiply each number in this pattern by whatever a is. So the pattern here would be 1 times 2, which is 2, and then 3 times 2, which is 6, and then 5 times 2, which is 10, and then 7 times 2, which is 14, so on and so forth. So this is the pattern that you want to use. This is very important to understand, and if you don't make that modification, you will get the wrong graph. So be very, very careful if you're using the step pattern, and the coefficient of x squared is not 1. So starting at the vertex 8 comma negative 2, again, I can go 1 unit to the right, and now, because this is a 2, I've got to go 2 units up. So 1, 2. So the x value goes from 8 to 9, and the y value goes from negative 2 to 0. So that gives me the point 9 comma 0. So I'm going to mark that out. The next number right here is a 6. So 1 unit to the right, 1, 2, 3, 4, 5, 6 units up. So the x value of 9 goes to an x value of 10, just going 1 unit to the right. And then the y value of 0 goes to a y value of 6. Again, I'm going 6 units up. So that's the 10, 6. So you can mark that out. Again, if you were going to continue here, which it doesn't have room on this graph, but if you were on Desmos or something like that, you could just go 1 unit to the right and then 10 units up. So that point would be 10 plus 1 is 11, and then 6 plus 10 is 16. So if you're on Desmos, and I gave you a link for that, you can check that 11, 16 is going to be on the graph, and I promise you it will be. Now, in terms of these guys over here, again, you're going to use this axis of symmetry. So x equals 8. If I'm right here, again, the x value is 8. Well, to go right here, I need to go 1 unit to the right. That gives me an x value of 9. Well, when I go over here, I need to go 1 unit to the left. So now I have an x value of 7. The y value is still the same as 0. Same thing over here. If I need to go 1, 2 units to the right here, I need to go 1, 2 units to the left here, so on and so forth. So just be very, very careful if you're sketching the graph using the step pattern and the coefficient for x squared, the a value is not 1. All right, for problem 4, we have f of x equals negative 2x squared plus 16x minus 29. So for this one, I'll just use the step pattern. So what we'll do here is just write this in vertex form. So f of x is equal to a times the quantity x minus h squared, and then plus k. So a is equal to negative 2. B is equal to positive 16. Then your h is equal to the negative of b over 2a. Well, b here is 16. A here is negative 2. So 2 times negative 2 is negative 4. So this is the negative of 16 over negative 4, which is negative 4. And so the negative of negative 4 is 4. So h here is going to be 4. Then your k is equal to f of h, so f of 4. So let's say that we have f of 4 here. So this is equal to negative 2 times. You would have positive 4 squared plus 16 times 4, and then minus 29. 4 squared is 16. Negative 2 times 16 is negative 32. Then plus 16 times 4 is 64, then minus 29. Negative 32 plus 64 is 32, and then 32 minus 29, that's going to be 3. So let's come over here and erase this and put that k is equal to 3. Let's erase the a and put a negative 2. Let's erase the h and put a positive 4. Let's erase the k and put a 3. So here we would have the vertex. So the vertex would occur at, again, h comma k, so that is 4 comma 3. And let me come down here and paste this in. So I'm just going to label this real quick. So this is the graph for f of x equals negative 2 times the quantity x minus 4 squared plus 3. The vertex occurs at 4 comma 3. So that's going to be up here. So that is the highest point on this because it's downward facing. When you use the step pattern here, you have to be very careful because the a value is negative. Remember, if it's a negative a value, this guy is downward facing. So your pattern, which is, again, normally 1, 3, 5, 7, continuing forever, well, now you're multiplying each one of these guys by negative 2. So you're going to get 1 times negative 2, that's negative 2. 3 times negative 2, that's negative 6. 5 times negative 2, that's negative 10. And you can just stop there. So on and so forth. You could do 7 times negative 2, that's negative 14. But again, it's not necessary. You're not going to use that. So this is the pattern that you're going to use here. Again, if the coefficient for x squared, that a value is not 1, you have to make this modification. We're starting at 4 comma 3. We're going to go 1 unit to the right. So the x value is now 5. The number in the pattern here is negative 2. So that means I'm going to now drop by 2. 1, 2. So the x value went from 4 to 5. I increased by 1. The y value went from 3 to 1. So it decreased by 2. So that gives me the 0.5 comma 1. Then we're going to the next number in the pattern. So get rid of this. Now we have negative 6. 1 unit to the right. So the x value is 6. And I'm going 6 units down. So 1, 2, 3, 4, 5, 6. So the y value is now negative 5. Again, the x value went from 5 to 6, so we increased by 1. The y value went from 1 to negative 5, so we decreased by 6. So then you would mark this out, and you can go to negative 10 next. So again, this is not on this graph right here because there's no room, but if you go to the link on Desmos, you'll see that you can go 1 unit to the right, so that would be 7, and then you would go 10 units down, so that would be negative 15. So you can check that on Desmos. You will see that 7 comma negative 15 will be on the graph. Again, I have a link for you if you just want to click it. All right, so in terms of the points over here, again, you can just reflect across the axis of symmetry. Okay, so this is x is equal to 4. So if I just wanted to start, let's say right here where the x value is 4, to travel over here to this 0.5 comma 1, I need to go 1 unit to the right. So to get this point over here, on the other side, I need to go 1 unit to the left. So now I would have 3 comma 1. Then coming down here, it's the same thought process. this is 1, 2 units to the right. So to get this point over here, I go 1, 2 units to the left. All right, for problem 5, we're given f of x equals 1/2 x squared plus 4x plus 7. All right, let me slide down here a little bit. So one thing to understand is that if the coefficient for x squared is not an integer, so in this case you have 1/2, well, it's going to be much more tedious when you consider using the step pattern. So you might want to use graphing transformations. So for this one, I'll just do it both ways just so you can compare. So let's go ahead and say that we have f of x equals a times the quantity x minus h squared, and then plus k. Let me make this better here. Let me put this like that. So a here is equal to, again, the coefficient for x squared, that's 1/2. B here is equal to the coefficient for x to the first power, so that's 4. H is equal to the negative of b over 2a. Well, if we look at b, that's going to be 4. And if we look at a, that's going to be 1/2. 2 times 1/2 is going to be 1. So this turns into negative 4 over 1, which is just negative 4. In terms of your k, this is equal to f of h, so f of negative 4. So you have f of negative 4. This is equal to 1/2 times negative 4 squared plus 4 times negative 4, and then plus 7. So negative 4 squared, again, this is wrapped here. That would be positive 16. And then 16 times 1/2, that would be 8. So then 4 times negative 4, that would be negative 16. So let's go minus 16 and then plus 7. Well, 8 minus 16 is negative 8. And then plus 7. Negative 8 plus 7, that's negative 1. So k here is negative 1. So let me just write this out. So f of x is equal to 1/2 times the quantity, again, x minus a negative 4. We'll change this over in a moment to x plus 4. So this is quantity squared. And then you have plus negative 1, you can just write minus 1. So what you would say is that your vertex is going to occur at h comma k, so negative 4 comma negative 1. And I'm just going to paste this right here. We're going to come down to this in a moment. You can already see that negative 4 comma negative 1, that's the vertex. But let me come back up and let me change this over into x plus 4. And actually, I'm just going to rewrite this. So f of x equals 1/2 times the quantity x plus 4, quantity squared, and then minus 1. Okay, let me get rid of this. Now, if you're going to use graphing transformations, again, comparing this to g of x is equal to x squared, well, again, you have on the inside, you want to undo what's being done to x. Well, I have x plus 4, so I need to subtract away 4 to undo that. So the first thing is we're going to shift left by 4 units. Second thing, again, now we're dealing with the vertical. When you deal with vertical, again, you're going to follow the order of operations. So the multiplication by 1/2 is done first, followed by subtracting away 1. What happens when you multiply by 1/2? Again, you could say there's a vertical compression by a factor of 2, or you could say there's a vertical shrink by a factor of 1/2. Again, different terminology, same meaning. So I'm just going to say that there's a vertical compression by a factor of 2. So that means you can take the y value and divide it by 2 or multiply by 1/2, whatever you want to do. Then the third thing is we're going to shift down by, let me make this better, 1 unit. So that's coming from the minus 1 there. So if you have some x comma y, that's from g of x equals x squared, that's going to go to, well, for the x, you're just shifting left by 4 units. So that's x minus 4. For the y, there's a vertical compression by a factor of 2, so that's y over 2, and then you're shifting down by 1 unit, so then minus 1. So let me go ahead and grab this and come down here. We know what the vertex is. Let me just erase this. I'm going to paste this in right there. Come back and paste this in here so we have a little labeling going. So I'm just going to arrow to that. So let's just start with some points that we know. Again, if you have something like 0, 0, what is that going to go to? Well, 0 minus 4 is negative 4. And then 0 over 2 would be 0. And then minus 1 would be negative 1. Again, 0, 0, which is the vertex on g of x equals x squared, is going to go to negative 4, negative 1. Again, we already found that that was the vertex, and we can see that clearly there. Now, here's where things get a little bit tricky. Normally, we use negative 1, 1 and 1, 1, but because of this dividing by 2 here, you're going to get a non-integer value. Now, you can still do it. So negative 1, 1, if you go negative 1 minus 4, that's negative 5. And then y would be 1 here. So 1 over 2 is 1/2. And 1/2 minus 1, you can go 1/2 minus 2 over 2. That's going to be negative 1/2. So negative 1/2. And then for this one, if you have 1 minus 4, that's negative 3. And then again, you would have this negative 1/2 for the y value. I don't have that done here, but if you look, if you go to -5 comma -1/2, that would be right there. So that would be that point. Again, it's not an integer for the y value, so it's something I typically would not do, but we can label that real quick and say that this would be -5 comma -1/2. And then this guy over here, let's see if we can line this up. So this is -3 comma. So this would be -3 comma -1/2. If you want to use that as a point. So in this case, let me just erase this. Again, you can click that link on Desmos if you want to go over something like that. I would go to the next guy that's going to produce an integer. So let's use -2 comma 4 and then 2 comma 4. So -2 minus 4, that's going to be -6. So that's the x value here. And then plug in a 4 here. 4 over 2 is 2. And then 2 minus 1, that's going to be 1. So -6 comma 1. So you can see that point right there. And then this one right here would go to, you have 2 minus 4, that's going to be -2. And then you have 4 over 2, again, that's 2. And then minus 1, that's again 1. So that's your -2 comma 1. Now, when you go to the next ones, again, you're going to have a similar issue. So if you went to -3 comma 9, and you went to 3 comma 9, you're going to get stuff for y that's not an integer. So if you want to avoid that, again, you can just go to the next one, which is -4 comma 16, and then 4 comma 16. And so this one right here, -4 minus 4, that's -8. And then if you do 16 divided by 2, that's 8. And then 8 minus 1, that's 7. So that's your -8 comma 7. And then this one right here, 4 minus 4 is 0. So it would be 0. And then, again, 16 over 2 is 8. 8 minus 1 is 7. So that's where you get the 0 comma 7. So just some things to consider if you don't have an integer for your a value. So something like 1/2. If you're using the step pattern, let me get rid of this. Again, we already know that the vertex occurs at -4 comma -1. I don't need to rewrite that. Again, it's normally 1 comma 3 comma 5 comma 7, so on and so forth. You need to multiply this by positive 1/2. 1 times a half, which is a half. Then you get a half times 3, which is 3 halves. Then you get 5 times a half, which is 5 halves, and you get 7 times a half, which is 7 halves. This might not be so easy to work with. If you start right here, you're basically going to have to go 1 unit to the right, so the x value is -3, and then a half a unit up. So we're back to that point that we found earlier, which let's just say that's right there. That would be your -3, comma, and then you'd have -1/2. Because essentially you're taking the y value, which is -1, you're adding 1/2, so that puts me at -1/2. Then again, you go 1 unit to the right, so now the x value is -2, and you're going to go, the next thing is 3 halves units up. Well, -1/2 plus 3 halves, that's going to put me at 1. So now I get -2 comma 1. So I would probably avoid this and just use graphing transformations for this one, although you can do it if you want. If you wanted to continue, let's say you go 1 unit to the right, so now the x value is -1. Now the next number here, let me mark these two out. I use this one and I use this one. It's 5 halves. So that means I've got to go up by 5 halves. So you go 2 over 2, which is 1 there, plus 5 halves. So that equals 7 halves, which is 3.5. So the y value there would be 3.5. So in other words, I'm going up to this right here. So this would be your point, and that's a terrible color to use. But in this particular case, that would be, let's say, -1 for the x value. Again, just going over by 1 unit. And then we're going up by 5 halves. So that would put me at a y value of 7 halves. The next one, if you mark this one out, let me use a different color there. So let me use this color. You're going up by 7 halves. So now you have 7 halves, basically times 2. So let me cancel this with this and say that would be 7. So the next y value would be 7. Again, I'm going over 1. So now the x value would be 0. And I'm going up to a y value of 7. So here you get the 0 comma 7. Let's say this is x is equal to -4. Again, that's your axis of symmetry. This right here, the x value is -4. We're going to go right here where the x value is going to be 0. So we're going 1, 2, 3, 4 units to the right. So to go over here and get this point, I need to go 1, 2, 3, 4 units to the left. So that gets me that -8 comma 7. Similar thought process. I mean, if you wanted to do this one, so basically you're going 1, 2, 3 units to the right. So over here, you need to go 1, 2, 3 units to the left. So let's just say, I'm going to try to line that up as best as I can. Let's just say that's about right there. So this one would be -7 comma, and then we'll say 7 halves. Let me close that down, and maybe this arrow could be better there. And then for this one, we would go 1, 2 units to the right. So over here, 1, 2 units to the left. Again, so on and so forth. So just my closing thoughts on this. Again, if the coefficient for x squared is not an integer, it's probably better in most situations just to use graphing transformations. This is going to get really, really tedious really quickly. All right, for problem 6, we have f of x equals negative 1/2 x squared minus 3x minus 9 halves. So again, another example where the a value, or the coefficient for x squared, is not an integer. So this makes things a little bit harder to use the step pattern on. So we have something like f of x is equal to a times the quantity x minus h squared, and then plus k, again, where a is equal to the coefficient of x squared, so that's negative 1/2. B is equal to the coefficient for x to the first power, so that's negative 3. H is equal to negative b over 2a. So b here is negative 3, so that's the negative of negative 3. And then the a here is negative 1/2. So 2 times negative 1/2 is negative 1. And so basically you have negative 3 over negative 1, which is 3. And so this would be the negative of 3, which is negative 3. Okay, let me get rid of this and put a negative 3. So k is equal to, you want f of h, which is negative 3. So let's come over here and say f of negative 3. This equals negative 1/2 times negative 3 squared. And then minus 3 times negative 3. And then minus, let me actually scooch this over so it fits. You have your 9 halves. Okay, so negative 3 squared is 9. 9 times negative 1/2 is negative 9 halves. Let's go plus negative here. Negative 3 times negative 3 is 9. So plus 9. And then you have minus 9 halves. What I would do here is just say negative 9 halves minus 9 halves. I'll do that first. So that would be negative 9 minus 9, that's negative 18, over the common denominator of 2. And then you have plus 9. Well, negative 18 over 2 is negative 9. So you get negative 9 plus 9, which is 0. So k is equal to 0 here. And so this, you can just get rid of it. You can put plus 0 if you want. That's really up to you. We know that minus a negative is plus a positive. Let's just go ahead and write this as x plus 3 right now, quantity squared. And the a value is negative 1/2. Okay, so in this particular case, I would just use graphing transformations. It's going to be a lot more straightforward. But if you want to use the step pattern, I'll just show you both, just so it's crystal clear. Again, if you compare this to g of x is equal to x squared, what's happening is horizontally, you're shifting to the left by 3 units. Because again, on the inside, you want to undo things. So we're going to say we're going to shift left by 3 units. And then vertically, you're just going to break this up into 2 things. The negative gives you a reflection across the x-axis. It's a vertical reflection. And then multiplying by 1/2, again, you could say that's a vertical shrink by a factor of 1/2, or you could say it's a vertical compression by a factor of 2. Again, different terminology, same meaning. So vertical compression by a factor of 2. So if you had some x comma y that's on the graph of g of x equals x squared, when you get to f of x equals negative 1/2 times the quantity x plus 3 squared, it's going to be, again, shift left by 3 units, x minus 3. And then here, basically, you'd say that you're going to take your y and divide it by negative 2, or you can just say the negative of y over 2, something like that. So let's close that down. Okay, let's go ahead and grab this. Again, you can just note that the vertex is going to occur at negative 3, 0. Okay, let me paste this in right here. And let me also paste this right here. And I'm just going to label the graph like that. So we know the vertex occurs at negative 3, 0. Again, you can write that out if you want. Not necessary though. Basically, just looking at those points that we know, again, you can go through this really quickly. So something like 0, 0, that's going to go to 0 minus 3 is negative 3. And then the negative of 0 is still 0. 0 divided by 2 is 0. So that's how we get the negative 3, 0. Again, the vertex for g of x equals x squared. The vertex for the f of x equals negative 1/2 times the quantity x plus 3 squared. Okay, when we think about the other points, think about where you're getting y values where you could divide by 2 and you still have an integer. Well, if you do the points negative 1, 1, or 1, 1, that's not going to work. So you'd want to go to negative 2, 4, and then 2, 4, that would work. So here, negative 2 minus 3, that's negative 5. And then the negative of 4 over 2, negative 4 over 2, that's just negative 2. So this right here, it would still be negative 2 for the y value. And then 2 minus 3, that's negative 1. So you're going to have this negative 5, negative 2, and then this negative 1, negative 2. So that's pretty straightforward. Let me get rid of these so I have some room. Again, if you go to the next one, which is negative 3, 9 or 3, 9, you're going to get a non-integer value when you think about y. So I would go to something like negative 4, 16, and then you have 4, 16. Again, it's going to be easier to work with. So negative 4 minus 3, that's going to give you negative 7. And then negative 16 over 2, that's going to be negative 8. And then here, 4 minus 3, that's 1. And again, this would just be negative 8. So that's how you get this negative 7 comma negative 8 and this 1 comma negative 8. So in this particular case, I think graphing transformations would be a better approach, a faster approach. But again, this is all personal preference. If you want to use the step pattern here, you can. It's just much, much more tedious. So you would start with your pattern. So you have the 1, 3, 5, 7, so on and so forth. You're going to take each number here and you're going to multiply by this negative 1/2. So that's your a value. So 1 times negative 1/2 is negative 1/2. Then 3 times negative 1/2 is negative 3/2. And you just continue. So then you'd have negative 5/2 and then negative 7/2. Again, so on and so forth. Let me move this down a little bit. Now let me get rid of this. This is what we're going to be working with. Again, you're always moving 1 unit to the right. You start at the vertex. So we know the vertex is negative 3, 0. So if I'm moving 1 unit to the right, the point I'm going to generate would have an x value of negative 2. What about the y value? Well, you're looking at this right here. And in other words, if it's negative, you're going down. So if I have negative 1/2, well, I'm starting at 0 for a y value. I'm just going down by half of a unit. So 0 minus 1/2 would be negative 1/2. So this is the point that I'm going to be at. So 1 unit to the right, half a unit down, that's going to be right there. Let me see if I can fit that in there. Actually, I should probably make that a little bit smaller. So maybe I'll do it like this. So this is negative 2 comma negative 1/2. Now, I'm going to do that again. I'm going to go 1 unit to the right. So now the x value is negative 1. And then my y value, well, right now it's negative 1/2. This right here is the next number in that pattern. So you're going to take that negative 1/2 and you're going to subtract away 3/2. So this becomes negative 1 minus 3. That's negative 4. And then over the common denominator of 2, negative 4 over 2, that's going to be negative 2. So the y value is negative 2. So close that down there. And you can see that we already have that point labeled. So 1 unit to the right, and then you're going to go down by 3/2. So that's going to put me right here. So I'm at that negative 1 comma negative 2. Okay, let's go to the next one. I'll just mark this one out. So now we're at negative 1 comma negative 2, 1 unit to the right. So that means the x value would be 0. And then the y value, now you've got to do negative 2, and then minus this 5/2 here. Get a common denominator. Let's write this as negative 4 over 2. And so negative 4 minus 5, that's negative 9, over the common denominator of 2. So that's negative 9/2. You could also write that as negative 4.5. So let's put 0 comma negative 9/2 there. And that's going to be, let me pick a good color here. Let's just say it's about right there. Not going to be perfect. Let's slide that over there. Actually, I can make this smaller. So let's say that this right here would be 0 comma negative 9/2. And again, let's just do one more of these. Let me mark this one out. Now you have negative 7/2. So 1 unit to the right. So now the x value would be 1. Let me just write this out. And the y value would be, you have this negative 9/2, and you're subtracting away 7/2 because you're going down by 7/2. So this would be equal to negative 9 minus 7, that's negative 16, over the common denominator of 2. So negative 16 over 2, that's going to be negative 8. Okay, so this would be 1 comma negative 8. And again, we already have that point right there. Okay, so once you have these points, again, you can just use your axis of symmetry. You would have x equals negative 3. Let me go ahead and sketch that in. So this is my x equals negative 3, my axis of symmetry. So again, if I have this point right here, and this labeling here is probably going to get in the way. So let me change that up. I'll just label it like that. So this point, which I'm going to draw in, let's say right here, you could get that by saying, okay, if I'm right here, my x value is negative 3, I would go 1 unit to the right to get to this point right here where the x value is negative 2. Well, if I'm here, I want to go 1 unit to the left to get this point right here. So that means that this point would be negative 4 comma negative 1/2. It has the same y value. So negative 4 comma negative 1/2. Okay, so coming to right here, let's say, and let me put a little dot there for clarity. I don't know if it shows up. Maybe I'll use a different color for that one, and I'll change to this color and put it there. So for this one, again, the x value is negative 3. I'm going to go 1, 2 units to the right to get there. So over here, I would go 1, 2 units to the left. So I get my negative 5 comma negative 2. Then coming down, it looks like we have this point right here. Let me try to line that up. It's not going to be perfect. Let's just say that's about right there. So I would go 1, 2, 3 units to the right to get here. And so I want to go 1, 2, 3 units to the left to get there. And that color does not show up so well. So let me redo that. So this would be negative 6 comma negative 9/2. So negative 6 comma negative 9 halves for that point right there. And then just coming down, let's do this one right here. So again, you would go 1, 2, 3, 4 units to the right to get to this 1 comma negative 8. And so I would match that and go 1, 2, 3, 4 units to the left to get to this negative 7 comma negative 8. So once again, I think that it's a lot more tedious when you have something that's not an integer here. And I would probably say that graphing transformations is a better approach in that scenario. All right, now let's change things up a little bit. So for the instructions, we're asked to find the equation of the parabola in vertex form. All right, so this is going to be for problem 7. And what we're given here is this graph, and we want to figure out the vertex form of this guy. So remember that is going to be f of x is equal to a times the quantity x minus h squared, and then plus k, where this vertex is going to occur, let me fix that, at h comma k. Well, we can see clearly the vertex is at 3 comma 0. So that's something we already know, so we can fill that in. The vertex, again, the h is 3 and the k is 0. So let me write this a little bit lower. We'll say f of x is equal to, I still don't know what a is, but I'll show you how to get that in a moment, times the quantity x minus your h is going to be 3. So this is squared for that quantity, and then plus your k is 0. Now you can leave off the plus 0. You don't need it. You can put it there if you want. It's not going to hurt anything, but I would just get rid of it. Now how do we figure out what a is? Well, what you're going to do is you're going to replace f of x with y, and then you're just going to pick a point that is not the vertex. So don't pick 3 comma 0. You can pick 4 comma 1, 5 comma 4, whatever else you want. Just don't pick the vertex. And you're going to plug in for x and plug in for y, and that will allow you to solve for a. In other words, if I pick something like, let's say 4 comma 1, I know that this is x and this is y. Well, I can replace the x here with a 4, and I can replace the y here with a 1, and so now I can solve for a. So this is going to be really quick. 4 minus 3 is 1, and then 1 squared is 1. So this would be a times 1, which is just a. So you end up with 1 equals a, or you could say a equals 1. Let me just flip this around and say a is equal to 1. So once you have that information, you're ready to write this guy in vertex form. So let's say that this graph is going to be f of x equals, your a is 1, so you can just get rid of that. So then you have your quantity x minus your h is 3, and this is going to be squared for the quantity. And then again, instead of putting plus 0, because your k is 0, you can just get rid of that. So you could really say this is f of x is equal to the quantity x minus 3 squared. All right, for problem 8. Again, we're given this graph, and we want to figure out what is the function here. So f of x equals a times the quantity x minus h squared plus k. So we want this in vertex form. So at this point, we know the vertex. That's going to be 4 comma negative 2. So let me just write here that we have f of x is equal to a times the quantity, x minus, again, the h value is 4. So this is quantity squared. And then plus the k value is negative 2. So instead of plus negative 2, let's just write minus 2. And again, if you want to figure out what a is, you're just going to plug in. Replace f of x with y first, and then pick a point that is not the vertex. So you can pick this one, or this one, this one, this one. Just don't pick the vertex. Let's just go with 6 comma 2. So we're going to plug that in. So for y, you're going to plug in a 2, and this equals a times the quantity. For x, you're going to plug in a 6. So 6 minus 4, quantity squared, then minus 2. Well, 6 minus 4 is 2, so you would get 2 is equal to a times, you would have 2 squared minus 2. 2 squared is 4. So this would end up being 4a minus 2 like that. Let's add 2 to both sides. This would cancel, and you would get 4a is equal to, 2 plus 2 is 4. So let's divide both sides by 4. This would cancel. You're going to get a is equal to 1. So let me erase this and put f of x here. We know that a is equal to 1, so you can just erase this here. So this guy right here is going to be f of x equals the quantity x minus 4 squared minus 2. All right, for problem 9. Now we're not given a graph. We're just told that the vertex occurs at negative 5 comma negative 5, and the point is negative 4 comma negative 7. So again, you could just use f of x is equal to a times the quantity x minus h squared plus k. Plug in for the vertex. So let me go ahead and just write this as y is equal to a times the quantity. X minus a negative 5, you could write x plus 5, again, quantity squared. And then plus negative 5, let's just write minus 5. And then just take this point right here and plug in. So this is the x and this is the y. So for y, you're plugging in a negative 7. And then for x, you're plugging in a negative 4. So what is negative 4 plus 5? That's positive 1. 1 squared is 1, so you can just get rid of this. So let's just go ahead and add 5 to both sides of the equation. This would cancel. And so you would end up with a is equal to negative 7 plus 5, that's negative 2. So a is equal to negative 2. Let me just write that right here. So a is equal to negative 2. And again, you can just fill this in. So f of x is equal to negative 2 times the quantity. Again, x minus a negative 5 is x plus 5. Again, this is quantity squared. And then you'd have your negative 5 for k. So let's go minus 5. So this would be your function in vertex form. F of x equals negative 2 times the quantity x plus 5 squared minus 5. All right, for problem 10, we're told that the vertex is negative 2 comma 1, and that a point on the parabola is 2 comma 7. Again, for this problem, I would just set up f of x is equal to a times the quantity x minus h squared, and then plus k. So I'm just going to keep this here. I'll just write underneath it. We'll say f of x is equal to, we don't know what a is, so this is times the quantity. You have x minus h squared. H here, again, is going to be negative 2. So you're getting that from the vertex. It's the x coordinate. So you have x minus a negative 2, so that's x plus 2, and this is quantity squared. Then plus, your k here is 1. So now we just have to solve for a, and to do that, you can erase f of x and just put y in its place. And you use the point that you're given. So this is 2 comma 7. This is your x. This is your y. So in the place of x, just plug in a 2. In the place of y, just plug in a 7. So you'd have 2 plus 2, which is 4. So this would be 4 squared, which would be 16. So let's write this as 16a right here. I'm just going to subtract 1 away from each side of the equation. So this would cancel. Let's say that we have 16a is equal to 7 minus 1 is 6. Let's go ahead and divide both sides of the equation by 16. And let's say that this would cancel with this. And so now you have a is equal to, well, if you think about 6 and 16, they're each going to be divisible by 2. So 6 divided by 2 is 3, and 16 divided by 2 is 8. So a here would be equal to 3/8. And let me come back and just paste that right there. And again, we can just fill this out. So for a, you want to put 3/8 there. For h, again, it's negative 2, but this is x minus a negative 2. So let's write that as x plus 2. So again, this is a quantity being squared. And then your plus k, again, k is 1. So here the vertex form would be f of x equals 3/8 times the quantity x plus 2 squared plus 1. All right, let's take a look at the practice tests where the instructions were asked to find f of k. All right, before I get into the problems, I just want to remind you of what we talked about in the lesson. So what is the remainder theorem? How do we use it to find f of k? So going back to something very basic. So if you go into your elementary school mode, let's say I asked you for something like 7 divided by 2. You would set it up like this. 2 goes into 7 3 times. 3 times 2 is 6. Subtract 7 minus 6 is 1. This 1 right here is known as the remainder. In other words, if I was to take 7 of whatever it is, let's say it's boxes. Let me draw out 7 boxes. And I'm going to split this up into equal groups of 2. So I'm going to make one group, second group, third group. Well, what happens is, let's label this. This is 1, 2, and then 3. I don't have enough for a fourth group. So I'm going to have some amount that's left over. Let me do this in a different color. So I'll put this one in a green. This right here, you really could say it's half of a group. That's how we get the answer of 3.5. But for right now, let's just leave it as saying that this would be the amount left over. So it's a remainder of 1. So the answer here would be 3. In other words, I have 3 equal groups of 2 and then 1 left over, or a remainder of 1. So we could say that 7, which is the dividend here, is equal to, you have your 2, which is the divisor, times 3, which is the quotient, plus your remainder, which is 1. So that's one way you could write this. So 2 times 3 is 6. Again, that's this part right here, plus 1. That's this part right here. That's the amount left over. So hopefully you know that from elementary school. Let me get rid of this. What I'm going to do is just relate this to a polynomial function. So let's say you have some polynomial function. Let's just call it f of x. You can say this is equal to, you're going to have your divisor. In this case, we're going to call that x minus k. And then times your quotient. So we're going to call that q of x. And then plus your remainder. We're going to call that r. So I can get rid of this now. We're just using that to show where this is coming from. What we want to do is establish that with this form right here, we can plug in a k for x, and we're going to be left with the remainder r. So that's the remainder theorem. So if I said, what is f of k? This is equal to plug in a k for x. This is k minus k, and then times q of k, and then plus r. Well, of course, k minus k is 0, and 0 times anything is going to be 0. So this becomes 0 plus r, which is r. So in other words, we can just do a division if we're trying to find out what is f of k. We're just looking for r, the remainder. Now, because this is in the form of x minus k, we can use synthetic division. So that's what we're going to be doing here. All right, let's take a look at the first problem. So we have f of x equals 4x to the 6th power minus 2x to the 5th power minus 6x cubed minus x squared plus 2x plus 1. We're given a k here that's equal to negative 1. So we're trying to find what is f of k. In other words, what is f of negative 1? Now, of course, you could just plug in. So you could just say, well, what is f of negative 1? And you could say this is equal to 4 times, you have negative 1 to the 6th power, and then I'm going to go plus negative 2, and then times negative 1 to the 5th power, and then I'm going to go plus negative 6 here, and then times negative 1 cubed, and then we're going to have minus, let's go plus negative 1, and then for x squared, I'm going to plug in a negative 1 squared, and then you have plus, you have your 2 times x, so that's 2 times negative 1. Let me write that down here. So 2 times negative 1, and then you have plus 1. Well, for negative 1 to the 6th power, that's 1. So you would have 4 times 1, which is 4. And then here, negative 1 to the 5th power, that's negative 1. And then negative 1 times negative 2, that's positive 2. Here, negative 1 cubed, that's negative 1. Negative 1 times negative 6, that's plus 6. And then here, negative 1 squared, that's 1. 1 times negative 1 is negative 1. And then you have plus 2 times negative 1, that's negative 2. Let's just write that as negative 2. And then you have plus 1. So if we go through here, 4 plus 2 is 6, 6 plus 6 is 12, 12 minus 1 is 11, and then 11 minus 2, that's 9, and then 9 plus 1, that's going to be 10. So that tells me that f of negative 1 is equal to 10. Now the other way that we can figure that out is just by doing a division and looking at the remainder. So let me write here that this is 10, that's what we're expecting. And we can just do a synthetic division. Again, we're doing f of x divided by x minus k. So let's just set this up. Our k is negative 1, so that goes outside here. And then when you look at this guy right here, again, you're just grabbing the coefficients. You need to make sure that if you're missing any powers of x, or if you're missing your constant, that you use 0 as a placeholder. So if I look through here, I have x to the 6th power, x to the 5th power. I do not have x to the 4th power. So I need to put 0 in as the coefficient for that. I have x cubed, x squared, x to the 1st power, and I have a constant. So I'm going to start with a 4. That's the coefficient for x to the 6th power. You take the sign with this, so this would be a negative 2. As the coefficient for x to the 5th power. Again, I'm missing x to the 4th power, so I'm going to put in a 0. I'm going to take that negative 6 as the coefficient for x cubed. I'm going to put in a negative 1 there, so that's clear, as the coefficient for x squared. So let's write that in. And then you have a 2 there as the coefficient for x to the 1st power, and then you have a 1. And for the synthetic division, all you're doing is you're dropping this down here. So 4 comes down, and then you're doing a multiplication, then an addition. Multiplication, then addition, until you get to the end. So negative 1 times 4 is negative 4, and then you add. Negative 2 plus negative 4, that's negative 6. Multiply. Negative 1 times negative 6, that's 6. Then you add. 0 plus 6 is 6. Multiply. Negative 1 times 6, that's negative 6. Add. Negative 6 plus negative 6, that's negative 12. Multiply. Negative 1 times negative 12, that's going to be positive 12. Then you add negative 1 plus 12, that's going to be 11. Multiply. Negative 1 times 11, that's going to be negative 11. Then you add 2 plus negative 11, that's going to be negative 9. Then you multiply. Negative 1 times negative 9 is going to be positive 9. And then you add 1 plus 9 is 10. So when we look at this final entry right here, which is 10, that's going to be the remainder. So we don't really care about anything else. We only care about this remainder here, the final entry. And so if you're trying to find f of negative 1, again, you can do the synthetic division, find it that way as 10, or you can use the plug-in method. In a lot of cases, this synthetic division, especially as you get into harder examples, it's going to save you a ton of time. All right, let's look at problem 2. So here we have f of x equals x to the 6th power plus 5x to the 5th power plus 4x to the 4th power minus 4x cubed plus 6x squared plus x minus 4. The k here is negative 3. So I'm looking through here and I have x to the 6th power, 5th power, 4th power, cubed, squared, 1st power, and then a constant. So I'm not missing anything. So I'm just going to take the coefficients and set this up. So this is a 1, and then this would be a 5, this would be a 4, this would be a negative 4. Again, always take that sign with you. This would be a 6, this would be a 1, and this would be a negative 4. So let me set this up like that. And then let's put the negative 3 right there. We'll bring this down, and we'll start, again, we're just going to multiply, then add. Multiply, then add, until we get to this final guy here, and this would be our remainder. So that's going to tell us what f of -3 is. Again, we're looking for f of k. K is -3. So let's multiply. -3 times 1, that's -3. And then we're going to add 5 plus -3, that's going to be 2. So let's continue. -3 times 2, that's going to be -6. 4 plus -6, that's going to be -2. Then -3 times -2, that's going to be 6. -4 plus 6, that's going to be +2. -3 times 2, that's going to be -6. 6 plus -6 is 0. -3 times 0, that's going to be 0. 1 plus 0 is 1. Then -3 times 1 would be -3. And then -4 plus -3, that's -7. So again, this guy right here is going to be your remainder. It's always the last entry right there. So that's what we want to know. We don't care about any of this other stuff. We're just going to say that f of -3, that's your k, is equal to -7 by the remainder theorem. All right, for problem 3, we have f of x equals x to the 5th power minus 4x to the 4th power plus 5x squared plus 3x plus 2. Your k here is 3. We're trying to find f of 3. So again, if you look through here and you're missing a power of x or you're missing a constant, put in 0 as a placeholder when you're writing in these coefficients. You do not have x cubed here. You have x to the 5th power, x to the 4th power, x squared, x to the 1st power, and a constant, but you're missing x cubed. So when you set this up, this is going to be a 1. You'll have this as a -4. Again, take the sign with you. You're missing x cubed, so put in a 0. Then you have a 5, you have a 3, and then you have a 2. So let me put this 3 here. And then again, to get started, you're going to bring this down, and then you're going to multiply, then add. Multiply, then add. That's all you're doing. So 3 times 1 is 3. -4 plus 3, that's going to be -1. Then 3 times -1, that's going to be -3. And then 0 plus -3, let me fix this, that would be -3. And then 3 times -3, that is -9. 5 plus -9, that's -4. And then 3 times -4, that's going to be -12. 3 plus -12, that's -9. And then 3 times -9, that's going to be -27. And then 2 plus -27, that is -25. So this right here is going to be your remainder. And so we can say that f of 3 is going to be equal to -25. All right, for problem 4, we have f of x equals 2x to the 4th power minus 3x cubed minus 6x squared minus 1. We're given that k is equal to 2. So again, I'm just going to set up my synthetic division. Now you'll notice that you're missing x to the 1st power. So again, you want to put 0 in as a placeholder when you set up those coefficients. So this one right here is a 2. Then this one, we're going to take the sign with us. So that's -3. We have -6 here. And then we're missing, again, x to the 1st power. So put in a 0 for that. And then you have your -1. So let's put this like this. You want to put your 2 out here. And then what we're going to do is just drop this down, and let's go ahead and get started. So we're going to multiply, then add, so on and so forth. So 2 times 2 is 4, and then you add -3 plus 4 is 1, 2 times 1 is 2, -6 plus 2, that's -4, 2 times -4 is -8, 0 plus -8 is -8, and then 2 times -8 is -16, -1 plus -16 is -17. Again, this final entry right here, this is going to be your remainder, and so that's what we're interested in. So let's go ahead and say that f of k, again, k is 2 here, so f of 2 is equal to this remainder, which is -17. All right, for problem 5, we have f of x is equal to x squared minus 5x plus 1, and then your k is equal to 2 plus I. All right, so what I'm going to do here is just set this up. So you have x squared, x to the 1st power, and a constant, so you're not missing anything. The coefficient for x squared is 1. Then this, I'm going to take the -5, and then this is a 1 here. And then this k right here is 2 plus I. So although it's a little bit more tedious, you're really going to use the same approach. Let me actually space this out a little bit more because we need the room. So this was -5 and this was 1. Let me actually put this in the middle like this. So I'm going to drop this down and then I'm going to multiply. So 2 plus I times 1 is just 2 plus I. So 2 plus I. So here's where we probably have to do some scratch work. So we're going to do -5 plus 2 plus I. Well, here you're just going to add the real parts. So -5 plus 2, that's going to be -3, and then plus I. So this would be -3, and then plus I. Okay, let me erase this. So now you're going to multiply this times this. So you have 2 plus I times -3 plus I. So let's start with the first. 2 times -3, that's -6. The outer, 2 times I, that's 2I. And then the inside, I times -3, that's -3i. And then the last, I times I, that's I squared, which we know is negative 1. So let's write this as negative 6, and then plus, for I squared, let's write that as negative 1. And then you have 2i minus 3i, that's minus I. So negative 6 plus negative 1, that's going to be negative 7. So let's say this is negative 7 minus I. Okay, so let's put that right here. So this is negative 7 minus I, and now we're just going to add. That's a lot easier. So we have 1, and then plus, you have this negative 7 minus I. So 1 plus negative 7 is going to be negative 6. So this is negative 6 minus I. So negative 6 minus I. So that right there is going to be your remainder. This right here. I know it's more tedious when you have a divisor like this, but it's the same process. So let's come up here and say that f of 2 plus I is equal to negative 6 minus I. All right, for problem 6, we have f of x is equal to x squared minus x minus 4, and then k is equal to 3 minus I. Okay, so coming down here, again, I'm not missing anything here. I have x squared, x to the first power, and then a constant. So we're just going to set this up. Again, you want to give yourself a lot of space for this type of problem. So this is a 1, this is a negative 1, and this is a negative 4. So let me write 1, negative 1, and then negative 4. And let me write 3 minus I right there. And we'll come back up in a moment. So let me drop this down here. So 3 minus I times 1 is 3 minus I. Then if you did, let me do this off to the side here, negative 1 plus 3 minus I, we're just going to add negative 1 plus 3. That's going to be 2. So you just have 2 minus I. So that's going to be right here. So 2 minus I. Then you're going to multiply. You're going to have this 3 minus I times 2 minus I. So 3 times 2, doing the first guys, that's going to be 6. Then the outer, 3 times negative I, that's minus 3i. The inside, negative I times 2, that's minus 2i. And then the last terms, you have negative I times negative I. We could say that's plus I squared. Now again, I squared is negative 1. So you can say that this is equal to 6. You can go plus negative 1 or just minus 1. And then negative 3i minus 2i, that's going to be negative 5i. And of course, 6 minus 1 is 5. So you get 5 minus 5i. And let's write 5 minus 5i right there. And now I just want to do negative 4 plus 5 minus 5i. And of course, negative 4 plus 5, that's 1. So you just get 1 minus 5i. So we'll write that right there. So 1 minus 5i. That's, of course, going to be your remainder. So this is what we're looking for right there. And so when we say we want f of k, where k is 3 minus I, this would be equal to this remainder right here. Let me slide down a little bit more and move this here. So this would be 1 minus 5i. All right, so now we want to change things up a little bit in terms of the instructions. So we want to determine if k is a 0. So what does it mean when we have a 0? Well, if we have some function, let's call it f of x, and we set this equal to 0, and we solve, well, the x values that make that true are going to be called zeros. So if we go back to our form of f of x is equal to, let's say x minus k, where this is the divisor, and then times your q of x, where that's the quotient, plus r, where that's the remainder. Well, again, if you plug in a k for x, so f of k, this gives you k minus k times q of k. And let me fix that. And then plus r. Well, how would I get this f of k being equal to 0? Well, we know this right here would be 0, and we're left with 0 plus r, which equals r. Well, if I want this to be 0, that means that the remainder needs to be 0. So if we want to determine if k is a 0, we're going to do the synthetic division. We're going to look at the remainder, and if that's 0, then that tells me that k is a 0. All right, for problem 7, we have f of x equals x to the 4th power plus 6x cubed plus 12x squared plus 8x minus 1. So I'm not missing anything here. My k value is negative 1, so I'm just going to go straight into my synthetic division. So the coefficient here is a 1, this is a 6, this is a 12, this is an 8, and then this is a negative 1. Okay, let's slide down here and just go through this. I'm going to drop this down, and then again, multiply, then add. Multiply, then add. So negative 1 times 1 is negative 1. 6 plus negative 1 is 5. Negative 1 times 5, that's negative 5. 12 plus negative 5, that's 7. Negative 1 times 7, that's negative 7. 8 plus negative 7, that's 1. So negative 1 times 1 is negative 1. and then negative 1 plus negative 1, that's negative 2. So this right here is your remainder. Now, we're not asked for f of k here. We're asked to determine if k is a 0. In this case, because the remainder is not 0, the answer is no. So f of k, or f of negative 1, is not going to be 0. So we're just going to put no. All right, let's take a look at problem 8. So here we have f of x equals x to the 5th power plus 7x to the 4th power plus 18x cubed plus 20x squared plus 8x. So with this guy right here, you are missing a constant term. So you want to put plus 0 on the end of that. In other words, when you set this part up, this is a 1, this is a 7, this is an 18, this is a 20, this is an 8. And then again, because you don't have a constant term, go ahead and put a 0 there. If you want to add plus 0 there, that's fine as well, but you don't really need to. It's just for the sake of doing the synthetic division. You want to put in a 0 as a placeholder for any missing terms. Okay, so that's what you need. Then the k here is negative 1. So let me come down here and just bring this like this. So we're going to multiply, then add, again, so on and so forth. So negative 1 times 1 is negative 1. 7 plus negative 1, that's going to be 6. Negative 1 times 6, that's negative 6. 18 plus negative 6, that's 12. Negative 1 times 12, that's negative 12. 20 plus negative 12, that's going to be 8. And then negative 1 times 8, that's going to be negative 8. 8 plus negative 8 is 0. And then negative 1 times 0 is 0. 0 plus 0 is 0. So this right here is your remainder. Again, if the remainder is 0, then that means that this k value here, negative 1, is a 0. In other words, if I plugged in a negative 1 for x right there, you would get 0 as a result. So since f of negative 1 equals 0, we can say that negative 1 is a 0 here. So we're just going to put yes. All right, for problem 9, we have f of x equals x to the 5th power minus 2x cubed plus x. We're given k here is equal to negative 2. Okay, so to set up the synthetic division, again, you'll notice that you're missing x to the 4th power, x squared, and you're missing a constant term. So with this one, since you're missing so many things, you might want to just rewrite it. So f of x is equal to x to the 5th power. Let's go plus 0x to the 4th power minus 2x cubed. And then plus, we're going to go 0x squared plus x plus 0. Normally, I don't take the time to rewrite it, but because we're missing so many things here, it's very easy to make a mistake. So the coefficient here would be a 1, and then this would be a 0, then negative 2, then you want 0, then this is a 1, and then you have a 0. Okay, let's set this up. So the k is negative 2. And again, once you have that, you're basically good to go. Go ahead and drop this down. Multiply, then add. Multiply, then add. So negative 2 times 1, that's negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2 is positive 4. Negative 2 plus 4, that's going to be 2. Negative 2 times 2, that's negative 4. 0 plus negative 4 is negative 4. Negative 2 times negative 4, that's going to be 8. 1 plus 8 is going to be 9. Negative 2 times 9, that's going to be negative 18. 0 plus negative 18 is negative 18. So the remainder here is not 0. So we know that negative 2 is not a 0. So we're just going to put no. All right, for problem 10, we have f of x is equal to x to the 4th power minus 2x cubed plus 4x squared plus 2x minus 5. The k here is 1 plus 2i. So I'm not missing anything here. So I'm just going to set this up. This one will probably take a good amount of time, but let's just go ahead and say this is a 1, and this is a negative 2, this one is a 4, this one is a 2, and this is a negative 5. Actually, let me space this out a little bit more. I'm just going to redo this because you need a lot of room for this when you're dealing with this kind of number. So let me put a little space there, a little space there, and a little space there. I think that will work out a little bit better for us. So let's put 1 plus 2i like that, and we're just going to drop this down. And let me come down here. And so you're going to multiply first. So 1 plus 2i times 1, that's 1 plus 2i. So here, if you do negative 2 plus 1 plus 2i, you're just going to add negative 2 plus 1. That's going to give you negative 1. So you would have negative 1 and then plus that 2i. So then you have 1 plus 2i times negative 1 plus 2i. Let me do that over here. So 1 plus 2i times negative 1 plus 2i. Okay, so for this one, I would use a formula. So one way you could do this is you could factor out a negative 1 from this one. So you would write it as 1 minus 2i and just put a negative out in front. So this would be equal to, let's go negative 1 times, I'll just wrap this in parentheses. So you're going to square the first guy. 1 squared is just 1. And then minus, you're going to square the second guy. So you're going to go 2 squared, which is 4, and then times I squared. So we know that I squared is -1. So let's write -1 and then times, inside of here you'd have 1, and then if this is -1, -4 times -1 is 4. So let's go plus 4. So this becomes just the negative of 1 plus 4, which is 5, which is -5. So this right here is just going to be -5. That's it. So 4 plus -5 is going to be -1. Then we're going to multiply. So 1 plus 2i times -1. Let me show that. So -1 times 1 plus 2i. This would be equal to -1 times 1 is -1. And then -1 times 2i, that's minus 2i. So let's say that this right here is going to be -1 minus 2i. Now we're adding, so 2 plus -1 would be 1, and then you just have your minus 2i. And now we need to multiply. So we have 1 plus 2i times 1 minus 2i. And again, we can use our formula here. So 1 squared is 1, and then minus this guy squared. So again, you're going to have 4i squared. Well, I squared is -1. So this is 1. Let's go plus -4 times -1. So this equals -4 times -1 is 4. So you have 1 plus 4, which equals 5. So this right here would be 5. And now you have -5 plus 5, which is 0. So the remainder here is 0. So that tells me this 1 plus 2i, that is going to be a 0. So the answer here is yes. All right, let's take a look at the practice test, where the instructions were asked to determine if g of x is a factor of f of x. All right, let's quickly review the factor theorem before we get into the problems. So one easy way to think about this would be just to go back to whole numbers. Let's say you take a number like 10, and let's just divide it by 2. So we know that 10 divided by 2 is exactly 5. In other words, there's no remainder. So 2 goes into 10 5 times. 5 times 2 is 10. Subtract here, 10 minus 10 is 0. So we know that we could write 10 as being equal to, again, 2 times 5. Well, looking at it this way, what can we say about 2 and 5? Again, when we work with multiplication, these guys are known as factors. They are multiplying together to give me this 10 here, which is the product. So these guys are called factors. In terms of division, you can also call them divisors. And I don't mean like the divisor here, because this right here, when you do the division, this is called the dividend, this is the divisor, and this is the quotient. But you can also use the word divisor to mean that when you do the division, you do not get a remainder. In other words, I can say that 2 is a divisor of 10 because when I divide 10 by 2, I get exactly 5, no remainder. I could say that 5 is a divisor of 10 because when I divide 10 by 5, I get 2, no remainder. Now let's say that we increase 10 by 1. So now the dividend would be 11. So we have 11 divided by 2. And then again, this 2 is still called a divisor here, but it's not going to be a divisor of 11. So you just have to separate that in your mind. So 2 goes into 11 5 times. 5 times 2 is 10. Subtract here, 11 minus 10 is 1. So again, this right here, this is your remainder. So a remainder of 1. So now if I go to write this, I would say 11 is equal to, well, still 2 times 5. But that's only going to get me to 10. So I need to add 1, again, that leftover amount. So can I say that 2 is a factor of 11? No. Can I say 5 is a factor of 11? No. Again, 2 times 5 is giving me 10. It's not giving me 11. I need 2 times 5, and then I have to add 1. So these are not factors. And you can tell that they're not factors because, again, you have this plus 1 here. You have this remainder. So if I divide 11 by 2, I get 5 with a remainder of 1. If I divide 11 by 5, I'm going to get 2 with a remainder of 1. So we can say that 2 is not a divisor of 11 because when you do the division, you get a remainder. You could say that 5 is not a divisor of 11 because, again, when you do the division, you get a remainder. So let's erase this. And now let's do this with a polynomial function. So I'm just going to make a simple little example. Let's say we do something like x minus 3. That quantity has a quantity 2x minus 5. So multiply this out. So x times 2x, that is 2x squared. The outer would be negative 5x. The inner would be negative 6x. So negative 5x minus 6x, that is negative 11x. And then the last, negative 3 times negative 5, that is plus 15. Okay, so if we think about it, this right here is a factor, and this right here is a factor, because again, these guys are multiplying together to give me this. So I'm just going to say that these guys are factors. But again, we could also call them divisors. In other words, when I go through and I say 2x squared minus 11x plus 15 divided by x minus 3, that's going to give me exactly 2x minus 5 with no remainder. If I said 2x squared minus 11x plus 15 divided by 2x minus 5, I'm going to get exactly x minus 3 with no remainder. So if you do the division and you don't have a remainder, you know that your divisor in that case is a factor. So in other words, if I did this with synthetic division, let's say we divide by x minus 3, so 3 is the k value there, and then here, this would be a 2, this would be a negative 11, and this would be a 15, where you're going to see that you're going to get no remainder. This drops down. 3 times 2 is going to be 6. Negative 11 plus 6, that's going to be negative 5. 3 times negative 5 is negative 15. 15 plus negative 15 is 0. Notice how there's no remainder here. And again, this would tell us that this is 2x minus 5, which is exactly what we have right there. So if you do the division, again, in this case, we're dividing by x minus 3, and you get no remainder, then you know that this guy is a factor of this guy. So that's all we're really doing here. Now, alternatively, let's say that we change the problem up slightly. And we said that instead of this, we would go 2x squared minus 11x. Instead of plus 15, let's just go plus 16. So we could just write this as the quantity x minus 3 times the quantity 2x minus 5. And then you could just go plus 1, because all I did was I added 1 over here, and I'm adding 1 over here. So looking at it this way, you can immediately tell that x minus 3 is not a factor of this, and 2x minus 5 is not a factor of this, because again, there's a remainder out here. If you did the division now, let's say you put 3 here, and you put a 2, a negative 11, and a 16. Well, again, drop down the 2. 3 times 2 is going to be 6. Negative 11 plus 6 is negative 5. 3 times negative 5 is negative 15. 16 plus negative 15 is going to be 1. This right here tells you that there's a remainder, and so this is not going to be a factor of this. All right, for problem 1, we have f of x is equal to x to the 4th power plus 2x cubed plus x plus 2. Notice here we're missing x squared. So when we set up the synthetic division, you need to put in a 0 as the coefficient for that. And then here we have g of x is equal to x plus 1. When you do the synthetic division here to see if g of x is a factor of f of x, remember it has to be in the form of x minus k. So I'm going to say that g of x is equal to, instead of x plus 1, I want x minus a negative 1. So this right here is going to match with this right there. That way you can take the k value as negative 1. That's what you want. So when I set up the synthetic division, you're going to put negative 1 out here, and then you're just going to grab your coefficients here. So you have a 1 as the coefficient of x to the 4th power, a 2 as the coefficient for x cubed. You do not have x squared, and again, don't forget that you have to put in a 0 as a placeholder. Then you have a 1 as the coefficient for x, and then a 2 as the constant. Okay, from here, we're just going to do a synthetic division, and again, if the remainder is 0, that tells us that g of x is a factor of f of x. Let's go ahead and drop this down right here, and then we're just going to go through. So we're going to multiply, then add, until we get to the end. So negative 1 times 1 is negative 1. 2 plus negative 1 is 1. Negative 1 times 1 is negative 1. 0 plus negative 1 is negative 1. Negative 1 times negative 1 is 1. 1 plus 1 is 2. Negative 1 times 2 is negative 2. 2 plus negative 2 is 0. So this right here is a 0. So for this one, I would just answer yes. Your g of x is going to be a factor of f of x. All right, for the second problem, we have f of x is equal to x to the 4th power minus 2x cubed minus 64x plus 128, and then g of x is equal to x minus 2. So if this already matches the form of x minus k, you're okay. So you have x minus 2, so here k is 2. So we're just going to set up the synthetic division. We're going to put a 2 here, and then we're going to take our coefficients. So we're going to take a 1 as the coefficient for x to the 4th power, a negative 2 as the coefficient for x cubed, a 0 as the coefficient for x squared because we're missing that, a negative 64 as the coefficient for x to the 1st power, and then 128 as our constant. Okay, so once you have this set up, again, just drop this down here and just get started. Again, you're just going to multiply, then add, until you reach the end. Okay, so 2 times 1 is going to be 2. Negative 2 plus 2, that's 0. 2 times 0 is 0. 0 plus 0 is 0. 2 times 0 is 0. Negative 64 plus 0 is negative 64. And then 2 times negative 64 is negative 128. And obviously 128 plus negative 128, that is 0. So this guy right here is a 0. That means we don't have a remainder. So we can say that, yes, your g of x is going to be a factor of f of x. All right, for problem 3, we have f of x is equal to x to the 5th power minus 2x to the 4th power plus 5x cubed minus 10x squared plus 6x minus 12, and then g of x is equal to x plus 3. As we talked about before, you want x minus k. This is x plus 3, so you've got to convert it over. So we're going to say g of x is equal to, you're going to want x minus a negative 3 here, so your k is negative 3. Go ahead and set up your synthetic division. Put the negative 3 out in front. Let me put that like that. And then you're just going to grab these coefficients. So it looks like in this case, I'm not missing anything. Coefficient for x to the 5th power is 1. The coefficient for x to the 4th power is -2. The coefficient for x cubed is 5. The coefficient for x squared is -10. The coefficient for x to the 1st power is 6. And then the constant is -12. Let's go ahead and drop this down here. Put the 1. Again, we're going to multiply, then add. Multiply, then add, till we reach the end. So -3 times 1 is -3. -2 plus -3 is -5. -3 times -5 is +15. 5 plus 15 is 20. -3 times 20 is -60. -10 plus -60 is -70. -3 times -70 is going to be +210. Then 6 plus 210 is 216. And then -3 times 216, that's going to be -648. And then -12 plus -648, that's going to be -660. So obviously this is not 0. So we can say that the answer here is going to be no. G of x is not a factor of f of x. All right, for problem 4, we have f of x is equal to x to the 5th power minus 5x to the 4th power plus 11x cubed minus 55x squared plus 18x minus 90. G of x is equal to x minus 5. So again, if this is already in the form of x minus k, we're good to go. We could just take 5 as the k. So let's put that out in front. And then we're not missing anything here. So the coefficient for x to the 5th power, that's 1. The coefficient for x to the 4th power, that's -5. The coefficient for x cubed, that's 11. The coefficient for x squared, that's -55. The coefficient for x to the 1st power is 18. And then the constant is -90. Let's go ahead and drop that 1 down. And so 5 times 1 is 5. -5 plus 5 is 0. 5 times 0 is 0. 11 plus 0 is 11. 5 times 11 is 55. -55 plus 55 is 0. 5 times 0 is 0. 18 plus 0 is 18. 5 times 18 is 90. -90 plus 90 is 0. So again, because the remainder here is 0, we can conclude that g of x is a factor of f of x. So let's just put yes here for the answer. All right, for problem 5, we have f of x is equal to x to the 4th power plus 8x cubed plus 13x squared minus 16x minus 30. G of x is equal to x minus 1. So looking at this guy, we already have the form x minus k. K here would be 1. So let's put that out in front. And then basically we're just going to take these coefficients. So we have 1 as the coefficient for x to the 4th power. We have 8 as a coefficient for x cubed. We have 13 as a coefficient for x squared. We have -16 as a coefficient for x, and then -30 as the constant. Okay, let's go ahead and drop this down. 1 times 1 is 1. 8 plus 1 is 9. 1 times 9 is 9. 13 plus 9 is going to be 22. 1 times 22 is 22. -16 plus 22, that's going to be 6. And then 1 times 6 is going to be 6. -30 plus 6, that's going to be -24. So again, if this guy right here is not 0, which is not in this case, it's -24. And so that tells us that g of x is not a factor of f of x. So we're just going to put no. All right, for problem 6, we have f of x is equal to x to the 4th power plus 2x cubed plus 27x plus 54. And then g of x is equal to x plus 3. Again, this right here, you need the form of x minus k. So we're going to rewrite this and say g of x is equal to x minus a -3, and the -3 here is going to be your k. So that's what you're looking for. Okay, so let's set up the synthetic division. So let's go ahead and say that -3, again, the k value is out here, and then underneath you have a 1 as the coefficient for x to the 4th power. You have a 2 as the coefficient for x cubed. You're missing x squared, so we're going to put a 0. And then for x to the 1st power, we have 27, and then the constant, we have 54. Drop this down. So we have a 1 down there. And then multiply. -3 times 1 is -3. 2 plus -3 is -1. -3 times -1 is +3. 0 plus 3 is 3. -3 times 3, that's going to be -9. 27 plus -9, that's going to be 18. And then -3 times 18, that's going to be -54. And then 54 plus -54 is 0. So again, if this guy right here is 0, you don't have a remainder. And we can conclude that, yes, your g of x here is a factor of f of x. All right, for the next few problems, we're going to change up the instructions slightly. So now we say that f of k is equal to 0, so that's given to us, and we just want to factor each. So for problem 7, we have f of x equals x cubed minus 7x plus 6. We're given k, which is a 0 here, as being equal to -3. So what we're going to do is say that this is -3 out here. So again, that's your k. I already know that this is going to give me a remainder of 0, but I want the actual quotient here. That's what I'm going to be looking for. So I'm looking at the coefficient for x cubed, that's 1. I'm looking at x squared, which is missing, so the coefficient there would be 0. I'm looking at the coefficient for x to the first power, which is -7, and then the constant is 6. Okay, let's do this synthetic division and we'll come back up. So this is going to get dropped down here, and then we're going to multiply. So -3 times 1 is -3. 0 plus -3 is -3. -3 times -3 is +9. -7 plus 9, that's going to be 2. And then -3 times 2, that's going to be -6. 6 plus -6 is 0. So we already knew that the remainder would be 0 because we were told that this was a 0. So what we can do is use this to write a quotient. In other words, if I divided my f of x by x minus k, this right here would be the quotient. So we're going to say that it's 1 degree less. We had a third degree polynomial. So this would be for a second degree polynomial. So this would be the coefficient for x squared. So you'd have x squared minus, this would be the coefficient for x, so 3x. This would be the constant, so +2, and then your remainder is 0. So let me erase everything. What you'd want to say is that if you took your f of x, which is equal to x cubed minus 7x plus 6, and you divided it by your x minus k. So when you say x minus k, it's x minus a -3, which is x plus 3. The result would be this x squared minus 3x plus 2. We just did that with synthetic division. So this times this would get me back to this. So all I have to do now is factor this quadratic, which is very easy to do. So let's say that this is equal to, we're going to start with the x plus 3. We already know that. We don't need to do anything there. Let me set up some parentheses for the other guy. So this would be x and this would be x. Give me two integers that sum to -3 and have a product of 2. It's going to be -2 and then -1. So this f of x equals x cubed minus 7x plus 6 is going to factor, let me fix this real quick. So this is going to factor into the quantity x plus 3 times the quantity x minus 2 times the quantity x minus 1. All right, for problem 8, we have f of x equals x cubed minus 2x squared minus x plus 2. The k value here is 2. So we're just going to do the same thing. We're going to use a synthetic division. So this is 2, and then you have 1 as the coefficient for x cubed, -2 is the coefficient for x squared, -1 is the coefficient for x, and then 2 as the constant. Okay, so what I'm going to do here is drop this down and say 2 times 1 is 2, -2 plus 2 is 0, 2 times 0 is 0, -1 plus 0 is -1, 2 times -1 is -2, 2 plus -2 is 0. Again, we already knew there was no remainder. We're just doing this to get our quotient. So because that was a third degree polynomial, this would be 1 degree less. So it would be a second degree polynomial. So this is for x squared. So you have x squared plus, you could say 0x and then -1. Well, 0x, you can get rid of that. You can just say this is x squared minus 1. So what we can say is that if you had f of x is equal to x cubed minus 2x squared minus x plus 2, and you divided it by x minus k, again, k is 2, so x minus 2, this would be equal to x squared minus 1. So let's say this is equal to x minus 2, that quantity times the quantity x squared minus 1. So now all I have to do is factor this one. I think most of you know that this right here is the difference of squares, so you can go ahead and say this is going to factor. Let's write this x minus 2 first, but this guy right here is going to factor into x plus 1, and then times x minus 1. So this f of x equals x cubed minus 2x squared minus x plus 2 is going to end up being factored as the quantity x minus 2 times the quantity x plus 1 times the quantity x minus 1. All right, let's take a look at problem 9. So we have f of x equals x cubed minus 21x minus 20. We have a k value here that is 5. So let's say that we set up our synthetic division. So let's put the 5 there. The coefficient for x cubed, that's 1. The coefficient for x squared is going to be 0, again, because we're missing that term. We have -21 as the coefficient for x, and then we have -20 as the constant. Go ahead and drop this down. And we're going to say 5 times 1 is 5. 0 plus 5 is 5. 5 times 5 is 25. -21 plus 25, that's going to be 4. And then 5 times 4 is 20. -20 plus 20, that's going to be 0. So this right here would be no remainder, which we already knew. So we're going to say that, again, because we started with a third degree polynomial, this right here would be a second degree polynomial. So 1 is the coefficient for x squared, and then plus 5 is the coefficient for x, and then plus your 4. And so what we can say is that f of x is equal to x cubed minus 21x minus 20. If I divided it by x minus k, which in this case it's x minus 5, you would get x squared plus 5x plus 4. So we can say this is equal to x minus 5 times, you have your x squared plus 5x plus 4. Now again, you just want to factor this to complete things. So let me start with x minus 5. We've already got that. This one, let's go ahead and split this up. So we know that this is x and this is x. Give me two integers that sum to 5 and have a product of 4. That's just going to be 4 and 1. So plus 4 and then plus 1. So this f of x equals x cubed minus 21x minus 20. This is going to be equal to the quantity x minus 5 times the quantity x plus 4 times the quantity x plus 1. All right, for problem 10, we have f of x is equal to x cubed minus 7x squared plus 16x minus 12. We're given a k here, which is 2. All right, so once again, let's set up the synthetic division. Let's put a 2 here. And then the coefficient for x cubed is 1. The coefficient for x squared is negative 7. The coefficient for x to the first power is 16. And then the constant is negative 12. Okay, let's go ahead and drop this one down like that. And we're going to multiply. 2 times 1 is 2. Then we're going to add negative 7 plus 2. That's going to be negative 5. 2 times negative 5 is negative 10. Now we're going to add 16 plus negative 10. That's going to be positive 6. 2 times 6 is going to be 12. Negative 12 plus 12 is going to be 0. Again, we knew there would be no remainder. So let's go ahead and write this. Again, this was a third degree polynomial that we started with. So this will be a second degree. So this is x squared minus 5x plus 6. Let's go ahead and say that our f of x is equal to x cubed minus 7x squared plus 16x minus 12. Again, if we divided that by x minus k, so k here's 2. So if we divided it by x minus 2, we would end up with this right here, this x squared minus 5x plus 6. So let's put here x squared minus 5x plus 6. Again, if we multiply these together, we'll go back to this. Okay, so all we have to do at this point is just factor this guy. So let's say this is equal to x minus 2. And then you're going to have to set up some parentheses here. So you put an x here and an x here. What are two integers that sum to negative 5 but have a product of positive 6? Well, that's negative 2 and negative 3. So we end up with x minus 2, that quantity, times the quantity x minus 2, times the quantity x minus 3. If you want to, you can write this as the quantity x minus 2 squared and then times the quantity x minus 3. Let me fix the 3 here. All right, let's take a look at the practice test where the instructions were asked to find the possible rational zeros. All right, before we jump into the first problem, I want to remind you about what we talked about in the lesson. So the Rational Zeros Theorem, or some people call it the Rational Roots Theorem, or you might hear it as the Rational Roots Test. This just gives us a method to determine all the possible candidates for rational zeros when you're working with a polynomial function when you have integer coefficients. Now we're going to see some examples in this practice test where we don't have integer coefficients. It's really easy to modify and work with this formula in that situation as well. So for the Rational Zeros Theorem, you're going to be looking at something called P over Q. So when you think about P, this is a factor of the constant term, and Q, that's going to be a factor of the leading coefficient. So you're just going to list out all the possibilities. It's very, very straightforward. Okay, so if I look at problem 1, I have f of x equals x cubed plus 4x squared plus 5x plus 2. So again, when I think about this right here, this is my constant term, so that's 2. This right here, this is my leading coefficient, so that's 1. So it's going to be the coefficient that is next to your variable raised to the highest power. So if the polynomial function is written in standard form, all you have to do is go all the way right here. So after your equal sign, it's going to be that first coefficient. So that's the leading coefficient. So basically, when you think about P, again, that's going to be factors of this guy right here, this constant. So let's go P over Q like this. So when I think about 2, what are the factors? Well, you just have 2 and 1. And again, you're going to have positive and negative for each of those. So to shortcut that, let's just go plus or minus 1 and then plus or minus 2. And actually, let me just set this up by doing it this way. Let me say this is for P, and then I'm going to come down here and say this is for Q, and then I'll write P over Q on another side. So for Q, again, that's factors of your leading coefficient. In this case, it's 1, so you just have plus or minus 1. So this one's really straightforward. Again, depending on the problem you're working with, this can get very, very tedious very, very quickly. Let me just put a little border here, and I'm just going to go P over Q. And so it's just all the possible ways you can do this. So you have plus or minus 1 over plus or minus 1. That's just going to give you plus or minus 1. So plus or minus 1. Then when you think about plus or minus 2 over plus or minus 1, that's going to be plus or minus 2. So this right here, if you were asked for all the possible rational zeros. They don't necessarily work. You're just putting up a list of what could potentially work. You have to go through and use synthetic division to actually test and see if they work. We're not doing that here, but these are your candidates for rational zeros. So your P over Q, you have plus or minus 1 and then plus or minus 2. All right, let's take a look at problem 2. So here we have f of x equals x cubed plus 8x squared plus 20x plus 25. So again, we're going to set up P over Q. So P, again, that's factors of your constant term. So here that's going to be 25. So for 25, you're going to have plus or minus 1. Then you're going to have plus or minus 5. And then you're going to have plus or minus 25. Then when we think about Q, that's going to be factors from, again, the leading coefficient. So here, that's going to be 1. So you just have plus or minus 1. So when we set this up, we're going to go P over Q. And again, we're just going through all the possibilities. So you have plus or minus 1 over plus or minus 1. That is plus or minus 1. You have plus or minus 5 over plus or minus 1. That is going to be plus or minus 5. Then you have plus or minus 25 over plus or minus 1. That is plus or minus 25. So again, these are your possible candidates. They don't necessarily work for rational zeros. So your P over Q here, you have plus or minus 1, plus or minus 5, and then plus or minus 25. All right, for problem 3, we have f of x equals 5x cubed plus x squared minus 5x minus 1. So again, when we think about P, these are the factors of the constant term. Here, that's negative 1. You can go plus negative 1 like that to make that crystal clear. And so when you think about negative 1, it's just positive 1 or negative 1. So I'm going to go plus or minus 1. Then for your Q, let me rewrite that. It's going to be factors of your leading coefficient. So in this case, you have 5 as the leading coefficient. So factors of 5, you have plus or minus 1. And then you have plus or minus 5. So if we go P over Q, so possible rational zeros, here P is only plus or minus 1. So we're going to divide that by plus or minus 1, and that would give us plus or minus 1. Then we have plus or minus 1 over plus or minus 5. We're going to write that as plus or minus 1/5. So these are the possible, again, they don't necessarily work, rational zeros. So your P over Q, you have plus or minus 1, and then plus or minus 1/5. All right, for problem 4, we have f of x equals 2x cubed plus 5x squared plus 4x plus 1. So again, when we think about P, that's going to be the factors of the constant term. So here that's 1. So that's just going to be plus or minus 1. And then when we think about Q, that's going to be factors from your leading coefficient. So here that's 2. And so that's just plus or minus 1 and then plus or minus 2. So again, P over Q. So we're going to say that's plus or minus 1 over plus or minus 1. That's plus or minus 1. Then we're going to have plus or minus 1 over plus or minus 2. That's going to be plus or minus 1 over 2, or plus or minus 1/2. So the possible rational zeros here, you have your P over Q, you have plus or minus 1, and then you have plus or minus 1/2. All right, for problem 5, we have f of x equals 2x cubed minus 10x squared plus 15x minus 9. So we have our P. That's going to be the factors of this constant here. So again, you can go plus negative there to say it's negative 9. And so for negative 9, you're going to have plus or minus 1, plus or minus 3, and then plus or minus 9. And then for Q, that's going to be factors of this leading coefficient, which is 2. So that's going to be plus or minus 1, and then plus or minus 2. So this one's going to be a lot longer. So let's just go ahead and say we have P over Q. So we're just going to take this one and go over this one, and then we'll just move down. So plus or minus 1 over plus or minus 1, that is plus or minus 1. Then you have plus or minus 1 over plus or minus 2, that is plus or minus 1/2. Then we're going to have this one. So we're on plus or minus 3 over plus or minus 1, that is plus or minus 3. Then you have plus or minus 3 over plus or minus 2, that is plus or minus 3/2. Then I'm going to just continue this down here. We have our plus or minus 9 over plus or minus 1, that is plus or minus 9. Then lastly, we have plus or minus 9 over plus or minus 2, that is plus or minus 9/2. So these are all your possible rational zeros. All right, for problem 6, we have f of x equals x cubed minus 10x squared minus 36x minus 24. So this one will be a little bit longer. Let me go plus negative here. So I'm going to say that the constant term here is negative 24. So let's put P, again, the factors of the constant term. So I would just start with plus or minus 1 and then just keep going up. So you can use plus or minus 2 And then if you think about 24, forget about the fact that's negative. 24 divided by 3 is 8. So you can go plus or minus 3, and then it's divisible by 4, so plus or minus 4. And then not divisible by 5, divisible by 6, so plus or minus 6. You can skip 7, it's divisible by 8, so plus or minus 8. Skip 9, skip 10, skip 11, and then we're going to have plus or minus 12, and then we're going to go all the way to plus or minus 24. Okay, so that's all the factors of negative 24. When you think about Q, again, it's the factors of this leading coefficient. So in this case, this is 1. So you're just going to get plus or minus 1. Well, this is actually not that bad here because basically when you think about P over Q, so P over Q, it's just going to be this right here. Because if I go plus or minus 1 over plus or minus 1, I'm getting plus or minus 1. If I go plus or minus 2 over plus or minus 1, I'm getting plus or minus 2. In other words, if I take a number and I divide it by 1, I just get the number back. If I divide it by negative 1, I get the opposite of the number. So all I have to do is rewrite this or copy it. Let me just copy it real quick. I think that would be a little bit quicker. So let me paste this in right there. So this would be all the possible rational zeros here. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and then plus or minus 24. All right, for problem 7, we have f of x equals 2x cubed plus 3x squared minus 1. So let's think about, again, p. That's going to be factors of your constant. You can go plus negative 1 here. So the constant term is negative 1. So basically the factors of negative 1 would just be plus or minus 1. Then for q, again, that's going to be the factors of the leading coefficient. In this case, that's 2. So you have plus or minus 1 and then plus or minus 2. Let me put a little border here. So if you want p over q, so you're going to take plus or minus 1 over plus or minus 1. That's going to be plus or minus 1. Then you're going to take plus or minus 1 over plus or minus 2. That's going to be plus or minus 1/2. So these are your possible rational zeros, plus or minus 1, and then plus or minus 1/2. All right, for problem 8, we have f of x equals 3x cubed minus 5x squared plus 7x plus 3. So let's go p. Again, factors of the constant term, so that's 3. So that's going to be plus or minus 1, and then plus or minus 3. And then q, that's going to be factors of the leading coefficient. So again, that's 3 also in this case. So we have plus or minus 1, and then plus or minus 3. Okay, so when we think about p over q, so what are the possible rational zeros we can have? So I'm going to start with plus or minus 1 over plus or minus 1. That's plus or minus 1. Then you have plus or minus 3 over plus or minus 1. So that's going to be plus or minus 3. Then you're going to have plus or minus 1 over plus or minus 3. So let's go plus or minus 1/3. Then you're going to have, let me fix this right here. Let me make that better. Plus or minus 3 over plus or minus 3. So that would end up giving me actually plus or minus 1. In other words, if I wrote plus or minus 3 over plus or minus 3, well, I'm going to go back to this plus or minus 1. So you don't need to double list things. When that happens and you get a duplicate, you can just delete it. So we're just going to list the possible rational zeros as plus or minus 1, plus or minus 3, and then plus or minus 1/3. All right, for problem 9, we have f of x equals 1/3 x cubed minus 11 over 6 x squared plus 3x minus 4/3. Okay, in this situation, we do not have integer coefficients. So what you want to do is actually modify this function. So you're going to look at the fractions that are involved. So the denominator here is 3, the denominator here is 6, and the denominator here is 3. So you're going to multiply through by the LCD. Now, why is this legal? I would not have this f of x here. I would have 6 times f of x. The LCD would be 6. So if you do 6 times f of x, and actually, let me rewrite this as g of x. So let's say g of x is equal to 6 times f of x, which would be equal to, you're just going to multiply everything here by 6. So 6 times the third is 2. So this would be 2x cubed. And then minus, if you multiply 11 over 6 by 6, you get 11. So this is 11, and then x squared. And then plus 6 times 3 is 18. And then x, and then minus 6 times 4/3. 6 divided by 3 is 2. 2 times 4 is 8. So this right here, again, is 6 times your f of x. But it's going to have the same zeros. The reason it has the same zeros is that if you're trying to find the zeros for your function, what you're going to end up doing is saying that this right here is 0 is equal to 1/3 x cubed minus 11 over 6 times x squared plus 3x minus 4/3. Well, you can legally multiply both sides by 6. This would still be 0 if I did that, because 0 times 6 is still 0. So you would have 0 is equal to, you would have, again, this 2x cubed and then minus 11x squared, and then plus 18x, and then minus 8. So it's going to have the same zeros. So you're able to use the rational roots theorem just by doing this little technique, because again, the zeros would be the same. So that's all you're looking for. Just to prove this to you, I've done a little graph here, and I'll give you a link for this on Desmos if you want to play around with it. But the guy in red, that's your f of x equals 1/3 x cubed minus 11 over 6 x squared plus 3x minus 4/3. Then the guy in green, that's going to be your g of x. So again, that's 6 times f of x. Again, that's giving me a vertical stretch by a factor of 6. So this is going to be 2x cubed minus 11x squared plus 18x minus 8. Now I went ahead and wrote the zeros out. So you can see that you're going to have one right here. So right there, that's a common point. Then you're going to have one right there. And then you're going to have one right there. So all the zeros are the same. Again, the graphs are not the same and they're not the same function, but the zeros are the same. So you're going to have one at 2. So that one right there. You're going to have one at 7 plus the square root of 17 over 4. So that's going to be this one right there. That's about, let's say 2.78 if you approximate it. And then you're going to have one right here, which is 7 minus the square root of 17 over 4. And that's about, let's say 0.72. Okay, so let's come back up here. And I'm going to say that for my p, I'm looking for, again, factors of this constant term. So in this case, that's -8. So factors of -8, you have plus or minus 1, you have plus or minus 2, plus or minus 4, and then plus or minus 8. Then let's think about q. So for q, again, it's factors of the leading coefficient. In this case, that's 2. So you have plus or minus 1 and then plus or minus 2. Okay, let me put a border here. So I'm going to go p over q. So we're going to start with this one. Let me just highlight this so we keep track of this. So this one, I'm going to go over this one. So plus or minus 1 over plus or minus 1, that's plus or minus 1. Let me fix this plus sign here. Then you have plus or minus 1 over plus or minus 2. That's going to be plus or minus 1/2. Now let me erase this highlighting here and let me slide down so we can keep track of this. So we have plus or minus 2 over plus or minus 1. So that's going to be plus or minus 2. Then we're going to have plus or minus 2 over plus or minus 2. So that would actually give me plus or minus 1, because again, this is what you're doing. You're going plus or minus 2 over plus or minus 2. That's going to give me plus or minus 1, which we already have. So that's a duplicate, so you don't have to write it. So now we're going to move on to the next one. Let me undo the highlighting there. Let me put the 2 back in. And we're going to go to plus or minus 4. So plus or minus 4 over plus or minus 1, that is plus or minus 4. And then you have plus or minus 4 over plus or minus 2, that's plus or minus 2. Again, we already have that, so you don't have to list it again. So let's go down here and go to plus or minus 8. So plus or minus 8 over plus or minus 1, that is plus or minus 8. And then plus or minus 8 over plus or minus 2, that is going to be, again, plus or minus 4, which we already have. So you can get rid of this comma here, and maybe I can just fit this up here. Let's put this plus or minus 8 like that. So again, we looked at where the zeros were. We saw that 2 was a 0, so it's in that list right there. The other guys that we found were not rational zeros. You had that 7 plus the square root of 17 over 4, and then 7 minus the square root of 17 over 4. Those are not rational zeros. So these are your potential or possible rational zeros. You have plus or minus 1, plus or minus 1/2, plus or minus 2, plus or minus 4, and then plus or minus 8. All right, for problem 10. We have f of x equals 2x cubed minus 1/2 x squared minus 2x plus 1/2. All right, so again, in this situation, we do not have all integer coefficients. So you could just multiply through by the LCD. So you have a denominator of 2 and a denominator of 2. So let's say that g of x is equal to 2 times f of x. So this would be 2 times 2x cubed would be 4x cubed. And then minus 2 times 1/2 is 1. So this would just be x squared. And then minus 2 times 2x would be 4x. And then plus 2 times 1/2 is 1. So again, the zeros here would be the same as the zeros here. We are changing the function. This is 2 times f of x, but it will have the same zeros. If we look at the graph, I know this is hard to see, but this guy in red, this is f of x equals 2x cubed minus 1/2 x squared minus 2x plus 1/2. Then your g of x, the guy in green, this is going to be 4x cubed minus x squared minus 4x plus 1. So if you look at where the zeros are, well, you can see that you have 1 right here. That's going to be at -1. You're going to have 1 right here. This is going to be at 0.25 or a fourth. And then 1 right here, which is going to be at 1. So they have the same zeros. They're not the same function. The g of x is 2 times f of x, so it's vertically stretched by a factor of 2. And you can see that here. But it does have the same zeros. So let's go back. So let's think about the p here. So we want the factors of the constant. So it's just 1, so that's just plus or minus 1. And then the q, that's going to be the factors of the leading coefficient. So you have 4, so that's plus or minus 1, plus or minus 2, and then plus or minus 4. Okay, so let me put a little border here, and we're going to have P over Q, which is going to be plus or minus 1 over plus or minus 1, that is plus or minus 1. Then we have plus or minus 1 over plus or minus 2, that is plus or minus 1 half. Then we have plus or minus 1 over plus or minus 4, that is plus or minus 1 fourth. So again, looking at this, the possible rational zeros, we have plus or minus 1, plus or minus 1 half, and then plus or minus 1 fourth. All right, let's take a look at the practice test. For the instructions, we're asked to write a polynomial function of degree 3 that satisfies the given conditions. All right, for problem 1, we are given that f of 2 equals negative 30. Then we're given zeros of 5, 4, and negative 3. So from the Fundamental Theorem of Algebra, we can set this up and say that f of x is equal to sum a times the quantity x minus k sub 1 times the quantity x minus k sub 2 times the quantity x minus k sub 3. So k sub 1, k sub 2, and k sub 3, those are your zeros. So we're given those, 5, 4, and negative 3. It doesn't matter the order that you put them in, so I'm just going to go with 5 right here, 4 right here, and then minus a negative 3 would be plus 3. So this right here, you could write as x plus 3. Okay, we have this part right here. This right here is the one that's a little bit tedious to find. You're given the fact that f of 2 equals negative 30. So let's just go ahead and say that if we plugged in a 2, everywhere there's an x. So in other words, if you had a times the quantity 2 minus 5 times the quantity 2 minus 4 times the quantity 2 plus 3, this would be equal to negative 30. So we can just use this to solve for a. Let me come down here a little bit, and we're going to say that 2 minus 5 is negative 3. So this would be a times negative 3, and then times 2 minus 4 is negative 2. And then 2 plus 3 is going to be 5. So this should be equal to negative 30. So negative 3 times negative 2 is 6. 6 times 5 is 30. So you would end up with 30a is equal to negative 30. And if we divide both sides of the equation by 30, we're going to end up with a being equal to negative 1. And really all you have to do is put a negative right there. Now, some teachers will let you give this as your answer. Others will want you to simplify. The simplifying is really the tedious part. So you could write your answer like that if you're self-studying and just move on. Otherwise, let's just go ahead and simplify. So let's just say that this would be equal to, let me write this as negative x plus 5. So that's just distributing this negative into this first guy, and then times you have this quantity x minus 4, and then times this quantity x plus 3. So I'm just going to start with these two right here, just using FOIL. Keep in mind that this is a negative x here, so it's going to change what we're used to. So we're going to have negative x times x. That would be negative x squared. Your outer here, you have a negative times a negative, which is a positive. X times 4 is 4x. Then your inside, you'd have plus 5x. And then your final, 5 times negative 4, that's negative 20. So if you want, we can just combine like terms now. So let's say that 4x plus 5x is 9x. So we have negative x squared plus 9x, and then minus 20. So I'm going to go ahead and wrap this, and then we're going to multiply this by this x plus 3. So what I would do for this is just write x times the quantity negative x squared plus 9x minus 20, and then plus 3 times the quantity negative x squared plus 9x minus 20. And so this right here, x times negative x squared would be negative x cubed, and then plus x times 9x would be 9x squared, and then minus x times 20 is 20x. Then you have 3 times negative x squared, that's minus 3x squared, and then plus 3 times 9x, that's 27x, and then 3 times negative 20 is negative 60. Okay, at this point, all we have to do is combine like terms. So we have negative x cubed, and then 9x squared minus 3x squared, that's going to be plus 6x squared. Negative 20x plus 27x, that's plus 7x. And then lastly, we have minus 60. So again, if f of 2 equals negative 30, and you have the zeros of 5, 4, and negative 3, this is what you could write here. If you want to just leave it in factored form, this is okay. So f of x equals the negative of the quantity x minus 5 times the quantity x minus 4 times the quantity x plus 3. Again, if your teacher tells you to simplify, you could write it like this. So you can say this is equal to negative x cubed plus 6x squared plus 7x minus 60. All right, for problem 2, we have f of 1 is equal to negative 24. We're given zeros of 9, negative 2, and negative 1. All right, so let's go ahead and write out our f of x is equal to a times the quantity x minus k sub 1 times the quantity x minus k sub 2 times the quantity x minus k sub 3. So these are the zeros. Again, you're plugging those in for k sub 1, k sub 2, and k sub 3. So you can plug that in any order. So you can put a 9 here. Then for the negative 2, if you have minus a negative 2, that's plus 2. And then for the negative 1, if you have minus a negative 1, that's plus 1. So now we just need to figure out what is a. To do that, you use this f of 1 equals negative 24. So in other words, if I plugged in a 1 everywhere there's an x, let's say that we have a times 1 minus 9 would be negative 8, and then times 1 plus 2 would be 3, and then times 1 plus 1 would be 2. We're going to set this right here equal to negative 24. Again, coming straight from this right here. So all you'd have to do is say negative 8 times 3, that's negative 24, and negative 24 times 2, that's negative 48. So let's say that negative 48a is equal to negative 24. And let's divide both sides by negative 48, like that. So this would cancel, and you're going to get a is equal to, so negative 24 over negative 48, that's going to be positive 1/2. Okay, so we have a now. Let's go ahead and erase this. Let's put in 1/2. If you're self-studying, you can just leave it like this. This is an acceptable answer. But if you want to simplify, or if your teacher requires it, then we can go ahead and just do that. So let's say that 1/2 would be put outside of some brackets. I'm just going to multiply these two together first. So let's do x times x, that's x squared. And let's do the outer. So we'd have x times 2, that's plus 2x. And then the inside, so negative 9 times x, that's minus 9x. And then your last negative 9 times 2, that's minus 18. Now let's go ahead and simplify this now. 2x minus 9x, that's negative 7x. So you have x squared minus 7x, and then minus 18. Let me slide this down a little bit like that. Okay, so now we're multiplying this by this x plus 1. Let me close that down. So the way I would do this, let's put equals 1/2, and then let's set up our brackets. You would say x times the quantity x squared minus 7x minus 18, and then plus 1 times this guy right here. Now 1 times anything is itself. Let's just write it out for clarity. So this 1 times x squared minus 7x minus 18. Let's close all that down. So this equals 1/2. Let's put the bracket. And then x times x squared is x cubed. And then minus x times 7x is 7x squared. And then minus x times 18 is 18x. And then again, 1 times anything is itself. You just have plus x squared minus 7x and then minus 18. Close that down. Okay, so coming down here, let's go ahead and say this equals 1/2. And then you'll open up these brackets. All right, so you're going to have x cubed, nothing to combine with that. Then you have negative 7x squared plus x squared, that's negative 6x squared. You have negative 18x minus 7x, that's negative 25x. And then you have minus 18, so let's close that down. So now we're going to distribute this in to each guy. So we'll say this equals 1/2 times x cubed is 1/2 x cubed. Let me actually make this better and this better. So this, and then minus 1/2 times 6 is 3. So you would have 3x squared, and make the 3 better here. And then minus 25 times 1/2 is just 25 halves. So 25 halves, and then times x, and then minus 18 times 1/2 is 9. So again, you can write your answer by saying f of x equals 1/2 times the quantity x minus 9 times the quantity x plus 2 times the quantity x plus 1. Or you could simplify this and say it's 1/2 x cubed minus 3x squared minus 25 halves x minus 9. All right, let's take a look at problem 3. So we're told here that f of 1 equals negative 8, and that you have the zeros 2 with a multiplicity 2, and then 5. So let's set this up. So f of x is equal to a times the quantity. You have x, you'll have minus k sub 1, and then x minus k sub 2, and then x minus k sub 3. So in this case, you have 2 with a multiplicity that's 2. So in other words, you can replace this with a 2, and then this with a 2. And we can change that to squared in a moment, but for right now, let's plug in a 5 for this one. So that's how this would set up. So you could say that this is a times the quantity, x minus 2 squared, and then times x minus 5. Again, if you want to write it like this, it's not wrong, but most people will probably write it like this. It's really up to you. So let me erase this, and let me put this like this. You are told that f of 1 equals negative 8. So again, you could just say that you plug in a 1 there. So a times 1 minus 2, that would be negative 1. So this is negative 1 squared. And then here, 1 minus 5, that's going to be negative 4. So this should be equal to negative 8. Let's see what we get out of this. So negative 1 squared is 1. So you can just get rid of this because 1 times anything is itself. So really all you have to do here is say that you have negative 4a is equal to negative 8. Divide both sides by negative 4. And so this would cancel. And then this over this is going to be 2. So let's say that a is equal to 2. Let me get rid of this. And let's write in here that this is 2. Now again, if you're self-studying, you could just leave this as the answer, or you could put 2 times the quantity x minus 2 times the quantity x minus 2 times the quantity x minus 5. That's fine as well. Or you can go through and simplify. So really, it's up to you. So let's say this is equal to, what I would do to make this a little bit easier, I would distribute the 2 into this guy right here. So if this is more clear, you could write it like this first. So 2 times the quantity x minus 5 times the quantity x minus 2 squared. I don't want to confuse anybody. So 2 times x would be 2x, and then minus 2 times 5 would be 10. So write it like that first, then times the quantity x minus 2 squared. So let's write this as 2x minus 10. And this you can use your formula for, so it's x squared minus 2 times this guy times this guy. So it's really just 2 times 2, which is 4, times x, which is 4x, and then plus the last guy, which is 2 squared, which is 4. Okay, so then we're going to say that this is 2x times this x squared minus 4x plus 4, and then plus, you have negative 10 times this guy. Let me just write this as minus 10 like this, times the quantity x squared minus 4x plus 4. So let's go ahead and say that this would be 2x times x squared is 2x cubed, and then minus 2x times 4x, that would be 8x squared, and then plus 2x times 4, that would be 8x. Then for this, we're going to treat this as negative 10. So negative 10 times x squared, that's going to be minus 10x squared. Negative 10 times negative 4x, that's plus 40x. And then negative 10 times 4, that's going to be minus 40. Okay, what can we combine here? So we have 2x cubed. We can't really do anything with that. And that 3 should be a lot better. And then we have negative 8x squared minus 10x squared. That's negative 18x squared. We have 8x plus 40x. That's plus 48x. And then we have minus 40. So this is what you want. Let me get rid of all this. So let's put equals here. And so again, you could write your answer as f of x equals 2 times the quantity x minus 2 squared times the quantity x minus 5. Or if you want to simplify it, you could say it's 2x cubed minus 18x squared plus 48x minus 40. And let me fix this 0 right there. All right, for problem 4, we're given that f of negative 1 equals negative 32. We are also given zeros where we have 1 with a multiplicity 2 and then negative 5. So let's say that we have f of x is equal to a times the quantity x minus k sub 1 times the quantity x minus k sub 2 times the quantity x minus k sub 3. So if we think about what's going on here, for k sub 1, again, you could just use 1, and then you'd have that again for k sub 2. And then for k sub 3, that's negative 5. So minus the negative 5 is plus 5. So again, if you want to keep it like this, that's fine. Or if you want to write x minus 1 quantity squared. So if you want to just do that, maybe it's a little bit easier to do. So let me move this down here like that. All right, then to find a, we want to plug in a negative 1 for each occurrence of x. So let's say that we have a times negative 1 minus 1, that would be negative 2. This would be squared. And then this right here, negative 1 plus 5, that's 4. So this should be equal to, as it tells us right here, negative 32. All right, so negative 2 squared, that's going to be positive 4. So you would have 4 times 4, which is 16, and then times a. So 16a is equal to negative 32. Divide both sides by 16. So this would cancel, and you're going to get a is equal to negative 32 over 16, which is negative 2. So let's write a is equal to negative 2. Okay, let's get rid of this from here. And let's put negative 2 in there. Let's get rid of this scratch work here. And again, if you're self-studying, you could just leave this as the answer. That's perfectly fine. Otherwise, if you want to go through, we can say that this is equal to, again, I would do negative 2 times x, which is negative 2x. And then negative 2 times 5, that would be minus 10. So I would do that first, just to get it out of the way. Then times, you have your x minus 1 quantity squared. So x squared. Then minus 2 times this guy times this guy. 2 times 1 is 2, times x is just 2x. And then plus the last guy, which is 1 squared, so that's 1. Okay, so this one, let's set this up as negative 2x times the quantity x squared minus 2x plus 1. And then you have your minus 10 times the quantity x squared minus 2x plus 1. Okay, so negative 2x times x squared, that's negative 2x cubed. And then negative 2x times negative 2x, that's going to be plus 4x squared. Then negative 2x times 1, that's minus 2x. I'm going to treat this as negative 10. So negative 10 times x squared, that's minus 10x squared. Then negative 10 times negative 2x, that's plus 20x. Then negative 10 times 1, that's negative 10. Okay, so going through here, let's see what we can combine. We have negative 2x cubed, and then we have 4x squared minus 10x squared. That's going to be negative 6x squared. We have negative 2x plus 20x. That's going to be plus 18x. And then we have minus 10. So let's say this equals to this. So f of x equals negative 2 times the quantity x minus 1 squared times the quantity x plus 5. Or you could say it's equal to negative 2x cubed minus 6x squared plus 18x minus 10. All right, for problem 5, we have f of 2 is equal to 135, and then we're given zeros where we have -1, multiplicity 3. Okay, so thinking about our setup, we have f of x is equal to, again, you have your a times the quantity x minus k sub 1 times the quantity x minus k sub 2 times the quantity x minus k sub 3. Well, here the only zero you have is -1. It just has a multiplicity 3. So really you'd have x minus a -1, which is x plus 1, and that would just be quantity cubed. So we can get rid of this and just put x plus 1 quantity cubed. Now we need a. So again, we're told f of 2 equals 135. So just plug in a 2 there. 2 plus 1 would be 3, and 3 cubed is 27. So you'd have 27a is equal to this 135. Let me fix this 3 here. Divide both sides of the equation by 27, and this would cancel. And you're going to get a is equal to 135 over 27 is 5. Okay, let's erase this, and let's put the 5 right there. So you can answer this way. Again, if you're self-studying, that's a perfectly acceptable answer. Or if you want to expand this, this one's actually going to be pretty quick because we can just use the formula. So let's say that this equals 5 times, let me put some brackets here. Again, the formula for this, if you think about it, it's this first guy cubed. So it's x cubed. And then plus, let me put a 3 here and go plus, let me put a 3 here. And then plus, the last guy, it's 1 cubed, so that's just 1. So what goes here and here? Well, in this position, you square this guy, and this guy is to the first power, and they're multiplied together. Well, 1 to the first power is just 1, and 1 times anything is itself, so you just need the x squared here. And then for this one right here, this guy's raised to the first power, and this guy squared. Well, 1 squared is still 1, and 1 times x is still just x. So this is an x right there, and that's all it is. Again, if you want to look up the formula for that, we did it in special products. So you can go back to that lesson. Otherwise, you could just do it the long way. Okay, so this equals, you distribute this in, so 5 times x cubed is 5x cubed, and then plus 5 times 3x squared is 15x squared, and then plus 5 times 3x is 15x, and then plus 5 times 1 is 5. And so basically you can answer as f of x equals 5 times the quantity x plus 1 cubed, or you could say 5x cubed plus 15x squared plus 15x plus 5. All right, for problem 6, we have f of 0 is equal to -252, and we're given zeros of -6, 3, and -2. So if we set this up as f of x is equal to a times the quantity x minus k sub 1 times the quantity x minus k sub 2 times the quantity x minus k sub 3. So if you have minus a -6, that would be plus 6. Then here you could just plug in a 3. And then again, minus a -2 would be plus 2. So let's plug that in there. So now we need our a. And we have f of 0 equals -252. So let's put a times. Here if I plug in a 0, 0 plus 6 is 6. Times, if I plug in a 0 here, 0 minus 3 is -3. And then times 0 plus 2 would be 2. So this should be equal to -252. So 6 times -3 is -18, and then -18 times 2, that's -36. So this is -36a is equal to -252. And then from this point, let's divide both sides by -36. So this would cancel, and we would say a is equal to, let me fix this 5 here. So -252 divided by -36, that would be positive 7. And let's put in our 7 here. So again, if you want to list this as your answer, that's perfectly acceptable. Otherwise, we could just go through and simplify it. It won't take too long. I would distribute this into one of these. It doesn't matter which one. I think that if you use this one, the 7 times 6 would be 42. That's kind of big. So maybe I would use this one. So let's just say that this is equal to 7 times x is 7x, and then plus 7 times 2 is 14. Then let me multiply this by the product of these guys. So x times x is x squared. The outer would be minus 3x. The inner would be plus 6x. So if you combine there, that would be plus 3x. And then 6 times -3 is -18. Okay, so let's say this equals, let's go 7x times the quantity x squared plus 3x minus 18, and then plus 14 times the quantity x squared plus 3x minus 18. Okay, so this would be equal to 7x times x squared is 7x cubed. And then plus, let me fix this 3 here real quick. Your 7x times 3x, that would be 21x squared. Then minus 7x times 18, that would be 126x. Then plus 14 times x squared is 14x squared. Then plus 14 times 3x, that's 42x. Then you have 14 times -18, which would be -252. All right, so looking at combining things, this is 7x cubed. And then you have 21x squared plus 14x squared. That's going to be plus 35x squared. Then negative 126x plus 42x, that is minus 84x. And then lastly, we just have minus 252. And let me just say that our f of x is equal to, again, you could write it like this. So 7 times the quantity x plus 6 times the quantity x minus 3 times the quantity x plus 2. Or you could write it like this. So 7x cubed plus 35x squared minus 84x minus 252. All right, for problem 7, we have f of 3 equals 20. And then the zeros here, we have negative 7, negative 1, and 2. Okay, so let's go ahead and say that we're setting this up as f of x is equal to a times the quantity x minus k sub 1 times the quantity x minus k sub 2 times the quantity x minus k sub 3. So again, this can go in any order. So you can plug in a negative 7 here. So minus a negative 7 is plus 7. And then minus a negative 1 would be plus 1. And then you could just plug in a 2 right there. And then we just need to figure out what a is. So f of 3 is 20. So if you plug in a 3 here, 3 plus 7 is 10. So let's go a times 10. And then times 3 plus 1 would be 4. And then times 3 minus 2 would be 1. So you could write that in, but multiplying 1 times something doesn't change it. So we're just going to leave that off. So this is equal to 20. Well, 4 times 10 is going to be 40. So this becomes 40a is equal to 20. We divide both sides by 40. This cancels. You get a is equal to 20 over 40 is 1/2. So this right here is 1/2. Now again, you could multiply this in to one of these guys now if you want, but I find that most people will not like working with fractions in that way, so I'll probably just do it in the end. And also, as I've been saying, you could leave your answer like this. So 1/2 times the quantity x plus 7 times the quantity x plus 1 times the quantity x minus 2. That's a perfectly acceptable way to answer this type of problem. So let's say that this is 1/2 times, so inside of brackets, let's just do this one first. So x times x is x squared. And then plus, your outer would be x, your inner would be 7x. So x plus 7x is 8x. And then plus 7 times 1 is 7. And this is times x minus 2. Let's close that down. So let's say this is equal to 1/2 out in front. And let's just go through this and say we're going to multiply x times the quantity x squared plus 8x plus 7. And then let's go minus 2 times the quantity x squared plus 8x plus 7. So let's close that down and then close down the brackets. Okay, so this equals, we're going to have 1/2. So x times x squared is x cubed. And then plus x times 8x is 8x squared. And then plus x times 7 is 7x. Let me fix the 7 there, make it better. So then here, again, I'm going to treat this as negative 2. So negative 2 times x squared is minus 2x squared. And then negative 2 times 8x, that's negative 16x. And then negative 2 times 7, that's negative 14. Okay, let's close all that down. So this equals, we're going to have 1/2, again, out in front. X cubed, I can't do anything with that. 8x squared minus 2x squared, that's going to be plus 6x squared. Then 7x minus 16x, that's going to be minus 9x. And then you have minus 14. So let's close that down. So looking at this, we have 1/2 that's going to be distributed. So 1/2 times x cubed is 1/2 x cubed. And then plus 1/2 times 6 is 3. So this is 3x squared. And then minus 1/2 times 9, that's 9/2, and then times x. And then minus 1/2 times 14, that's going to be 7. Let's say our answer is f of x equals 1/2 times the quantity x plus 7 times the quantity x plus 1 times the quantity x minus 2. Or you could say 1/2 x cubed plus 3x squared minus 9/2 x minus 7. All right, let's take a look at problem 8. So we're told f of 1 is equal to 1, and we have zeros of 1/2, 3/4, and negative 1. So in this particular case, it's going to be a little bit tedious because we have some fractions for the zeros. Let's go ahead and just set this up. So f of x is equal to a times the quantity x minus k sub 1 times the quantity x minus k sub 2, and then times the quantity x minus k sub 3. Okay, so for k sub 1, let's just use 1/2. And then for k sub 2, let's use 3/4. And then for k sub 3, let's use negative 1. And of course, minus the negative 1 is plus 1. Okay, so we're told that f of 1 equals 1. So again, you've got to plug in a 1 here, here, and here. Because you're dealing with fractions, it is a little bit tedious. So let's say a times, you would have 1 minus 1/2. Let me show this. So I'm going to write 1 as 2 over 2, and then minus 1/2. So this would be 1/2. So a times 1/2, and then times, you're going to plug in a 1 here. So 1 minus 3/4. Most of you know that's 1/4. But let's just go ahead and write 1 as 4 over 4. And then minus 3 over 4, just for completeness. So 4 minus 3 is 1 over the common denominator of 4. So this is 1/4 here. And then we're going to go times. Let me fix this real quick. So again, times. Now you have 1 plus 1, which is 2. Okay, so if I look at this, this should be equal to 1. If you look at 1/2 times 2, that would be 1. So let me say that this would cancel with this. And what I have is 1/4 times a is equal to 1. Well, I can multiply both sides by 4. And so this would cancel with this, and I get a is equal to 4. Okay, let me get rid of this. Now, particularly for this example, because it's going to be so tedious to simplify, I would say that just putting a 4 right here and being done with it would be okay. Again, especially if you're self-studying. So f of x equals 4 times the quantity x minus 1/2 times the quantity x minus 3/4 times the quantity x plus 1. But in the interest of completeness, I'm just going to go ahead and do it. So let's just go ahead and say that this is equal to, I would distribute the 4 into this one. So you would have 4x and then minus 4 times 1/2 would be 2. Let me move this one over. So x plus 1 like that. And let me put x minus 3/4 at the end. Okay, let's say this equals, we're going to do these two first. So 4x times x is 4x squared. The outer would be 4x. The inner would be minus 2x. So 4x minus 2x would be plus 2x. And then negative 2 times 1 would be negative 2. Okay, so let me wrap this. And then let me wrap this. So x minus 3/4. Okay, so let's say this is equal to, we're going to go x times the quantity 4x squared plus 2x minus 2. And then let's go minus 3/4 times the quantity 4x squared plus 2x minus 2. Okay, so what is this going to give us? We know that x times 4x squared would be 4x cubed. And then plus x times 2x would be 2x squared. And then minus x times 2, that's 2x. All right, so I'm going to treat this as negative 3/4. So let's say that we have negative 3/4 times 4x squared. And of course, the 4's are going to cancel, so this is just negative 3x squared. So negative 3x squared. Then you have negative 3/4 times 2x. So let's say that's negative 3/4 times 2. And then let's put the x right there. So of course, this would cancel with this and give me a 2. So this is negative 3/2 x. So negative 3/2 x. And then lastly, negative times negative is positive. And then 3/4 times 2. So 3/4 times 2. This would cancel with this and give me a 2 down there. So this is 3/2. Okay, let's see if we can simplify this further. So we're going to have 4x cubed. Nothing I can do with that. So 2x squared minus 3x squared, that is negative x squared. Then you're going to have negative 2x minus 3/2 x. So let's just work with the coefficients. So negative 2 I could write as negative 4 over 2. And then minus 3/2. So of course, negative 4 minus 3, that's going to be negative 7. Over the common denominator of 2. So this is negative 7/2. So if I did negative 2x minus 3/2 x, that would be negative 7/2 x. Then lastly, we have this plus 3/2. So again, you could say f of x equals 4 times the quantity x minus 1/2 times the quantity x minus 3/4 times the quantity x plus 1. So this would also be equal to 4x cubed minus x squared minus 7/2 x plus 3/2. All right, for problem 9, we have f of negative 1 is equal to negative 16. We're given zeros of 3 with multiplicity 2 and then negative 1/2. So let's say f of x is equal to a times the quantity x minus k sub 1 times the quantity x minus k sub 2 times the quantity x minus k sub 3. Let me fix this x here. And again, if 3 is a 0 with multiplicity 2, you could put a 3 right there and then a 3 right here. But in most cases, you would just put the x minus 3 and just say it's quantity squared. So it's up to you if you want to do it that way or this way. It's just personal preference. This one would be x minus a negative 1/2, which is x plus 1/2. So let's put that in there and let's slide this down here. All right, we want to figure out a. So we're told that f of negative 1 is negative 16. So let's say that a times, you're going to plug in a negative 1 here. So negative 1 minus 3, that is negative 4. So this would be negative 4 squared, which of course is 16. So let's say that this is 16. And then here, if you plug in a negative 1 plus 1/2, I think most of you know that's negative 1/2. But again, just to show the scratch work, you can say negative 1 is negative 2 over 2, and then plus 1/2. And of course, this is negative 2 plus 1, which is negative 1, over the common denominator of 2. So it's negative 1/2. So this would be equal to, as it says up here, negative 16. So 16 times negative 1/2, that is going to give me negative 8. Let me erase this and just put, this is negative 8a is equal to negative 16. Divide both sides by negative 8. And so we're going to say that this is going to cancel with this. So we end up with a is equal to negative 16 over negative 8. That is 2. Okay, let's get rid of this scratch work here and just put a 2 right there. And again, if you want to list this as your answer, f of x equals 2 times the quantity x minus 3 squared times the quantity x plus 1/2, that's fine. Or we can go through and simplify. So let's say this is equal to 2 times, let me put some brackets right there. So this guy right here, again, using the formula, you would have x squared, then minus 2 times this guy times this guy. Well, 2 times 3 is 6, and 6 times x is 6x. So this would be minus 6x. And then plus this guy squared, 3 squared is 9. Okay, so let's put this as x plus 1/2 like this and close this down. Now, what you could do, let me actually get rid of this. You can multiply this by this. So in other words, you could say 2 times x would be 2x, and then plus 2 times 1/2, that would be 1. And then times this x squared minus 6x plus 9. I think that's probably the easiest way to do it. So this would be equal to 2x times the quantity x squared minus 6x plus 9 plus 1 times the quantity x squared minus 6x plus 9. Let me fix the 9 there. And so 2x times x squared, that is going to be 2x cubed. Then minus 2x times 6x, that is going to be 12x squared. Then plus 2x times 9, that's going to be 18x. Then plus 1 times anything is itself. So this is x squared minus 6x plus 9. Let me fix the 6 here. So then let's say this is 2x cubed. Nothing to combine with that. Then we have negative 12x squared plus x squared. That's negative 11x squared. And then we have 18x minus 6x. That's plus 12x. Let me fix that. Then we have plus 9. Let me bring this up here. And let me put equals. So we can say that f of x equals 2 times the quantity x minus 3 squared times the quantity x plus 1/2. Or we could say this is equal to 2x cubed minus 11x squared plus 12x plus 9. All right, for problem 10, we're told that f of 0 equals negative 25. We're given zeros, negative 10, multiplicity 2, and then 1/4. Okay, so let's go f of x is equal to a times the quantity x minus k sub 1 times the quantity x minus k sub 2 times the quantity x minus k sub 3. So you have a 0 that's negative 10 and another 0 that's negative 10. So that's x plus 10. So x minus a negative 10 again is x plus 10. And let's just go ahead and erase this one and say it's quantity squared. And then this one right here would be 1/4. So let me erase this and put x minus 1/4. Okay, so we're told that f of 0 is equal to negative 25. So we're going to use that to find a. So if I plugged in a 0 there, I would have 10 squared, which is 100. Let's say a times 100. And then times 0 minus 1/4 would be negative 1/4. Well, 100 times negative 1/4 is negative 25. So this would be negative 25 times a is equal to, again, this negative 25 right here. If we divide both sides of the equation by negative 25, we're going to have this cancel and this would cancel be 1. So a is just equal to 1. So you can write 1 there or you can just get rid of it. It's really up to you. So if you want to multiply this together, again, that's up to you. This is an acceptable answer. You could just say f of x is equal to the quantity x plus 10 squared times the quantity x minus 1/4. That's fine. Otherwise, we can just simplify and say that using the formula here, this would be x squared plus 2 times x times 10, that would be 20x. And then plus 10 squared, that's 100. And then this would be times x minus 1/4. So this becomes x times the quantity x squared plus 20x plus 100. Let me fix this real quick. And then minus 1/4 times the quantity x squared plus 20x plus 100. Okay, let me make this better here. Sliding down, we're going to say this is equal to x times x squared is x cubed. And then plus x times 20x is 20x squared. And then plus x times 100 is 100x. Here we have negative 1/4 times x squared, so that's negative 1/4 x squared. Then we have negative 1/4 times 20x. Well, negative 1/4 times 20 is going to be negative 5, so this is negative 5x. And then lastly, you have negative 1/4 times 100, that is negative 25. Okay, so looking at this, we have x cubed, nothing we can do with that. You have 20x squared minus 1/4 x squared. So for that, let me slide down a little bit. Let me write 20 as 80 over 4 and then minus 1 over 4. So this becomes 79 over 4. So that's going to be your coefficient for x squared. So let's say this is plus 79 over 4 x squared. Then we have 100x minus 5x. That's going to be plus 95x. And then lastly, we have minus 25. And again, you could say f of x equals the quantity x plus 10 squared times the quantity x minus 1/4. That's fine. Or we could say it's equal to x cubed plus 79 over 4x squared plus 95x minus 25. All right, let's take a look at the practice test where the instructions were asked to write a polynomial function of least degree that has the given zeros. All right, before we get into any problems today, I want to take a few moments and go through some of the formulas that you can use to greatly speed up your work. I'm going to start with something we should already know. So if we multiply two complex conjugates together, so let's say something like a plus bi and then times a minus bi, we should know already that this is a squared plus b squared. So that's going to be a real number. But in case you want to go through this the long way, again, if you just use FOIL, a times a is a squared. The outer and the inner would cancel. So you would have a times negative bi, that's negative abi, and then plus you would have bi times a, so a bi. So again, that's just going to cancel away. And then lastly, you would have bi times negative bi, so that's negative b squared I squared. Well, what is I squared? That's negative 1. So that's going to flip the sign here. So we can say this is equal to a squared plus b squared. Okay, so this is just something you want to remember. And let's put this here that this is a squared plus b squared. So something you might not have looked at, let's say you add two conjugates together. So let's say you have a plus bi, and then you add a minus bi. Well, what does this do? You have a plus a, that's going to be 2a. And then you have bi plus negative bi, so that's going to cancel. So this is just going to be 2a. So keep these two things in mind here, because I'm going to show you something else. And this is the only formula you really need for today. Let's say we have x minus, and I'm going to put in here a plus bi, and then I'm going to close this down. And we multiply this by x minus, so we want the conjugate of this, so a minus bi. Close that down, and then close this down. What is a quick way to do this? The slow way would be, okay, I'm going to write this as x minus a, and then minus bi. So that quantity times the quantity x minus a, and then plus bi. In other words, the slow way is x minus a minus bi, and then times x minus a plus bi. You don't need to do this. This is going to take a long time, and it's going to be quite tedious. So I'm going to erase this, and I'm going to erase my equal sign for right now. And I'm just going to do this in the simplest way possible, and that is by making a substitution. You can do it without a substitution, but every time I do it that way, people tend to get lost. So I'm just going to let something like u be equal to this a plus bi. And then I'm also going to make a substitution here. So we'll use w for this a minus bi. Let's say that I write this again using these substitutions. So I'm going to say that I have x minus, this is u, again, that's a plus bi, and this is x minus a minus bi, that is w. Well, what's going to happen if I multiply these guys together? I'm going to get x squared, and then I'm going to get minus wx, and then I'm going to get minus ux, and then I'm going to get plus uw. Okay, let's think about some things that we already know. Let me slide down. I'm going to try to fit all this on the sheet at one time. The first thing is I can factor out a negative x here. So in other words, I could write this as x squared and then minus x times the quantity w plus u and then plus uw. If we think about what is w plus u, again, we've already done that. This is w, this is u. So we're just adding the conjugates together, so we know that's going to be 2a. So this right here, I'm just going to arrow to it and say it's 2a. And then we know what uw is. That's me multiplying the conjugates together. So that's a squared plus b squared. So this right here is a squared plus b squared. And maybe I could make that a little bit better. Okay, so using this information, let me get rid of this, and let me come up here and say this equals, well, this would be x squared, and then this would be 2a here times negative x. So minus 2ax, and then basically you'd have plus this a squared plus b squared. Okay, let me get rid of this. This is the formula that we're going to use today to greatly speed things up. I would strongly advise for you to write this down. I'm going to reference it all the time, and I'm just going to roll through these things because trying to do it the slow way is going to take a very, very long time. All right, for problem 1, we have zeros of -1 with multiplicity 2, and then we have 1 minus I. So from the Conjugate Zeros Theorem, we know that if we have a non-real complex zero, such as 1 minus I, then its complex conjugate is also a zero. So 1 plus I. So non-real complex zeros, common conjugate pairs. So this means that our polynomial function is going to have 4 zeros. So we're going to set this up as f of x is equal to a, that's some leading coefficient, times the quantity x minus k sub 1, times the quantity x minus k sub 2, times the quantity x minus k sub 3, times the quantity x minus k sub 4. So we're just going to plug in here, 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 and here. Again, the zeros that you plug in, they can go in any order. In terms of a, in the last section, we were given information to figure out what that was. This is just a leading coefficient. In this section, because the problems are more tedious, they typically just leave it off and say, well, you can just make a 1. But really, you could use any non-zero real number that you want, and it would still work out in terms of getting the correct answer. I'm just going to use 1 for simplicity, and I'm just going to leave it off when we set this up in the future. Okay, so I'm just going to follow this and plug in. So f of x is equal to, so the quantity, x minus, again, k sub 1, so pick any of these zeros. Let's just pick -1. So x minus a -1 is x plus 1. And the multiplicity here is 2, so let's just say this is quantity squared. And then for this one and this one, again, just pick these. So let's go x minus. Be very careful when you plug this in. So you want to subtract the whole thing away. So we're going to use some parentheses here. So let's go 1 minus I. Close that down. And then we're going to close this down. And then we're going to do this. So we're going to go x minus, and then this guy right here. Again, it's going to be 1 plus I. So 1 plus I, close that down, and then close this down. Now, again, I gave you a formula for multiplying these guys together. So we're just going to use the formula. So we're going to blow through this really quickly. If you don't know what the formula is, go back to the beginning of this video. Okay, so let's slide down here a little bit. And I'm just going to say that this is equal to, this guy right here squared would be x squared plus 2 times this guy times this guy. So that's 2x. And then plus the last guy squared, 1 squared is 1. So this right here, again, I'm just going to do it really quickly. This would be x squared. And then you're going to have a minus 2 times a times x. Now, what is a? A is going to be 1 here. So 2 times 1 is 2. So this is just minus 2x. Then you're going to have plus. So this right here is going to be a real number. So you have a squared plus b squared. So for our purposes, let's just say that a is 1 and b is 1, so 1 squared is 1. So in other words, you would have 1 squared plus 1 squared, again, coming from that formula that we talked about earlier. So 1 squared is 1 in each case, and so you would basically have 1 plus 1, which is 2. Let's just write this as a 2 and close that down. Okay, so now we know how to do this. We're just going to take each term from this polynomial, multiply it by this polynomial, and then combine like terms. So let's start with x squared times this guy right here. So x squared times x squared, that's going to be x to the 4th power. Then you're going to have x squared times negative 2x. So that's negative 2x cubed. And then x squared times 2, that's going to be plus 2x squared. Now we're going to move on to this one right here. So we have 2x times this guy right here. So we have 2x times x squared. So that's plus 2x cubed. And then 2x times negative 2x, that's minus 4x squared. And then 2x times 2, that's going to be plus 4x. So last guy here, it's real easy because we have 1. So 1 times anything is itself. So you can really just copy this. So plus x squared minus 2x plus 2. Okay, let me get rid of this highlighting here. And we're just going to combine like terms. So we're going to say this is x to the 4th power. You have negative 2x cubed and plus 2x cubed. So those are going to cancel. You have 2x squared minus 4x squared. So that's negative 2x squared. And then you have plus x squared. You could write that as plus 1x squared if you want. So negative 2x squared plus 1x squared, that would be negative x squared. Then you have 4x and then minus 2x. That would be plus 2x. And then you have plus 2. So this x to the 4th power minus x squared plus 2x plus 2, that's what you want. Let me get rid of this. So this is one way to write it, but the other way you could say f of x is equal to x to the 4th power minus x squared plus 2x plus 2. All right, for problem 2, we're given zeros of negative 5 and then 3i. We know that if 3i is a 0, then negative 3i, so the complex conjugate, is also a 0. So come down here and set this up. We're going to go f of x is equal to, again, for a, the leading coefficient, you can just leave that off. You could just pick 1, or you can pick any non-zero real number that you want. So I'm going to say that this is x minus whatever the 0 is that I'm plugging in. So here it's negative 5. X minus the negative 5 is x plus 5. And then here you would have x minus, so you have a 0 of 3i. And then here you would have x minus, this is negative 3i, so minus a negative 3i is plus 3i. This one's pretty easy to simplify. So we can just go through and say that this would be x plus 5 times, this one again, if you want to go back to your formula, it would be this guy squared. So this is x squared. And then again, you're going to have a plus here, this 3 here squared, so that would be 9. And again, that happens because I squared equals negative 1, so it flips the sign. Okay, so this one right here, you can go through and simplify really quickly. So x times x squared would be x cubed, and then plus you have x times 9, which is 9x. And then you're going to have 5 times x squared, which is plus 5x squared, and then plus 5 times 9, which is 45. I would just switch the order of these. So let's say that this is x cubed, and then plus 5x squared plus 9x plus 45. And at that point, we're good to go. Let me erase this scratch work here. Let me fix that and say f of x is equal to x cubed plus 5x squared plus 9x plus 45. Or again, if you want to list it like this and move on, that's fine as well. All right, for problem 3, we are given zeros of 1, -1, and then 2 minus 2i. So again, if 2 minus 2i is a 0, that means that 2 plus 2i is also going to be a 0. So let's go ahead and set this up. So let's say that we have f of x is equal to, again, for a, I'm just going to use 1, so you can leave that off. We're going to have x minus, one of the zeros is 1, and then we have x minus a -1 is plus 1, and then we have x minus, we're going to throw in 2 minus 2i. Be very careful here. So we're going to put this inside of parentheses. So 2 minus 2i, close that down, and then close this down. And then here we're going to do x minus, again, let's put some parentheses here. So 2 plus 2i, and let's close that down. And then we're going to close this down. Okay, let me see if I can slide this over so it fits a little bit better. Now, what you want to do is use your formula for this. Let me start with this one though. X minus 1 times x plus 1, just use your formula. That is x squared minus 1. So let me wrap this in parentheses. And then for this one, again, we know it's x squared minus 2 times a in this case is 2 times x. So minus 2 times 2 times x. Well, 2 times 2 is 4, so this is minus 4x. Just like that. And then you're going to have plus, again, your a squared. Let me write this out. So a squared plus b squared. Again, just coming from that formula. So we're going to just use an a value of 2 and a b value of 2. So 2 squared is 4. And we can just put that this would be 4 plus 4, which would be 8. Okay, so this would be 8 here. And again, using that formula is just going to save a lot of time. So let's go through and multiply now. So x squared times x squared, that's going to be x to the 4th power. X squared times negative 4x, that's going to be minus 4x cubed. X squared times 8, that's going to be plus 8x squared. Then this is -1 here multiplied by this. You're just going to change the sign of everything. So this is negative x squared. This is plus 4x. This is minus 8. Okay, so looking at what we have here, this would be x to the 4th power minus 4x cubed. And then 8x squared minus x squared, that's plus 7x squared. Let me fix this x right here. And then you have plus 4x and then minus 8. Okay, let me get rid of this. Your f of x could be written as this, or again, if you want to simplify, you could say it's equal to x to the 4th power minus 4x cubed plus 7x squared plus 4x minus 8. All right, let's take a look at problem 4. So here we're given zeros of 4 and then 2 plus I. So again, that means we're going to have 2 minus I as a 0. And so let's set this up. So we have f of x is equal to the quantity x minus 4 times the quantity x minus. And I'm just going to wrap this in a different color. So 2 plus I. Let's do that like that. And then this would be over here times x minus. And then let's say this inside would be 2 minus I. Close that down and then close this down. So again, if you want to simplify, we're going to just use the formula. Let's keep this out in front. So x minus 4. This one here is x squared minus 2ax. What is a here? It's going to be 2. So this would be 2 times 2, which is 4. So minus 4x here. Let me scooch this down. And then plus, again, this is a squared plus b squared like that. And so what is a? We're going to use 2. And for b, we can just use 1. So let's say 2 squared is 4. And 1 squared is 1. So 4 plus 1 would be 5. So let's put this as a 5 here. And again, we can just go through and say x times x squared is x cubed. And then x times negative 4x is minus 4x squared. And then x times 5, that's plus 5x. Then we have negative 4 times this guy right here. So we would have negative 4 times x squared, that's negative 4x squared. And then negative 4 times negative 4x, that's plus 16x. Then negative 4 times 5, that's minus 20. Okay, so let's look through this and say that it's x cubed. We have negative 4x squared minus 4x squared. That's going to give me negative 8x squared. We have 5x plus 16x. That's going to be plus 21x. And then we have minus 20. Okay, let me get rid of this right here. And let me scooch this up like this. So we'll say that f of x is equal to, again, you could list it this way if you want, or you could say it's x cubed minus 8x squared plus 21x minus 20. All right, for problem 5, we are given 3 plus I as a 0, and we're told that the multiplicity is 2, and then we're given 3 minus I. Well, again, if this is 3 plus I with multiplicity 2 by the Conjugate Zeros Theorem, then you would have 3 minus I also with a multiplicity. I'm just going to abbreviate that. That's going to be 2. So when you set this up, you could say f of x is equal to, let's go x minus let's go 3 plus I, close that down and close this guy, quantity squared. And then you're going to have x minus, now you're going to have this guy. So you can have 3 minus I, and then we're going to have quantity squared. Okay, this one is going to be pretty tedious. Let me actually copy this, and I'm just going to come to another page here. I'm going to write the f of x back in there, and maybe that could be better. So we should know that if you have something like m squared times n squared, you could write that as m times n squared. So this is something we talked about earlier in the course. We're going to use that here, and we're going to say this is equal to, you could use brackets or whatever you want. So I'm going to throw this in here. So the quantity x minus, and then you have 3 plus I here. Just be real careful with your parentheses. Maybe I'll just highlight that. And then over here, you have x minus 3 minus I inside there. Again, let me just highlight this for clarity. And then we're going to close this down and square it. So on the inside, you can just use that formula. So let's go ahead and say that this is equal to, let me put the brackets here. So we know that this is x squared and then minus, again, let me just write this out. So 2ax and then plus you have your a squared plus b squared. So this is something, again, you just want to write over and over and over again. It's really going to help you out today. So what is a? A is going to be 3. So 2 times 3 would be 6. So this is minus 6x. Again, a is 3. So a squared, 3 squared would be 9. And then b, you could just use 1. So 1 squared is going to be 1. And so 9 plus 1 is going to be 10. So that's this guy right here. And let me scooch this down. And I forgot to square it, so let's square it now. So if you had x squared minus 6x plus 10, quantity squared, what would that be equal to? So this would be equal to the quantity x squared minus 6x plus 10 times the quantity x squared minus 6x plus 10. Let me get rid of these middle steps here because we're going to run way off the page. We don't need that stuff anymore anyway. Let me move this up here like this. So x squared times x squared is x to the 4th power. Then x squared times negative 6x, that's negative 6x cubed. Then x squared times 10, that's going to be plus 10x squared. Then negative 6x times x squared, that's minus 6x cubed. Negative 6x times negative 6x, that's plus 36x squared. Then negative 6x times 10, that's going to be negative 60x. Then here you have 10 times this guy, so you're going to have plus 10 times x squared is 10x squared. And then 10 times negative 6x is negative 60x. And then 10 times 10 would be 100. Okay, so let's look for like terms. So x to the 4th power, nothing we can do with that. Then if you have negative 6x cubed minus 6x cubed, that's going to be negative 12x cubed. Then if we have 10x squared plus 36x squared, that's 46x squared, then plus another 10x squared, that's going to be plus 56x squared. And then we have negative 60x minus 60x, that's minus 120x, and then plus 100. And let me come back up here, and I'm just going to paste this in. So this is the answer. Again, I know this is a tedious one, but if you use that formula, it's not too bad. So f of x is equal to, again, you can use this if you want, or you could say it's x to the 4th power minus 12x cubed plus 56x squared minus 120x plus 100. All right, for the next few problems, the instructions are going to change. Now we want to find all zeros. All right, for problem 6, we have f of x is equal to x to the 4th power minus 4x cubed minus x squared minus 114x minus 102. We're given 1 0, which is negative 1 plus 4i. Let me come to another page here. I'm just going to write zeros here. So this is going to be the answer for this problem. And we have negative 1 plus 4i. By the Conjugate Zeros Theorem, we know that negative 1 minus 4i is also a 0. So we need 2 more zeros here because we have a 4th degree polynomial. And the way we're going to get them, let me come back up here. We're going to take this guy right here and use synthetic division. And basically, we're going to cut this down to a cubic, and then we're going to cut it down to a quadratic, and then we can use the quadratic formula. So basically, let me set this up as negative 1 plus 4i. And you want to give yourself a lot of room when you do these. So the coefficient for x to the 4th power is 1. Let me leave a decent amount of space here. Then the coefficient for x cubed is negative 4. Then this is going to be negative 1 for the coefficient for x squared. The coefficient for x to the 1st power is negative 114. And the constant is negative 102. Okay, let me bring this to another page. No way that's going to fit here. So let me come right here. And again, you're just going to drop this down and go through this. So negative 1 plus 4i times 1, that is negative 1 plus 4i. When you add these together, you just have to add negative 4 plus negative 1, that is negative 5, and then you just have your plus 4i. Now here comes the tedious part. You need to multiply this by this. So let's go negative 1 plus 4i, and then times negative 5 plus 4i. Okay, so negative 1 times negative 5 is 5. Your outer, negative 1 times 4i is negative 4i. Your inner, 4i times negative 5, that's minus 20i. And then your last, 4i times 4i, that's plus 16i squared. Now, I squared is negative 1, so really you can erase this and just change the sign here to a negative. And so if you think about 5 minus 16, that's going to be negative 11. And then negative 4i minus 20i, that is negative 24i. So that's going to go right here. So you have negative 11 minus 24i. Okay, let me get rid of this. And now we're going to add, and that part's easy. So you just have to do negative 1 plus negative 11. That is going to be negative 12. And then you have your minus 24i. Okay, so now we have to multiply. Again, that's the tedious part. So this times this. So you're going to have negative 1 plus 4i. And then times, you're going to have negative 12 minus 24i. So negative 1 times negative 12 is 12. The outer, negative 1 times negative 24i, that's plus 24i. The inner, 4i times negative 12, that's minus 48i. The last, 4i times negative 24i, that's going to be negative 4 times 24, that's 96. And then I times I is I squared. So once again, I squared is negative 1. So just change the sign of this to a plus. So 12 plus 96, that's going to be 108. And then 24i minus 48i, that's negative 24i. And I'm going to write that we have 108 and then minus 24i. And then we're going to add these guys. Let me get rid of this. Again, that's really easy to do. All you have to do is do negative 114 plus 108, and that is going to give me negative 6. And of course, you have the minus 24i. Okay, so now we're going to multiply this by this. And so you have this negative 1 plus 4i, and then times this negative 6 minus 24i. And so negative 1 times negative 6 is 6. Your outer would be negative 1 times negative 24i, so that's plus 24i. Your inner, 4i times negative 6, that's minus 24i. And then your last 4i times negative 24i, that's going to be negative 96i squared. So this right here is going to cancel. And then again, I squared is negative 1. So this right here would be a plus. What is 6 plus 96? That is 102. So that goes right here. And of course, we should expect that when we get the sum here, that it's going to be 0. Because again, if the remainder is 0, that tells us that this is a 0, but we were already told that this was a 0. This is not new information. The reason we're doing this is so we can get the coefficients for the cubic. Now, you don't have to write it out. You can just take this right here and do synthetic division again. So now what you're going to do is use the conjugate. So you're going to go negative 1 minus 4i, and you're going to set this up like this. And so you're going to copy these. Let me go ahead and copy. So this is going to be your coefficient for x cubed, x squared, x to the first power, and that's your constant. And now we're going to do synthetic division again. So this will be a 0, and we're not really concerned with whether it's a 0 or not. We already know that from the Conjugate Zeros Theorem, but we're trying to get this down to a quadratic where we can use the quadratic formula and find the other two zeros. Okay, so let's put this like this, drop this down. And so negative 1 minus 4i times 1, that's negative 1 minus 4i. So now you're going to add, and negative 5 plus negative 1, that's negative 6. 4i minus 4i is 0. So this is just negative 6. So now you're going to multiply negative 1 minus 4i times negative 6. Let's do that right here. So negative 6 times negative 1 minus 4i. So negative 6 times negative 1 is 6. And then negative 6 times negative 4i is plus 24i. So this is 6 plus 24i. Let me get rid of this. And now we're going to add. So negative 12 plus 6, that's going to be negative 6. Notice that negative 24i plus 24i, that's 0. So we're going to do negative 1 minus 4i times negative 6. We just did that a moment ago. We know it's going to be 6 plus 24i. And of course, when you add these guys together, negative 6 minus 24i plus your 6 plus 24i, that is going to give you 0. So that is not a surprise because we knew this was a 0. At this point, this right here is going to give you your quadratic. So this 1 right here is the coefficient for x squared. So x squared, then you have minus 6x, and then minus 6. And let me come back here. All you need to do is set this equal to 0 and solve. And in this case, you're not going to be able to factor it, so you can just use the quadratic formula. So your a is 1, your b is going to be negative 6, and your c is also negative 6. So your x is equal to, again, the negative of b plus or minus the square root of b squared minus 4ac all over 2a. So what is b? b is negative 6. So the negative of negative 6 is positive 6. Then here, negative 6 squared is positive 36. Then for a, you have 1. So you can just erase that. Your c is negative 6. So let's go plus negative 4 times negative 6. What does that give me? Negative 4 times negative 6, that's positive 24. Let's put 24 there. And then 2 times a, again, a is 1. So what is 36 plus 24? That is going to be 60. So this would be equal to 6 plus or minus. If you think about 60, it's 15 times 4. Let me erase this and just put 15 times 4. We know 4 is a perfect square, so you can say this is 2 times the square root of 15. This is over 2. Now, you can factor out a 2, so we can say this is equal to 2 times the quantity 3 plus or minus the square root of 15 all over 2. And so now we're going to cancel this 2 with this 2. So let me write this as 3 plus or minus the square root of 15. So one zero would be 3 plus the square root of 15, and the other would be 3 minus the square root of 15. So that's what we're looking for in terms of the zeros. That's the process overall. I know it's quite tedious, but you will be asked to do it in this section. All right, for problem 7, we have f of x equals x cubed minus 7x squared plus 17x minus 15. The zero given is 3. So in this case, all you have to do is some simple synthetic division. We're going to put 3 out here. And then we're going to take this as a 1 for the coefficient for x cubed, this as a negative 7 for the coefficient for x squared, this as a 17 for the coefficient for x, and then your constant is negative 15. So we're just going to drop this down like this. 3 times 1 is 3, and negative 7 plus 3 is negative 4. 3 times negative 4 is negative 12. 17 plus negative 12 is positive 5. 3 times 5 is 15. Negative 15 plus 15 is 0. All we're doing is we're getting these guys right here so we can set up our quadratic, and then we can just use the quadratic formula. So this is the coefficient for x squared, and then you'd have minus 4x, and then plus 5. And I'm just going to write in zeros, plural, so we know 1 is 3. Let me paste this in right there. Let's say this equals 0 here. So let's go ahead and solve this. Can we factor this? So we need two integers that sum to negative 4 and have a product of positive 5. Well, with positive 5, you either have 1 and 5, 1 plus 5 would be 6, or you have negative 1 and negative 5, that would be negative 6. So we're not going to be able to solve this with factoring. So again, we're just going to go to our quadratic formula. So this is a 1, let's go plus negative 4, and this is a 5. So A is 1, B is negative 4, and C is 5. So we have x is equal to, again, the negative of b plus or minus the square root of b squared minus 4ac all over 2a. So let me put a little border here. We have x is equal to, what is the negative of b? B is negative 4. So the negative of negative 4 is positive 4. Then plus or minus the square root of b squared. Negative 4 squared is 16. Then minus 4 times a times c. A is 1, so you can forget about that. So let's just go plus negative 4 times c is positive 5. So this right here, negative 4 times 5, that's negative 20. So this is negative 20. And 16 minus 20 would be negative 4. So this is negative 4. And then this is over. 2 times a is 1, so this is just 2. So let's simplify. So we know that the square root of negative 4, we can write that as 2i. So let's say that this is 4 plus or minus 2i over 2. And of course, we can simplify this. So we would say that we pull out a 2, and this would be 2 plus or minus I over 2. And then let's cancel this 2 with this 2, and we'll say that it's 2 plus or minus I. So I'm just going to say it would be 2 plus I, and then of course 2 minus I. All right, let's take a look at problem 8. So we have f of x equals x cubed minus 8x squared plus 6x plus 52. The zero we're given is 5 minus I. So let me come over here, and let me put zeros, 5 minus I, and of course you'd have 5 plus I, and you'll have one more, again, because this is a cubic, so you'd have 3 zeros. Let me come up here, and again, we can just use synthetic division. There's lots of ways you could do this. So I'm just going to start with 5 minus I here, and then leave lots of room. So we're going to have a 1 here. This is negative 8. Then this is going to be a 6, and this is going to be a 52. And let me drop this down here like this. So 5 minus I times 1 is 5 minus I. So you're just going to add negative 8 plus 5. That's going to be negative 3. So this is negative 3 minus I. Let me fix that. And then you just need to multiply these guys together. So 5 minus I times negative 3 minus I. And so this would be 5 times negative 3, that's negative 15. 5 times negative I, that's minus 5I. Negative I times negative 3, that's plus 3I. And then negative I times negative I, that's plus I squared. We know that I squared is negative 1, so you can just say that this is minus 1 here. And so negative 15 minus 1, that's negative 16. And then negative 5I plus 3I, that's negative 2I. So let's go ahead and say that this right here is going to be negative 16 minus 2i. And let's say that 6 plus negative 16 is negative 10, and then minus 2i. So now we have 5 minus I, and then times this negative 10 minus 2i. So 5 times negative 10 is going to be negative 50. And then you have 5 times negative 2i, that's negative 10i. And then negative I times negative 10, that's plus 10i. And then negative I times negative 2i, that's going to be plus 2i squared. Again, I squared is negative 1. So let's flip this to a negative here. And then basically this is going to cancel. So negative 50 minus 2, that is negative 52. So this is negative 52. Again, that's not a surprise. We were already told that this was a 0. So this is a 0. And I'm just going to highlight that. So now we have a quadratic, but we do not have real coefficients. So we're not going to use the quadratic formula. We're just going to use synthetic division again. So we're going to go 5 plus I now. And we're just going to use this right here. So 1, you have negative 3 minus I, and then negative 10 minus 2i. Let's drop it down and bring this down here. And let's go ahead and say that 5 plus I times 1 is 5 plus I. So negative 3 plus 5 is positive 2. Negative I plus I, that's going to cancel. So 5 plus I times 2, let me do this over here. So 2 times the quantity 5 plus I. This is 2 times 5, which is 10, plus 2 times I, which is 2i. So this is 10 plus 2i. Again, we already know this is a 0, so it's not a surprise. So if we have negative 10 plus 10, that's 0. Negative 2i plus 2i, that's 0. So this is 0. Again, we know there's no remainder. So this right here. Well, we had a quadratic, so now this is going to be a first degree. So this is just x and then plus 2. That's all it is. Let me come up here. And all you'd have to do is say x plus 2 is equal to 0. And of course, that would be x is equal to negative 2. So negative 2 would be your other 0. So the zeros here, you have 5 minus I, and then 5 plus I, and then you would have negative 2. All right, let's take a look at problem 9. So we have f of x is equal to x to the 4th power minus 4x cubed plus x squared plus 6x minus 40. We're given a 0 of 1 plus 2i. Let me come down here again, and let me write zeros. So if 1 plus 2i is a 0, let me write that one. So 1 plus 2i, again, by the Conjugate Zeros Theorem, we would have 1 minus 2i as a 0. Let's come back up here. Again, we're just going to stick to our synthetic division. So let's go ahead and say that this would be 1 plus 2i over here. And again, I want to leave myself a lot of room. So this would be a 1 right here. And let me leave myself some space and go negative 4. And then this would be a 1. This would be a 6. And then this would be negative 40. Extend that a little bit. And we can just do this right here. I'll just drop down and bring that down. And then let's start. So 1 plus 2i times 1 is just 1 plus 2i. So then negative 4 plus 1, that's going to be negative 3. So this is negative 3 plus 2i. So now we have to do 1 plus 2i times negative 3 plus 2i. 1 times negative 3 is negative 3. And then we have 1 times 2i, that's plus 2i. And then we have 2i times negative 3, that's minus 6i. And then we have 2i times 2i, that's plus 4i squared. So of course, you can just write this as minus 4 here because I squared is negative 1. So you have negative 3 minus 4. That is going to be negative 7. And then you have 2i minus 6i, that is negative 4i. So this right here would be negative 7 minus 4i. And now we're going to add 1 plus negative 7. That is going to be negative 6. And then you have minus 4i. So we're going to multiply 1 plus 2i. So 1 plus 2i. And then times negative 6 minus 4i. This is 1 times negative 6. That's negative 6. And then you have 1 times negative 4i, that's negative 4i. And then 2i times negative 6, that's minus 12i. And then 2i times negative 4i, that's minus 8i squared. So this equals. So this I squared is negative 1, so this is just going to flip the sign. So this would be a plus. Negative 6 plus 8, that's going to be 2. So this is 2. And then we have negative 4i minus 12i, that's going to be minus 16i. Okay, so let me put this right here as 2 minus 16i. And we're going to go 6 plus 2, that is 8. And then you have minus 16i. So we would have 1 plus 2i. Let me fix this plus here. And then times 8 minus 16i. So 1 times 8 is 8. The outer would be 1 times negative 16i, that's minus 16i. The inner would be 2i times 8, so that's plus 16i. And then the last 2i times negative 16i, that is negative 32i squared. This right here is going to cancel. And then I squared is negative 1, so you can just flip this to a plus. So 8 plus 32, that is 40. So this is 40. Again, that's as expected because we already know that this is a 0 because it tells us that in the problem. So this is a 0. Again, the reason we're doing this is to get this down to a quadratic. Right now it's a cubic, so this would be your coefficient for x cubed, x squared, x to the 1st power. Again, this would be the constant. So basically, you just do synthetic division again with the conjugate of this. So 1 minus 2i. And we're just going to take this right here. So 1 negative 3 plus 2i, and then you have negative 6 minus 4i, and then 8 minus 16i. So let's drop this down right here. So we have a 1, and then 1 minus 2i times 1 is 1 minus 2i. So negative 3 plus 1, that is going to be negative 2. 2i minus 2i is 0, so this is just negative 2. Then 1 minus 2i times negative 2, that's negative 2 times. You have 1 minus 2i like that. Negative 2 times 1 is negative 2. And then negative 2 times negative 2i, that's plus 4i. So this is negative 2 plus 4i. So now we have negative 6 plus negative 2, that is negative 8. And negative 4i plus 4i, that's 0. So that's going to go away. So now we're going to multiply negative 8 times this 1 minus 2i. And this would be negative 8 times 1, that's negative 8. And then negative 8 times negative 2i, that's plus 16i. So this is negative 8 plus 16i. Again, if you add those guys together, this 8 minus 16i, and then plus this negative 8 plus 16i, that is 0, again, as expected. So we're just going to take this, and we're going to get a quadratic out of it. So this is for x squared, and then this is minus 2x, and then minus 8. So we're just going to grab this. Okay, let's bring this back right here. And I'm just going to set this equal to 0. This is actually one you can solve with factoring. It's pretty easy to do. You can use the quadratic formula if you want. That's up to you. But I'm just going to put an x here and an x here. Two integers that sum to negative 2 and have a product of negative 8. That's going to be negative 4 and then positive 2. Okay, let me get rid of this. And again, by the zero product property, you would just say x minus 4 is equal to 0. Or x plus 2 is equal to 0. Let me get rid of this. Add 4 to both sides of the equation here. This cancels. You get x is equal to 4. Then over here, we're going to subtract 2 away from each side of the equation. This cancels. You're going to get x is equal to negative 2. So we can just throw those in as zeros. Let me fix this I here, make it a little bit better. So another 0 would be 4, and then another 0 would be negative 2. So if we look at all the zeros, you have 1 plus 2i, and then the complex conjugate, which is 1 minus 2i, and then you have 4, and then negative 2. All right, for problem 10, we have f of x equals x to the 4th power plus 2x cubed minus 22x squared minus 30x plus 153. We're given 1, 0, which is negative 4 plus i. Let me come down here and just put zeros. So we have negative 4 plus I, and then of course you'd have negative 4 minus I. Let me go back. And again, we're just going to follow that same procedure. We're going to use synthetic division to get this down into a cubic, and then we're going to go down to a quadratic, and then from there we can just use the quadratic formula. So let's write this as negative 4 plus I, and let's set that up like that. And you just want a lot of room here, so we're going to take a 1, that's the coefficient for x to the 4th power, and then 2, that's the coefficient for x cubed. And then you have negative 22, that's your coefficient for x squared. You have negative 30, that's your coefficient for x. And then you have 153, that's going to be your constant. And let's drop this down. We'll say that this is 1. Negative 4 plus I times 1, that's just negative 4 plus I. Well, 2 minus 4 would be negative 2. So let's say this is negative 2 plus I. So now we're going to do negative 4 plus I, and then times negative 2 plus I. So negative 4 times negative 2 is positive 8. Negative 4 times I would be minus 4i. Then I times negative 2, that's minus 2i. And then lastly, you have I times I, which is I squared. So plus I squared, which of course is negative 1. So you can just put minus 1. So this would be equal to 8 minus 1 is 7. And then negative 4i minus 2i, that's negative 6i. So this right here is going to be 7 minus 6i. So then negative 22 plus 7, that's going to be negative 15. And then you have this minus 6i here. So now we're going to multiply. So we're going to do negative 4 plus I, and then times negative 15 minus 6i. So negative 4 times negative 15, that's positive 60. And then your outer negative 4 times negative 6i, that's going to be plus 24i. Your inner I times negative 15, that's negative 15i. And then for the last, you have I times negative 6i, that's going to be minus 6i squared. So I squared is negative 1. So we're just going to change the sign of this to a plus. So you have plus 6 there. So 60 plus 6 is going to be 66. And then you have 24i minus 15i. That's going to be plus 9i. So this right here would be 66 plus 9i. Then we have negative 30 plus 66. That is going to be 36. And then you have plus 9i. And then let's multiply. So we're going to have negative 4 plus I, and then times 36 plus 9i. So negative 4 times 36, that's going to be equal to negative 144. Then negative 4 times 9i, that's minus 36i. Then I times 36, that's plus 36i. And then I times 9i is plus 9i squared. Okay, so this is going to cancel. I squared is -1, so you can just change this to a minus. So -144 minus 9, that is going to be -153, again, as expected. So you put -153 here. Let's get rid of this. And of course, when you add those guys together, your 153 and your -153, let me slide this down a little bit, that's going to give you 0. So again, that's not a surprise. We already know the remainder would be 0 here because we were told that -4 plus I is a 0. What we're going to do now is grab this right here. So this would be the coefficient for x cubed, x squared, x, and the constant. And we're going to do synthetic division again. So now let me write -4. Again, instead of plus I, you want minus I. So that's, again, coming from the Conjugate Zeros Theorem. And we're just going to grab this. So you have 1. Let me use a little space. You have -2 plus I. Then we have -15 minus 6i, and then you have 36 plus 9i. Okay, let me drop this down like this, and let's say -4 minus I times 1, that's -4 minus I. So -2 plus -4, that's going to be -6, and then I minus I is 0. So now you have -4 minus I times -6. So -6 times the quantity -4 minus I. This would be -6 times -4, that's 24, and then -6 times -I, that's plus 6i. So this is 24 plus 6i. Let me get rid of this. So -15 plus 24, that's going to be 9, and then -6i plus 6i, that's 0. So then -4 minus I times 9, that's going to be 9 times the quantity -4 minus I. So this equals 9 times -4 is -36, and then minus 9 times I is 9i. So this right here would be -36 minus 9i. So of course, when you add these guys together, you're going to get 0. 36 minus 36 is 0. 9i minus 9i is 0. So this is not a surprise. We know that this would be 0 for the remainder because we know that -4 minus I is a 0 if -4 plus I is a 0. Okay, so now we have a quadratic. So this is for the coefficient for x squared. So it would just be 1x squared or x squared. And we would have -6x and then plus 9. Okay, let me paste this in here and set this equal to 0. So for this one, you can factor it. This would factor into x minus 3 quantity squared. And you can say that's equal to 0. Again, that's coming from the fact that -3 times -3 would be +9, and -3 plus -3 is -6. Now, with this guy right here, you're going to have a double root. In other words, because this is squared, you could write this as x minus 3, the quantity, times x minus 3, that quantity, is equal to 0. And so if you solve x minus 3 is equal to 0, you add 3 to both sides of the equation, and so you get x is equal to 3. Now, depending on how the question is asked, you might only have to put, because if it just says, what are the zeros, you just put a 3 in there. Now, sometimes they're more specific, and they might say, what are the zeros and their multiplicities? So if that comes up, then you would want to modify the answer to say that this right here has a multiplicity that's 2. Okay, so it just depends on the situation. Just read the instructions carefully. If they just ask for the zeros, most of the time they'll just say, okay, well, it's -4 plus I, -4 minus I, and then 3. If they ask for the zeros and the multiplicities, then you want to say -4 plus I, -4 minus I, and then you would say 3 with a multiplicity 2. All right, let's take a look at the practice test. Where the instructions were asked to state the possible number of positive real zeros and negative real zeros. All right, let's take a look at the first problem. We're given f of x is equal to 4x to the 5th power plus 2x to the 4th power plus 30x cubed plus 15x squared minus 16x minus 8. So again, we're using Descartes' Rule of Signs, and this is for us to be able to determine the number of positive and negative real zeros for some polynomial function. So your polynomial function is going to have real coefficients, which we have here, a non-zero constant term. Here you have -8, and then it has to be written in descending powers of x. So in other words, it's going to be in standard form, and this is already in that form. So if you think about the number of positive real zeros, it's going to be equal to the number of variations in sign. So in other words, just look at the sign changes that occur in the coefficients, or it could be less than that by a positive even integer. So let's just start with that. I'm just going to write out here for the, let me just put positive, I'll just abbreviate that, real zeros. So like that. What are the sign changes here? Well, you notice that this is positive, this is positive, this is positive, this is positive, but then this is negative. In other words, when you go from right here to right here, this is going to change the sign. So it's from positive to negative, so there's one sign change there. But then when we go from here to here, it's negative and then negative again, so there's no sign change. So there's only 1 here, so when that happens, you just put a 1. Now, if you can decrease by 2, you go ahead and do that, but in this situation, 1 minus 2 would be -1, so you're not going to put that down. So now let's look at how to find the negative real zeros. So for that, you're going to use f of -x and you're going to look at the sign changes, it's the same process. So here, what you would do is you would look for everywhere there's an odd exponent. So here, and then also here, and you're going to change the sign of the coefficient. So this would become negative 4x to the 5th power. If it's an even exponent, the coefficient stays the same. So this is just plus 2x to the 4th power. This would be minus 30x cubed. Again, we're going to change the sign there. And then this would stay the same, so plus 15x squared. And then this one, again, you're going to flip the sign, so it would be plus 16x, and then this would be minus 8. So looking at this, let's say the negative, and I'm just going to abbreviate that, real zeros. What is that going to be? Let me actually slide this down a little bit, and maybe that could be written a little bit better. If you look at this one, we have a lot of sign changes. So here it's negative, and right there it's going to be positive. So let's go ahead and say that that's going to be number 1. Then if you look at this to this, again, you've got another sign change. So that's going to be number 2. And then from here to here, again, that's another sign change. So let's put that as number 3. And then this one stays the same, and then it changes again. So from here to here, we're going to say that that's number 4. So you have 4 sign changes here in f of negative x. So that means for the number of negative real zeros, it could either be 4, or again, you can decrease this by 2. So you're going to say it could also be 2, and then it could also be 0. So let me put or 0 here. So the number could be 4, 2, or 0. So you don't know. It doesn't tell you exactly in this particular situation because it can always be decreased by a positive even integer. And in this case, you start with 4, so that's the maximum number that could occur. You decrease by 2, you get to 2. You decrease by 2, and you get to 0. For the positive real zeros, we know that there'll be exactly 1 because if you try to subtract away 2, you get negative 1. And of course, that's not a valid answer, so you would just stop there. So positive real zeros, you would have 1, and then negative real zeros, it could be 4, 2, or 0. All right, for problem 2, we have f of x is equal to 2x to the 5th power plus 4x to the 4th power plus 5x cubed plus 10x squared minus 12x minus 24. So again, let's start off by finding the positive real zeros here. And let me actually fix this, make it a little bit better here. So what are the sign changes here? You'll notice that this is positive, 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 but then we go negative. So this right here to this right here, that's going to be 1 sign change, and then this is negative. So you just have 1. So positive real zeros, you're just going to put 1. Then for negative real zeros, let's go f of negative x. Again, you're just going to change the sign of the coefficient everywhere where your exponent is odd. So that's going to be right here, and then this one right here. So let me highlight that. And then, so this would be negative 2x to the 5th power. Plus, this stays the same, so 4x to the 4th power, because the exponent is even there. And then this would be minus 5x cubed. This would stay the same, so plus 10x squared. And then this one's going to change to plus 12x. And then this is minus 24. Okay, so looking at this, you see that you have a sign change immediately. So you're going from negative to positive, so that's 1. Let's write that in there. And then you're going to have a sign change again. So that's going to be 2. And then you have a sign change again. So that's going to be 3. And maybe the 3 could be better there. And then this stays the same. And then you have 1 final sign change. So this would be 4. So you have 4 of these guys. Let me come down here and we'll write negative, and I'll just abbreviate that, real zeros. So it could be 4, but that's the maximum number it could be. Then it could also be 4 minus 2 is 2. And then I'm going to put or, it could also be 0. So it could be 4, 2, or 0. All right, for problem 3, we have f of x is equal to 4x to the 6th power plus 16x to the 4th power minus 25x squared, then minus 100. Okay, so for the positive real zeros here, let's look at what we have. Now, some of you might say that you're missing x to the 5th power, you're missing x cubed, and you're missing x to the 1st power. That is actually okay. When you're missing a term like that, as long as it's not the constant, and I'll talk about that in the last problem, you're just going to skip it over and count it as no sign change. So this right here, you're going positive, positive, and then this is negative. So right there, that is 1 sign change, and then this is negative. So the positive real zeros, that's just 1. Now, if you notice, this is even, this is even, and this is even, and this would not change. If you look at f of negative x, it's going to be exactly the same thing as this. So I can write it out that f of negative x is equal to, I'm just going to copy this. So 4x to the 6th power plus 16x to the 4th power minus 25x squared minus 100. Again, when this happens, that's an even function. So let's go through here and say that the negative real zeros would be exactly the same as this one because, again, there's only going to be one sign change. When we go from positive to negative there, that's your sign change, and so we'll just put 1 there. That's it. So the positive real zeros, you're going to have exactly 1, and the negative real zeros, you'd have exactly 1. All right, for problem 4, we have f of x is equal to 9x to the 6th power plus 45x to the 4th power minus 4x squared minus 20. So if we look at this one, again, for the positive real zeros, let me make this better. We have positive, positive, and then negative. So right here, you have one sign change. So that would be a 1 because this guy right here is still negative. So you have positive, positive, negative, there's your sign change, and then negative again. Then when you flip this over, again, just like in the last problem, if you looked at f of negative x, well, this is even, even, even. This is not going to change. So it's exactly going to be the same. It's an even function. So this is 9x to the 6th power plus 45x to the 4th power minus 4x squared minus 20. Okay, so thinking about this, again, you would just have one sign change when you go from here to here. So when we say the number of negative real zeros, that is going to be exactly 1 as well. All right, for problem 5, we have f of x is equal to 5x to the 6th power minus 4x to the 4th power minus 20x squared plus 16. So let's see, we have this as positive and this as negative. So this right here would be one sign change. Then this is negative, but then this is positive. So this right here, that's a second sign change. So for the positive real zeros, you're going to have either 2, again, that's the maximum number, or you can decrease that by 2 and get to 0. So 2 or 0. Then for the negative real zeros, again, you have a situation where this is even, and this is even. So you have f of negative x being equal to exactly the same thing. So 5x to the 6th power, then minus 4x to the 4th power, then minus 20x squared, then plus 16. So we would write here that the number of negative real zeros is going to be 2 or 0, because from right here to right here, you have one sign change, and then from right here to right here, you have a second one. So it's either 2, which is the maximum number, or you can decrease that by 2 and get to 0. So it's 2 or 0 here as well. All right, for problem 6, we have f of x equals 6x to the 5th power minus 9x to the 4th power minus 34x cubed plus 51x squared plus 20x minus 30. Okay, so for the positive real zeros here, let me fix this. If we look at the number of sign changes, well, you're going to have, let me actually slide this down a little bit. You're going to have one right away. So you're going from positive to negative, so that's 1. And then this is negative, but then this is positive. So here is a second one. And then this is positive, but then this is negative. So here is a third one. So you would either have 3 or 1. So basically, once you get to 1 minus 2, that's going to be negative 1, so you can't put that down. You would either have 3, that would be the maximum number because there's 3 sign changes here, or you can decrease that by 2 and get to 1. So it's either 3 or 1. Then when we look at f of negative x, again, anywhere where you have an odd exponent, the coefficient is going to change sign. So right there, and again, let me write a 1 in right there. So this is crystal clear, so right there. So we're going to have, this is going to change, so negative 6x to the 5th power. This is the same, so minus 9x to the 4th power. This is going to change, so plus 34x cubed. And then this right here will be the same, so plus 51x squared. This is going to change, so minus 20x. And then we have minus 30. Okay, so how many sign changes do we have? This is negative, but then this is positive. So there's going to be 1 right there. And then this is positive, but then this is negative. So there's 1 right there. So this would be 2. And then this is negative. So there's only 2 of these guys. Again, this is negative and this is negative, but then it changes to positive. So that's the first one. Then this is positive, but then it goes to negative. So that's the second one. It changes. And then this is negative. So we're just going to have 2. So let's write negative real zeros. And let me make this better here. So in this case, and let me slide this down just a little bit, you can either have 2, again, that would be the maximum number, or you can decrease that by 2 and have 0. So either 2 or 0. All right, for problem 7, we have f of x equals 5x to the 5th power plus 25x to the 4th power plus 14x cubed plus 70x squared minus 3x minus 15. Okay, so looking at this, again, this is positive, this is positive, this is positive, this is positive, but then this is negative. So when we go from right here to right here, we have one sign change. This is negative, so there's only going to be one. So when we look at positive real zeros here, there's going to be exactly one. Okay, when we look at negative real zeros, we want f of negative x, and this equals, look at everywhere where the exponent is odd. So this is 5, this is 3, and then this right here is 1. So let me highlight that as well. So for all of those places, you're going to change the sign of the coefficient. So this would be negative 5x to the 5th power. This right here, that's even, so don't change it. So plus 25x to the 4th power. Change the sign here, so this is minus 14x cubed. And then this one would stay the same, so plus 70x squared. Let me put this in here. And then this right here, you change the sign, so plus 3x. And then this stays the same, so minus 15. Okay, so looking at this, we have a sign change right away. So from negative to positive, so that's 1. And then you have another sign change. So that would be number 2. So from positive to negative. And then you have another one. So from negative to positive, so that's 3. And then this one stays the same. And then we have a sign change again. So this would be from positive to negative. So that's 4. So in terms of the negative real zeros, let me fix this real quick. Well, you're either going to have 4, or you could decrease this by 2. So 4 minus 2 would be 2. And then you could decrease it again by 2, and you would have 0. So 4, 2, or 0. Those are your possibilities, 4 being the maximum that you could have. Then you could also have 2 or 0. All right, for problem 8, we have f of x equals 16x to the 6th power plus 64x to the 4th power minus 25x squared minus 100. Okay, so looking at this one, if we look at the sign changes, you have positive, positive, then you have a negative. So there's going to be one sign change there, and then this one's negative. So for the positive real zeros, we're going to have exactly 1. Then for the negative real zeros, you're going to have exactly 1 as well. Why? Because this is even, and this is even. So when you do f of negative x, again, this is an even function, you would get the same thing. You would get 16x to the 6th power plus 64x to the 4th power minus 25x squared, and then minus 100. Let me fix this real quick. And again, all you're going to have is one sign change here. That's going to be when you go from right here to right here. So from positive to negative, so just 1. So for the number of negative real zeros, it's the same thing. So negative real zeros, you're going to have exactly 1. All right, let's take a look at problem 9. So we have f of x equals x to the 6th power minus 64. Again, do not worry about all these terms that we're missing. You're just going to skip them over. So the only variation in sign, you could say that this is a 1 here. It's positive to negative. So of course, there's going to be one of those. So there's going to be one positive real zero. So for the positive real zeros, let me fix that. We're going to say there's exactly 1. For the negative real zeros, what do we notice here? Again, this is an even function. If I did f of negative x, I'm going to get the same thing because this is an even exponent right here. So basically there would be one sign change. So this would be a 1. So in terms of the positive real zeros, you're going to have exactly 1. And then in terms of the negative real zeros, you're also going to have exactly 1. All right, for problem 10, we have f of x is equal to 27x to the 7th power plus 37x to the 4th power minus 64x. All right, in this situation where you do not have a non-zero constant term, what I would do is factor. The reason you're going to do that is because the number 0, which is not positive and not negative, is going to be a 0 or a root here. So let's show that by saying that we have x times the quantity. You have 27x to the 6th power plus you have 37x cubed, and then minus 64. So on the inside part here, now you have a non-zero constant term. So we're just going to apply our little rule here. So this is positive, this is positive, this is negative. So going from right here to right here, you're going to have one sign change. So what this tells me is that the number 0 is a 0. Now, your problem might not ask for that. If they're asking for the number of positive real zeros and the number of negative real zeros, well, again, 0 is not positive, it's not negative, so you need to get with your teacher in that situation. But I'm just going to write here that for the positive real zeros, there's going to be exactly 1. And then I'm also going to put here, for clarity, in this situation that the number 0 is again, you could put 0 or root. Let me put 0 here, and I'm going to put root here to avoid some confusion. Now, what about the negative real zeros? Let me put that here. So negative real zeros. Well, let me get rid of this. I would do the same thing. So I would find f of negative x and then just factor out an x. So let's say this is equal to, so here, because this exponent is odd, this sign for this coefficient is going to change. So this is negative 27x to the 7th power. This guy is even, so there's no change here. So plus 37x to the 4th power. Then this guy again is odd, so the sign here is going to change. So this is plus 64x. Now, if you factor out an x, then you have negative 27x to the 6th power plus 37x cubed, and then plus 64. So we already know that the number 0 is a 0, so we're not worried about that. We're just working on the inside here. And you'll notice that when you go from right here to right here, there's a sign change. So from negative to positive, and this is positive. So again, just one sign change here. So when we come down to this part right here, and we ask for the number of negative real zeros, it would be exactly 1. So depending on the situation, for this one, you might want to answer that there's exactly one positive real zero, there's exactly one negative real zero, and then the number 0, which is not positive and not negative, is going to be a 0 or again a root, if you want to avoid confusion there, for this guy. You might say that there's 3 real zeros in this case, which means that since this guy is a degree of 7, you're going to have 4 non-real complex zeros. All right, let's take a look at the practice test. For the instructions, we're asked to show there is a 0 between the two numbers given. All right, for problem 1, we're given f of x equals x to the 5th power minus 3x to the 4th power plus 4x cubed minus 12x squared minus 12x plus 36. We want to show that there's a 0 between negative 1 and 2. So how do we do this? We're going to use the Intermediate Value Theorem. Let me just show you this with a graph real quick. So we're going to graph this guy right here, and I'll leave a link for you on Desmos so you can follow along. But essentially, you're going to find out in a moment that f of negative 1 is positive 28. Let me just write that here. So f of negative 1 is positive 28, and I'll do that with synthetic division. And then here we have f of 2. So f of 2 is negative 20. So how do I know that based on this information, there's a 0 between negative 1 and positive 2? Your 0 is actually going to be right there. You can see it on the graph. Well, the reason we know that is because this is a continuous curve for your polynomial function. So if this guy right here is positive in terms of the y value, it's positive 28, that means we're above the x-axis. This guy down here is negative in terms of the y value, that means we're below the x-axis. So again, if this is continuous, we can only get from above the x-axis to below the x-axis by passing through the x-axis itself. It's very, very simple. So this right here is where you're going to hit the x-axis. So that's going to be your root or your 0. So when you have one of these guys being positive and the other one being negative, you can conclude that there's going to be a real 0 between those two numbers. So let me come back up and we'll just do this really quickly. So we're going to use synthetic division. Again, if you want to plug in, that's fine as well. So I'm just going to go negative 1 out here, and then we'll put a 1, a negative 3, a 4, a negative 12, a negative 12 again, and then a 36. So hopefully you know how to do synthetic division at this point. So we're going to drop down this 1. Negative 1 times 1 is negative 1. Then negative 3 plus negative 1 is negative 4. Negative 1 times negative 4 is positive 4. 4 plus 4 is 8. Negative 1 times 8 is negative 8. Negative 12 plus negative 8 is negative 20. Negative 1 times negative 20 is positive 20. And then negative 12 plus 20, that's going to be positive 8. And then negative 1 times 8, that's going to be negative 8. And so 36 plus negative 8, that's going to be 28. And again, we saw that f of negative 1 was equal to 28 on the graph. Let me just write that f of negative 1 is equal to, so this is positive 28. Okay, let me get rid of this. We're going to keep those coefficients in there. We're going to change the value of k to 2 now. All right, let me drop this down. So 2 times 1 is going to be 2. Negative 3 plus 2, that's going to be negative 1. 2 times negative 1 is negative 2. 4 plus negative 2 is 2. 2 times 2 is going to be 4. Negative 12 plus 4 is going to be negative 8. 2 times negative 8 is going to be negative 16. So negative 12 plus negative 16, that's going to be negative 28. And then if we do 2 times negative 28, that's going to be negative 56. Let me fix this 8 here. Then if you do 36 plus negative 56, you get negative 20. And again, we saw from the graph that our f of 2 was equal to negative 20. So we can get rid of this. We don't need this anymore. Again, you don't have to go to a graph each time. That's unnecessary. If you get this type of problem, just figure out what f of -1 is, and that's 28 in this case, that's positive. Then figure out what f of 2 is. In this case, that's -20. Again, it's negative. So if one is positive and one is negative, then you can conclude that you're going to have a real zero between those two values, so between -1 and 2. All right, for problem 2, we have f of x equals x cubed plus 7x squared plus 13x plus 3. So again, I'll just show you this with a graph real quick. I'll leave a link for you on Desmos. This is -4 comma -1. So in other words, if you said f of -4, you're going to say that's equal to -1. And this is 0 comma 3, so f of 0, that's going to be 3. So this is negative in terms of the y value, and this is positive. Again, because this is a continuous curve, this guy right here, if it's going to go from below the x-axis to above the x-axis, it has to pass through the x-axis itself. Now in this particular case, you're going to notice that you're going to hit a 0 right there, and right there. That is okay. We're just saying that there's at least one real zero between an x value of -4 and an x value of 0. It doesn't matter that there's more than one. That's okay. So we're going to go back up, and we're just going to show this real quick. So if you want f of -4, you can just do this with synthetic division. Again, you can plug in also if you want. So this is a 1, a 7, you have a 13, and then a 3. Let's drop this down. So -4 times 1 is -4. So 7 plus -4 is going to be 3. -4 times 3 is -12. 13 plus -12 is 1. -4 times 1 is going to be -4. 3 plus -4 is -1. So we can see that, again, f of -4 is going to be equal to -1. Now, we can get rid of this. We don't need it anymore because for 0, that's one that I would not use synthetic division for because you could just plug in. So we'll just say that f of 0 is just going to be equal to what? Well, anywhere where I plug in a 0 for x, it's just going to go away, basically. You'd have 0 plus 0 plus 0. You just get rid of that. So then you have the plus 3, so it's just going to be 3. So if we look at this f of -4 is -1, so it's a negative, and then f of 0 is 3, so it's a positive. So again, because this is negative and this is positive, we know that we have a 0 between those two values. Again, even though there's more than one 0, that's okay. We're just using this to say we know we have at least one real 0 between the two values of -4 and 0. All right, so the instructions are going to change. We want to determine if k is an upper bound, a lower bound, or the test is inconclusive. All right, so coming down to problem 3, we have f of x equals 2x to the 4th power plus 10x cubed plus 14x squared plus 6x. We're given a k value, that's 2. So if the k value you get is positive, you're going to check for an upper bound. You're not going to check for a lower bound. So with an upper bound, what you're going to do is set up your synthetic division, and you're going to look at the bottom row. So that's where you get your quotient, your remainder. And if everything there is non-negative, so meaning it's positive or 0, then you do have an upper bound. So you will not have a 0 that's greater than your k. So let's put 2 right there just to set up the synthetic division. So we're going to take a 2 and then a 10, a 14, a 6. Now you're missing your constant, so you want to put in a 0 there. You want that as a placeholder. So let's go ahead and drop this guy down right there and go 2 times 2, that's 4. 10 plus 4 is 14. 2 times 14 is 28. 14 plus 28, that is 42. 2 times 42 is 84. And then 6 plus 84 is 90. 2 times 90 is 180. 0 plus 180 is 180. Now, I don't care about any of this. I just want to look to see, is everything non-negative? So positive, 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 and positive. So we're good to go. So we can say that k, which here is 2, is an upper bound. So there will not be a real 0 that's greater than 2. So let me put that this is an upper bound. All right, for problem 4, we have f of x equals x to the 5th power minus x cubed minus 2x squared plus 5x minus 3. We're given a k value here that's equal to -5. So if this is negative, you want to check for a lower bound. Let me go ahead and set this up. So I'm going to put a -5 here. And then for the synthetic division, you have a 1. You're missing x to the 4th power, so you put in a 0 for that. Then you have a -1, a -2, you have a 5, and then a -3. Okay, so let me go ahead and redo that. Let me make it a little bit better there. I'm going to drop down the 1. And then -5 times 1 is -5. 0 plus -5 is -5. -5 times -5 is 25. -1 plus 25 is 24. So -5 times 24, that's going to be -120. -2 plus -120, that's going to be -122. -5 times -122, that's going to be 610. 5 plus 610 is 615. So then -5 times 615 is going to be -3075. So if you do -3 plus -3075, you're going to get -3078. So this is going to be a lower bound. And the way you know that is you're looking for alternating signs. So in other words, you're starting with a positive, then you go negative, positive, negative, positive, negative. Now, if you get something that's 0, you can use it as either, whatever you need to make that pattern work. So in other words, let's say this was a 0 right here for whatever reason. Well, I could treat that 0 as being negative and I'd be okay. So if you get a 0, it can be treated as a positive or negative. Just use it as you need. But basically in this case, you're looking for alternating signs. So positive, negative, positive, negative, positive, negative. And we have that here. So we can say that k, which is -5, is a lower bound. So there won't be a real 0 that's less than -5. So let's put that this is a lower bound. All right, let's take a look at problem 5. So here we have f of x equals 4x to the 5th power minus 16x to the 4th power minus 8x cubed plus 16x squared plus 4x. The k value here is equal to -1. So this example here is going to help clear some things up. So a lot of students get confused because in some cases, just like this one, you're going to see that you actually have a lower bound, but when you do the test, it's going to fail. So I want to explain what's going on. Let me come down here and let me just first show you this with a graph. So this is the graph of our function, and I'll leave a link for you on Desmos. It's a little bit hard to see, but clearly this guy right here, this x value of -1 is a 0. In other words, we can say that f of -1 is equal to 0. And if I look to the left here, where the x values are less than -1, you see that you're not going to have another 0 there. So in other words, this by definition is a lower bound than -1 because there are no real zeros that are less than -1. Now, if we come back up here and we do the test, you're going to see that it fails. So let me go through this real quick, and then I'll talk about what's going on here. So let me just take this as a 4, this as a -16, this as a -8, this as a 16, this as a 4. You do not have a constant here, so put in a 0 for that. And let's put this like this, and then put a -1. I'm just going to drop this down and then go through. So -1 times 4 is -4. -16 plus -4 is -20. -1 times -20 is 20. -8 plus 20 is going to be 12. -1 times 12 is -12. 16 plus -12 is 4. -1 times 4 is -4. 4 plus -4 is 0. And then -1 times 0 is 0. 0 plus 0 is 0. So when we look at this, again, let's say we're doing the rational roots test or something like that. And basically we would find that this guy's a 0. But we would not determine that this guy is a lower bound. Why? If you look at the test, again, it's supposed to alternate in sign. So this should be positive, negative, positive, but then this should be negative. So this right here is going to cause it to fail. But again, if we go back to this graph right here, clearly -1 is a lower bound. So what is going on? Well, this is what we call a one-sided test. What it means is that if I test something, so let's say I test -2, which I'll do in a moment for you, and it works as a lower bound, in other words, it passes the test, I can conclusively say that it's a lower bound, and you will not have a real 0 that is less than that number. If I do the test with something and it fails, it really doesn't tell me anything. It's inconclusive. You cannot say that -1 is not a lower bound because it failed the test. That's what we mean by a one-sided test. If I was to erase this, and let's say I did -2, I already know that's going to work. So let's plug in -2 right there, and you drop this down. So -2 times 4 is -8. -16 plus -8, that's going to be -24. And then -2 times -24, that's positive 48. -8 plus 48, that's going to be 40. -2 times 40, that's -80. 16 plus -80, that's -64. And then -2 times -64, that's positive 128. 4 plus 128, that's 132. And then -2 times 132, that's -264. 0 plus -264 is -264. So using the bottom row here, you have positive, negative, positive, negative, positive, negative. So this does pass the test for a lower bound. So we can conclusively say that -2 is a lower bound. In other words, there are no real zeros that are less than -2. Again, if you go back here, there's -2 for the x value. You can clearly see that that does work. There are no real zeros that are less than -2. But again, when we did -1, it did not pass the test. So that's something that you really need to keep in mind when you're working on these problems. If something does not pass the test, you cannot say conclusively that it's not a lower bound or upper bound just depending on what test you're doing. You can only conclusively say that it is an upper bound or lower bound if it does pass the test that you're doing. So hopefully that makes sense, and maybe that'll save you some frustration if you're working on a problem like this in a textbook, although most of the textbooks will just give you problems where they say, show that this is an upper bound or show that this is a lower bound, but some of them do use problems like that, so it's really based on which book you have. So here I'm just going to answer that the tests, let's just put the test, maybe I'll put the here, so the test is inconclusive. Inconclusive. Meaning we cannot determine that this guy right here, this -1, is a lower bound even though it is. All right, let's take a look at problem 6. So here we have f of x equals 2x to the fourth power minus 2x cubed minus 5x squared minus 3x plus 2. We have a k value that's 3. Again, if this is positive, you're going to check for an upper bound. So let's go ahead and say we have 3 there. And let's set this up. So we have a 2, we have a -2, a -5, a -3, and then a 2. Let me just redo that. And let me do this like this and drop this down. And so let's go ahead and get started. So we know that 3 times 2 would give me 6. And then -2 plus 6 is 4. 3 times 4 would be 12. -5 plus 12 is 7. 3 times 7 is 21. -3 plus 21, that's going to be 18. 3 times 18, that's going to be 54. 2 plus 54 is 56. So again, everything here is positive. As long as it's non-negative, you can have zeros here. So as long as it's non-negative, you're okay. You can conclude that your k value, which is 3 here, is an upper bound. So you will not have a real zero that's greater than 3. So let's say that this is an upper bound. All right, for problem 7, we have f of x equals x to the fourth power plus 7x cubed minus 25x squared plus 11x plus 6. We have a k here that's equal to 1. So let's put a 1 here, a 7 here, a -25 here, an 11 here, and then a 6 here. And then let's put a 1 here. So this is positive. So we're going to test for an upper bound. Let me drop this like this. So 1 times 1 is 1. 7 plus 1 is 8. 1 times 8 is 8. -25 plus 8, that's -17. And then 1 times -17 is -17. 11 plus -17, that's going to be -6. 1 times -6 is -6. 6 plus -6 is 0. We're testing for an upper bound here, so you cannot have a negative entry in the bottom row if something's going to be an upper bound. It has to be 0 or positive only. So this one right here is going to cause it to fail. This one also, but again, if you're in this section and you're not actually trying to find zeros, you're just trying to do the test. Once you get a negative entry there, you can just stop and say that the test is going to be inconclusive. Remember, it's a one-sided test, just like we talked about in problem 5. So you cannot conclude that your k here, which is equal to 1, is not an upper bound. It's inconclusive. I'll just tell you that I've looked at the zeros for this, and it actually is not an upper bound, but again, you can't conclude that from the test. So let's just put that the test is inconclusive. All right, for problem 8, we have f of x equals 4x to the fifth power minus 11x to the fourth power minus 18x cubed minus 7x squared minus 4x. The k value here is -4. So again, if this is negative, you're testing for a lower bound. So let's take 4, -11, -18, -7, -4. And again, you're missing your constant, so just put in a 0 for that. Let me redo this. So let me drop this down. And we're going to multiply. So -4 times 4, that is -16. -11 plus -16, that is -27. Then -4 times -27, that's 108. Then -18 plus 108, that's going to be 90. -4 times 90, that's going to be -360. Then -7 plus -360, that's -367. -4 times -367, that's going to be 1,468. Then -4 plus 1,468 would be 1,464. And then -4 times 1,464, that's going to be -5,856. Let me fix that 5 there. Let me extend this a little bit. So 0 plus this -5,856 would be -5,856. Again, we don't care about any of these entries. We're just trying to figure out, does it alternate? So this is positive, negative, positive, negative, positive, negative. Yes, it does. So this guy right here is going to be a lower bound. So let's go ahead and say that we have a lower bound. Again, that just means that you will not have a real zero that's less than this -4. All right, for problem 9, we have f of x equals 3x to the fourth power minus 14x cubed plus 11x squared minus 14x plus 8, where k here is equal to 1. So let's take the 3, the -14, the 11, the -14, and then the 8. And then let's put the 1 right there. Let's drop this down. We're going to be testing for an upper bound because this is positive here. So we have 1 times 3, which is 3. -14 plus 3 is -11. 1 times -11 is -11. 11 plus -11 is 0. 1 times 0 is 0. Negative 14 plus 0 is negative 14. 1 times negative 14 is negative 14. 8 plus negative 14 is negative 6. So again, if you're testing for an upper bound, you cannot have a negative entry. So right away, when you get this negative 11, you can just stop if you're in this section. Again, if you're looking for zeros, and that's why you're doing the synthetic division, then you'll just continue to the end. You'll see this is not a 0 because the remainder is not 0. But in this particular case, if you're in this section, you can just stop here. Now again, this is a one-sided test. So we cannot conclude that this 1 is not an upper bound. We don't know. The test is inconclusive. So we'll just say the test is inconclusive. And I'll just tell you, I looked at the zeros already for this. And so this actually is not going to be an upper bound. So you do have a real 0 that's greater than 1. But again, you cannot figure that out from this test. It's going to be inconclusive. All right, for problem 10, we have f of x equals 3x to the 4th power minus x cubed minus 2x squared plus 3x plus 2. The k value here is equal to negative 4. So let's put a negative 4 here. And then let's take the 3, the negative 1, the negative 2, the 3, and then the 2. Let me fix that. So we're going to be testing for a lower bound, again, because this is negative. Let's drop this down. Negative 4 times 3 is negative 12. Negative 1 plus negative 12 is negative 13. Negative 4 times negative 13, that's positive 52. Negative 2 plus 52 is going to be 50. Negative 4 times 50 is negative 200. 3 plus negative 200 is going to be negative 197. And then negative 4 times negative 197, that's going to be 788. And then 2 plus 788 is 790. So the question is, does this alternate? This is positive, negative, positive, negative, positive. Yes, it does. So this is going to be a lower bound. You will not have a real 0 that's less than negative 4. So I'm just going to write that this is a lower, let me fix that. So a lower bound. All right, let's take a look at the practice test where the instructions were asked to find all zeros. All right, before we look at any of the problems, I'm just going to give you the steps for finding the zeros of a polynomial function. The very first thing you should always try is to factor the polynomial function. So in easier cases, the zeros can be found by simply factoring. Sometimes you can't get all of the zeros you need, but you can just cut down the amount of work you have to do. Maybe you're starting with something that's a 5th degree polynomial and you do some factoring and you end up only having to work with a 3rd degree polynomial. So that's a lot easier. So provided you haven't gotten all the zeros you need, you would move on to step 2 and you would start this process where you would use the Descartes Rule of Signs. So this will tell us the possible number of positive and negative real zeros. This is going to be extremely helpful throughout the process. The third thing is I would use the Rational Zeros Theorem to list all possible rational zeros. So once I have that list, now for 4, I'm going to test the potential rational zeros using synthetic division. If you get a remainder of 0, that tells you that that potential rational zero is an actual rational zero. For the 5th thing, while we're doing the synthetic division, we're going to be using the upper and lower bounds theorem to narrow down the possibilities. Then for the 6th thing, once a 0 is found, you're going to use the factor theorem to rewrite the polynomial function. So you have your f of x equals the quantity x minus k times q of x, where k is the 0 we found. So if q of x is a quadratic, we can stop and use the quadratic formula. Sometimes you can factor. If q of x is not a quadratic, then basically you're going to repeat the process. So you're going to try to factor your q of x. If that doesn't work, you're going to test the remaining candidates on q of x. Now, these two things here are very important. They're common questions. The first thing is the 0 that you just found should be retested on q of x, just in case you have a 0 of multiplicity. Sometimes you have a double root, so maybe you have a 0 of 1, but the multiplicity is 2, something like that. Then this one right here, candidates that were not zeros for f of x will not be zeros for q of x and don't need to be retested. So that one's very important. It's a question that I get asked all the time. All right, for the first problem, we have f of x equals x cubed plus 5x squared plus 8x minus 96. The first thing you're going to do is see if you can factor. This is a 4-term polynomial, so you would try to factor it using grouping. In this case, you're not going to be able to. So you would move on and use Descartes' Rule of Signs. So hopefully you remember how that works. For your positive real zeros, you're looking at the number of sign changes in f of x. So with f of x here, we have a positive, a positive, a positive, and a negative. So this right here is one sign change. So the positive real zeros would be 1. Again, you can try to decrease that by 2, but in this case, 1 minus 2 is negative 1, so that's not possible. So the exact number of positive real zeros will be 1. We know that for sure. Then for this one, the negative real zeros, you're looking at the f of negative x. And so for that one, the quick way to do it is where you have an odd exponent. So there and there, you're just going to flip the sign of the coefficient. So here this is positive 1, here this would be negative 1. Here this is positive 8, here this would be negative 8. That's a very quick way to get that. So once you look at this, you're going to say, how many sign changes do I have? So this is negative and this is positive, so that's 1, and this is positive and this is negative, so that's 2, and then this is negative, so that's no sign change there. So basically what you're going to have is 2 sign changes. So the number of negative real zeros, well, the maximum it could be is 2, because there's 2 sign changes. Or again, you can keep reducing that by 2 until you get to negative. So 2 minus 2 would be 0, and then 0 minus 2 would be negative 2. That's not possible. So it's either 2, that's the maximum, or 0 in terms of the negative real zeros. Remember, we want to generate a list of possible rational zeros. How do we do that? Well, again, you think about the factors of this guy right here. This is your constant term. Forget about the fact that's negative. Let's just think about it as 96. You would list out all the factors for that, and that would be over the factors of your leading coefficient. So in this case, that's 1, and that's going to make this really easy because you can just forget about it. You can just think about the fact that it's just the factors of, again, I'm just going to go with positive 96 to keep it simple. And I have all this listed for us. So you have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 16, plus or minus 24, plus or minus 32, plus or minus 48, and then plus or minus 96. Fortunately, it's not going to be that bad because we're going to find the zeros pretty much right away. But in some cases, you might be working on a problem. You may have a list that's longer than this, and maybe you have to go halfway or 3/4 of the way through before you actually get a 0. So because we were told that the number of positive real zeros is exactly 1. In the lesson video, I told you I would start in the middle. You can do that if you want. You can check for an upper bound, something like that. I typically do start with the smallest positive number when I'm checking those. Keep in mind that even though we have a positive real zero for sure, we don't know if it's rational. It could be irrational. So it might not be on the list. You might have to go through all of those guys before you figure that out. So that's why this process is very tedious. So for this one, I'm just going to show you this. I'll put this on screen if you want to check it. But basically, when you do the synthetic division with your 1 here as your value for k, you're going to end up with a remainder of negative 82. So obviously that's not 0, and the upper bound test here would be inconclusive. So next we can check positive 2. So here we would have a remainder of negative 52. And again, the upper bound test would be inconclusive. Then when we check positive 3, we actually get a remainder of 0. So we know that 3 is a 0. So when this happens, you're just going to record these values here. Remember, we started with a 3rd degree polynomial. So this is going to be a 2nd degree polynomial. So this 1 would be the coefficient for x squared. This 8 would be the coefficient for x. This 32 would be the constant. So I'm just going to grab this and come down here. I already wrote this out. Basically, this is where this is coming from. You're going to say that f of x, again, using the factor theorem, is equal to, your divisor is x minus k. So the k value here was 3. So this would be x minus 3, that quantity, times the quantity, x squared, plus 8x plus 32. So at this point, I don't need to keep doing synthetic division because this right here is a quadratic. So we can just try to solve x squared plus 8x plus 32 is equal to 0. So this right here, this 1, the coefficient for x squared is a. This right here, this 8, the coefficient for x to the first power is b. And then c, the constant term is 32. So you would just plug into this, and I've already done that for us. So x equals negative 8 plus or minus the square root of 8 squared plus, I just treated this as negative 4 because normally you have minus 4 times 8 times c. So I just changed it a little bit. So this is plus negative 4 times 32 over 2. So I'm just going to say this is equal to negative 8 and then plus or minus the square root of, so 8 squared is 64, and then negative 4 times 32, that's negative 128. This is all over 2. So this equals negative 8 plus or minus the square root of 64 minus 128 is negative 64, and this is over 2. So this is equal to negative 8 plus or minus the square root of negative 64. Well, the square root of 64 is 8, and the square root of negative 1 is I, so we're going to put this as 8i. Then this is over 2. What you want to do here is factor out a 2. So inside the parentheses, you'd have negative 4, and then plus or minus 4i over 2. This would cancel, and so you're left with your negative 4 plus or minus 4i. So depending on the book, they might list the answer like this. So let me put zeros like that, and let me paste this in. And you could split this up if you want. So you could say negative 4 plus 4i, and then negative 4 minus 4i, and then this one was 3. So you can list it like that. Other times they're going to set this equal to 0 and show it that way. So you might say something like x minus 3, that quantity, times the quantity x squared plus 8x plus 32. Let's say we set that equal to 0. The x values that would make this true, that would be, let's put equals negative 4 plus 4i, and then negative 4 minus 4i, and then 3. So however you want to write it, sometimes they write it like this, sometimes they write it like this. Just realize that there's different notation based on the book you're using. All right, for problem 2, we have f of x equals x cubed minus x squared minus 53x plus 165. So can you factor this one? Again, it's a 4-term polynomial. You would try using grouping. That's not going to work here. So we would just go into using Descartes' Rule of Signs. And again, you would look at f of x. So here you're looking for how many sign changes do you have. So this is positive to negative, so that's 1. And then here you have from negative to positive, so that's another 1. So basically you have 2. So the number of positive real zeros, it would be 2 at the maximum, because that's the number of sign changes you have in f of x, or it would be 0. Again, because we can decrease that by 2. Then for the negative real zeros, again, we're going to look at f of negative x. So here, this is negative, negative, positive. So here's a sign change. So there's 1, and then this is positive. So there's only 1 sign change. So the negative real zeros here would be exactly 1. So if I look at the possible rational zeros, again, it's that p over q. This right here, this is your constant. It's 165. The leading coefficient is 1. So you don't have to worry about these in this practice test because all the leading coefficients are 1, again, to make it easier. So I'm just thinking about what are the factors of 165. That's all I have to worry about. So coming down here, we have possible rational zeros. So you can have plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 11, plus or minus 15, plus or minus 33, plus or minus 55, and then plus or minus 165. So again, quite a lot of possibilities. What I would do, because I have only one negative real zero, and I know I have exactly one, I would start by testing the negatives. Now, in this particular situation, that's not going to work out, but that's what I would do. The reason it doesn't work is that although you have one negative real zero, you don't know whether it's rational or irrational. In this case, it's going to end up being irrational, and you would have been better off going with this one right here. But again, we don't know that because we haven't worked the problem yet. By my strategy, I would start with something like -1, then go to -3, then -5, -11, so on and so forth. So we would start by testing -1. And again, I've already done the synthetic division for us. You can just pause the video if you need it. But basically, this is not going to work because the remainder is not 0. It's 216. Then in terms of the lower bound test, it's going to be inconclusive. Then we'll check -3. Again, the remainder here is 288. So that's not going to work. And the lower bound test, again, is inconclusive. Then we're going to go to -5. So the remainder here is 280. Lower bound test, again, is inconclusive. Now we're going to go to -11. Now, if you look at -11, this guy right here, the remainder is not 0. It's -704. But something that's interesting is that this is positive, negative, positive, and then negative. So what does that tell me? Well, if this is a negative here, and these alternate in the sign, so again, positive, negative, that tells me that -11 is a lower bound. So I can stop searching on that list for negatives. In other words, I don't have to do -15, -33, -55, or -165 because I know that that negative real zero that I know I have is not going to be on this list. It's going to be irrational. So now I'm going to go back and think about the positive guys. So basically I would start with, again, +1. If you want to start with something in the middle, again, that's up to you. It's all personal preference. I'm just going to start with 1 and see if that works. So this is 1, testing that. The remainder is 112. Upper bound test is inconclusive. Testing 3, the remainder is 24. Upper bound test is inconclusive. Testing 5, we get a 0. So this is where you would stop. And again, you're going to write this guy. This would be a quadratic. So this is x squared plus 4x minus 33. I already have this on the other page. So this is now f of x equals x minus 5. Again, it's x minus k. The k value here was 5. And then times, we just found the quotient as x squared plus 4x minus 33. Again, that's coming from right here. All you have to do is take this right here and use the quadratic formula. So you have your x squared plus 4x minus 33 is equal to 0. So your a value here is 1. Your b value here is 4. And your c value here is -33. So we're just going to plug in, and I'm going to get x equals -4 plus or minus the square root of 4 squared plus -4 times -33 over 2. So everywhere there was an a, I just took it out because it's 1. Multiplying something by 1 doesn't change it. So that's why you don't have that entry right there or down here. Okay, so let's go through and crank this out. It wouldn't be that bad. So it's -4 plus or minus the square root of 4 squared is 16. -4 times -33, that is 132. Let's just do this now. So 16 plus 132, that's going to be 148. So this is over 2. Now, 148, let's think about that for a moment. Well, it's going to be 37 times 4. Let's write -4 plus or minus. We could do this a long way. Let's go the square root of 4 times 37 like that so nobody gets lost. This would all be over 2. So we know the square root of 4 is 2. So you can just erase this and put 2 times square root of 37 like that. We're going to go ahead and say we're going to factor out a 2. That would give me -2 plus or minus the square root of 37 all over 2. And then let's cancel this with this. And so we're going to end up with -2 plus or minus the square root of 37. And I think we can just use this right here. Again, if you want to just list out the zeros like this, I think that's fine. So I'll just write zeros. Let me write this one first. So again, it's x minus k. K is 5 here, so one of them is 5. Then the other one would be -2 plus the square root of 37, and then you're going to have negative 2 minus the square root of 37. Also, if you wanted to do the x equals these values, that's up to you. It's just depending on the book you're reading or your teacher, how they want to format the answer. So typically I'll just write zeros and then list them like this. All right, for problem 3, we're going to get a little bit of a break. So we have f of x equals x cubed minus 2x squared minus 16x plus 32. Again, this is why I tell you to always try to factor, because when you look at these problems in a book, or maybe your teacher gives you an assignment or something, a certain amount of them can be factored, and you're meant to do that to just give yourself a little bit of a break, because these problems, again, when you have to go through all those steps, it's very, very tedious. So the first thing I would do, this is a 4-term polynomial, so I'm going to think about factoring by grouping. So I'm just going to say this is equal to, I'm going to pull out an x squared, and then I would have x minus 2, and then here I'm going to pull out a negative 16, and so that's going to be x minus 2. So we have a common binomial factor here. So let's say that this is x minus 2, and then times, you'd have this x squared, and then minus this 16 here. Now this can be further factored because it's the difference of squares. So you can say that this is x minus 2, and then times, this would be x minus 4, and then times x plus 4. So it's very easy with this one right here. And we'll just say that f of x is equal to this. If you want to set this equal to 0 because it's easier for you to understand, that's fine. But basically, you can just grab the zeros. Again, they're of the form x minus k, where k is the 0. So this would be a 0, this would be a 0, and this, you can change it over into, again, minus a negative 4 like that. And so this would be a 0. So in terms of your zeros, they're going to be 2, and then you'd have 4, and then you'd have negative 4. Again, you can always solve this if that's more comfortable for you. So in other words, you could also do x minus 2, and then x minus 4, and then x plus 4. So all those quantities multiplied together, set this equal to 0. Again, from the zero product property, what you would do in this case is say, well, x minus 2 is equal to 0, or x minus 4 is equal to 0, or x plus 4 is equal to 0. Let me fix this or here, and let me fix this 0 here. Well, we're going to get the same answers, right? So you add 2 to both sides here, this cancels, you get x equals 2. So that's this one right here. For this one, you add 4 to both sides, this cancels, you get your x is equal to 4. So that's this one right here. And then for this one, let's subtract 4 away from each side, this cancels, you get your x is equal to negative 4. So that's this one right here. So a lot of times, books will show it like that, and that's where you get the x equals, because they set the guy equal to 0. Again, if you want to do it that way, that's up to you. But I'm just going to go ahead and list it this way. So I'll say the zeros. You're going to have 2, 4, and then negative 4. Okay, let's take a look at problem 4. So here we're given f of x equals x to the 4th power minus 5x cubed plus 11x squared minus 15x. So the first thing is if you have an x everywhere, so you have x to the 4th power, x cubed, x squared, and then x, you automatically know that the number 0 is a 0, or you could say the number 0 is a root so it doesn't get confusing, because basically if you plugged in a 0 for x, you'd have 0 minus 0 plus 0 minus 0, and that's just 0. So I know that's going to be equal to 0. A good way to show that is just to factor the x out. So your x is right there. So if we had x times the quantity x cubed minus 5x squared plus 11x minus 15, and I set that equal to 0, well, by the zero product property, I know I would have x equals 0 as one of the solutions, and the other ones would be found by going x cubed minus 5x squared plus 11x minus 15 equals 0. So what you do in this situation is you just record that 0, again, the number 0 is a 0, and then you work on the inside part. So you got to figure that out. So in order to avoid confusion, I'm just going to call this g of x, just so we know what I'm talking about. That way you're not confused about f of x, which is the original guy. And so g of x will be equal to x cubed minus 5x squared plus 11x minus 15. Again, so nobody's lost. It is coming from right here. That's what we're working on. We would do the whole process on this. So the positive real zeros, again, for this one would be 3 or 1, because you have a sign change here, and then another one here. So that's 2. And then another one here. So that's going to be 3. So it's 3, or I can decrease that by 2 and get to 1. So the maximum number is 3, or it could be 1. Then here for negative real zeros, this is going to help you out a lot. Notice that for g of negative x, there's no sign change at all. This is negative x cubed minus 5x squared minus 11x minus 15. So negative, 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 negative. So the negative real zeros here, it's 0. So we know we won't have any. So when you generate your list, again, this is a 1. This, forget about the fact that it's negative 15, just call it positive 15, and think about what are the factors of positive 15. Again, that's your possible rational zeros. Well, plus or minus 1, plus or minus 3, plus or minus 5, and then plus or minus 15. Well, hold on a minute. We just said that negative real zeros would be 0, so you could really reduce this and say that you can get rid of the negatives and say, well, modifying the list, it's 1, 3, 5, or 15 only. I don't need to check any of the negatives here. So coming down here, if I check 1, I'm going to get a remainder of -8. So that's not going to work. Again, the upper bound test is inconclusive. Then if I check 3, I'm going to see that I have a 0. So this right here, because we were working with a cubic, this is going to be a quadratic. So this is x squared minus 2x plus 5. So that allows me to write this as x, remember we factor that out, times the quantity x minus 3. Again, it's x minus k, and k here is 3. And then times, this was the quotient, so x squared minus 2x plus 5. So for x squared minus 2x plus 5, if you set that equal to 0 and solve this with the quadratic formula, your a here is 1, your b here is -2, and your c here is going to be 5. You're going to get x equals the negative of -2 plus or minus the square root of -2 squared, plus you have -4 times 5 all over 2. So this would be equal to, the negative of -2 is 2, then plus or minus the square root of -2, again, this is wrapped squared, that's positive 4. -4 times 5 is -20, so this would be minus 20. Then this is all over 2. And maybe this is way too long, so let me change that like that. So 4 minus 20 is -16, so let me say this is 2 plus or minus the square root of -16 over 2. Now, the square root of -16 is going to be 4i. So let's say that this is equal to 2 plus or minus 4i over 2. And we can factor out a 2 from the numerator. So 2 times a quantity. This would be 1 plus or minus 2i over 2. And of course, this is going to cancel with this. And let's say that we're going to have this 1 plus or minus 2i. And let me come back here. Again, I'll just write the zeros here. So let's say for the zeros, initially we found that the number 0 was a 0. Then we found that 3 was a 0. And then we found that for this one, we had 1 plus 2i. So that's a 0. And then you're going to have 1 minus 2i. That's a 0. Again, if you want to do the x equals notation, that's fine as well. All right, let's take a look at problem number 5. So here we have f of x equals x to the 5th power plus 2x to the 4th power minus 18x cubed minus 36x squared plus 81x plus 162. Now this is actually one that you can factor. It might not be obvious that you can factor, so if you went through the normal process on it, that's fine. It's not that big of a deal. You will get the same answer either way. Now, how do I know you can factor this? Well, I want you to notice that the coefficient here is 1 and the coefficient here is 2. Then this one, the coefficient, let me go plus negative here and plus negative here. The coefficient is -18. The coefficient is -36. So 2 times -18 would be -36. Just think about that for a moment. Then this one is 81 and 162. Well, 2 times 81 would be 162. I'm just going to maybe do this like this. And let me go plus negative again. So I can wrap that and then wrap this. From the first group, I'm going to pull out just x to the 4th power. Inside, I'm going to have x plus 2. From the second group, I'm going to pull out a negative 18x squared. So inside, you're going to have x plus 2. From the third group, I'm going to pull out 81. So that's going to give me x plus 2. So you have this guy right here, this guy right here, and this guy right here. So it's a common binomial factor. So of course you can pull that out. So we would say this is x plus 2. And then what's left? You'd have x to the 4th power. Let me make this better here. And then you'd have minus 18x squared. And then you'd have plus this 81. Now, this can be factored. You can use substitution if you need to. And I guess I'll probably do that because I don't want anybody to be lost. So let me put a little border here, and I'll do this the long way, although it's very easy to do without substitution. So I'm going to let u be equal to x squared. And so you can say that this is u squared minus 18u and then plus 81. So hopefully that makes sense. All I'm really doing is saying that if you have x to the 4th power, it's x squared squared, and then minus 18, again, this is x squared, and then plus 81. If I'm going to let u be equal to x squared, well, this would be u squared minus 18u plus 81. Okay, get rid of this. This is very easy to factor. So hopefully you know that this is going to factor into u minus 9 quantity squared. How do I know that? Well, you could actually write this, let me do this a different way, as u squared minus 2 times 9 times u, and then plus 9 squared. So hopefully that makes it obvious. So this is equal to the quantity u minus 9 squared. Okay, so let me get rid of this in the middle. So u minus 9 quantity squared. Okay, so if u is equal to x squared, all we have to do is say that this is x squared minus 9 quantity squared. And I'm going to write this as x plus 2. And then this would be x squared minus 9 quantity squared. So what does that really mean? It means that you have x squared minus 9 times x squared minus 9. Well, I know that x squared minus 9 will factor into x plus 3 times x minus 3. So this is x plus 2, and then times x plus 3, and then times x minus 3, and then times x plus 3 again, and then times x minus 3 again. So really, let's just go ahead and say that it's x plus 2 times x plus 3 quantity squared, and then times x minus 3 quantity squared. So lots of ways you could do that. Again, a lot of people, when they see this, you could have used, let me move this down here, a little rule that says this is x plus 2, like this. And then this, you could say, well, it's going to be, let me use brackets here. This would be x plus 3 times x minus 3, like that. So that's this guy right here on the inside being squared. And then, of course, from the rules of exponents, this is going to be applied to this factor and this factor. So that would be equal to this right here. So if you want to do it that way, that's fine as well. Okay, so once we have it like this, it's very, very easy to get the zeros. So you would think about the fact that you could write this as x minus a negative 2, and then x minus a negative 3, quantity squared. And then you just have your x minus 3, quantity squared. So this right here would be one of your zeros. This would be a 0, and then this would be a 0. So that's all you have to do. Again, you could also say something like x plus 2 times x plus 3, quantity squared, times x minus 3, quantity squared, is equal to 0, and then just solve that. So you would do x plus 2 is equal to 0, or x plus 3 is equal to 0, or x minus 3 is equal to 0. So subtract 2 away from each side of the equation here, x is equal to negative 2. Subtract 3 away from each side of the equation here, x is equal to negative 3. And then you're going to add 3 to both sides of the equation here, so x is equal to 3. So whether you do it by writing it in this form here, which is fine, or you set this up this way, it's really up to you. You're going to get a 0 of negative 2, you're going to get a 0 of negative 3, and then you're going to get a 0 of positive 3. The only difference here is that you have some multiplicities to consider. So depending on how the question was worded, you might want to answer it like this. So I'll say zeros. Let's say they just asked you for that. So again, you're going to have negative 2, then you're going to have this negative 3, and then you're going to have this positive 3. So let me just highlight it. So negative 2, negative 3, and then positive 3. So that would be one answer if they just asked you for the zeros. A lot of times, the book is going to say, give me the zeros and their multiplicities. So in that situation, let me just put a separate answer here. I would say negative 2. That only occurs once, so you just list it once. You don't have to put anything. And then for negative 3, again, because you have this squaring here, the multiplicity is 2. It's a double root. So I would list that by saying negative 3, and then in parentheses or something like that, I'll just put multiplicity, and I'll abbreviate that, and that's going to be 2. Then similarly, for 3, you're going to have a double root again because of the squaring. So I'm going to put 3 there, and again, I'm going to list that the multiplicity is 2. All right, let's take a look at problem 6. So here we have f of x equals x to the 4th power plus 16x cubed plus 54x squared minus 16x minus 55. This one can actually be factored, but I'm going to do it both ways because it's not obvious that you can factor this. Let's say I regroup this as x to the 4th power plus 54x squared and then minus 55. So that's just going to be one group. And then I'm going to go plus, what will be left? You have 16x cubed, and then minus, you'd have your 16x. So I didn't do anything illegal. I just changed the order of the terms. So looking at this one right here, let me do this first. This is easier. You're going to pull out a 16x, and that's going to give you x squared and then minus 1. So we know this can further factor. We won't do that yet. For this one right here, again, it's quadratic in form. So let me just write this off to the side. Let's again say that you have x squared plus 54x squared minus 55. Again, you can do something. I'm going to come back up in a moment. You could do something like you let u be equal to x squared. And so this becomes u squared plus 54u minus 55. Well, can you factor this? Yeah, pretty easily. This is u and this is u. Two integers that sum to 54 but have a product of negative 55. We could do positive 55 and then you could do negative 1. So what I'm going to do, again, u is equal to x squared. Let me get rid of this. And I'm just going to write, instead of u plus 55, I'm going to say we have x squared plus 55. And then instead of u minus 1, we're going to have x squared minus 1. And I need my equal sign here. And so at this point, you can already see that this is common. So you can pull it out. So we're going to say that we have the quantity x squared minus 1. And we know we can further factor that, but let's do that in a moment. And then here you're going to have x squared. You're going to have plus 55 and then plus 16x. I'm going to write that as plus 16x plus 55. So this right here is what we have. Now this can be factored further and so can this. And we're going to keep going. So we know this is the difference of squares. So this is x plus 1, and then times x minus 1. And this right here, you can factor it as x and then x. So two integers that sum to 16 and have a product of 55, that's going to be 11 and 5. So we're going to go plus 11 and then plus 5. So again, once you have it in this form, it's very easy to go through it. You can just say that, again, this is x minus a negative 1 like this, times x minus 1 like that. And that is not so clear. So let me make that a little bit better. And then this would be x minus, let me change the color here. So negative 11 like that, and then I'll change it back. And let's do x minus a negative 5 like that. So again, let me change the color here so it makes more sense. So again, you could just get the zeros from this form. So there's a 0, there's a 0, there's a 0, there's a 0. That's all you have to do. So for this problem, it's actually pretty easy if you can do the factoring. But again, for this one, that is not obvious. So if you didn't get it, don't worry about it. That's something that you really need a lot of practice to spot. So I'm going to say that the zeros here, let me erase this and do this like that. We would have negative 1, we would have positive 1, we would have negative 11, and then we would have negative 5. So with that being said, let me come down here and do the problem in a different way. So this is your f of x, again, x to the 4th power plus 16x cubed plus 54x squared minus 16x minus 55. Positive real zeros, there's just going to be 1. And that's because there's one sign change in this f of x here. So just right there. And so basically, when we get to f of negative x, you're going to see there's 3 sign changes. So there's one right there, and then there's one right there. So let me count those off, and then there's going to be 1 right there. So that's going to be 3. So for negative real zeros, it would be 3 or 1. If I'm doing this problem, and again, I didn't see the factoring, the fact that I have one positive real zero, I'll probably start with the positives. And again, because this leading coefficient here is a 1, I'm just looking at, forget about the fact that it's negative, I'm just looking at the fact that I have 55 for the constant. So what are the factors of 55? Well, you have plus or minus 1, plus or minus 5, plus or minus 11, and then plus or minus 55. So it's really not that many. So those are your possible rational zeros. So I would just start with 1 and just work my way up. So here's 1, just trying that. And if you go through, immediately you get a 0. You also see that this is an upper bound, right? Because the entries down here, you have all non-negative entries. So 1 is a 0, and it's also an upper bound. We also know from Descartes' Rule of Signs that the positive real zeros, it would only be 1. So all of this makes sense. You would take this as your cubic now. So let's say this is x cubed plus 17x squared plus 71x, and then plus 55. Let me make that better. And I already have this written on this page right here. So we have x minus 1. Again, the k value is 1. And then times this x cubed plus 17x squared plus 71x plus 55. Again, this is coming from the synthetic division. I don't want anybody to be lost. So it's just coming from right there. So coming down, now we know we don't have any more positive real zeros. So we would check the negative ones. So I would start with negative 1. So when we try negative 1, we see that we get a 0. So this right here is where you can stop because you can immediately go to the quadratic formula or factoring. So let's come down here. And now we would say we have x minus 1. And then times x plus 1, and this x squared plus 16x plus 55, again, that's coming from right here. This, we started with a cubic, so this would be a quadratic. This is 1x squared plus 16x plus 55, so that's where that's coming from. So looking at it now, you can just take this guy, and you can actually solve that with factoring. So x squared plus 16x plus 55. So this right here would be x, and this would be x. Again, we did this earlier, so we know this is plus 11, and then plus 5. So you could actually factor this and say it's x minus 1 times x plus 1, and then times, you can go x plus 11, and then times x plus 5. So that's how we would do it using synthetic division. So again, if you want to take the zeros, go ahead and write it all in the form of x minus k. So x minus 1, and then x minus a negative 1, and then x minus a negative 11. Again, all the things we did earlier, and then x minus a negative 5. And again, some of this stuff doesn't show up so well. So let me change this and change this. So this is crystal clear. I think this one's okay, but we'll change it. So it's x minus k. So this right here would be a 0. This would be a 0. This would be a 0. And this would be a 0. So let me write out, once again, the zeros for this guy. You would have positive 1, negative 1, negative 11, and then negative 5. All right, for problem 7. We have f of x equals x to the 4th power plus 5x cubed minus 8x minus 40. So you can factor this using grouping. Again, if it's a 4-term polynomial, I would immediately look at that. So this is x cubed, pulling that out from the first group. So you would have x plus 5. From the second group, pull out a negative 8, you're going to have x plus 5. So very easy to do that here. And you're going to have this common binomial factor, which is x plus 5. So this right here is going to be the quantity x plus 5. And then times x cubed minus 8. Now at this point, you might say, okay, well, I need to do synthetic division with this, but you don't. Remember, you can factor this as well. So let me paste this right here, and let me put f of x is equal to this. So we're going to use this formula right here to factor this. So we have a cubed minus b cubed is equal to the quantity a minus b times the quantity a squared plus ab plus b squared. So we learned this formula earlier on in the course. So here, your a is x, and your b is actually going to be 2. So let me rewrite this and put this as 2 cubed. So that's crystal clear. So you can say this is equal to your x plus 5 here, and then times, just follow this. So again, a is x, b is 2. So you want x minus 2. X minus 2, and then times, here you'd want x squared, and then plus you'd want 2 times x, and then plus you would want 2 squared, which is 4. That's all it is. I'm just going to flip this back to 8. So this is your f of x now. And basically, this right here is not going to be able to be factored any further using rational numbers. Of course, if we want to use complex numbers, we can do it that way, but this is an irreducible quadratic. So all we have to do is set this equal to 0 and solve it with the quadratic formula. So I have my x squared plus 2x plus 4 equals 0. Again, your a here is going to be 1. That's always going to be the case for these problems today. And then your b here is 2, and your c here is 4. So we're just going to plug in. And so we get x equals negative 2 plus or minus the square root of 2 squared plus negative 4 times 4 all over 2. So this would be equal to negative 2 plus or minus the square root of 2 squared is 4, and then negative 4 times 4 is negative 16. So this is minus 16. This is all over 2. Okay, so this is equal to negative 2, and then plus or minus 4 minus 16 is going to be negative 12. So this is the square root of negative 12 all over 2. Now we know that negative 12, let's just rewrite this as negative 1 times 4 times 3. So that's crystal clear. We know that the square root of negative 1 is I, and the square root of 4 is 2. So I'm going to say this is negative 2 plus or minus 2i times the square root of 3 over 2. Now notice that I can pull out a 2 from the numerator. So this would be 2 times the quantity, negative 1 plus or minus I times the square root of 3 all over 2. And then let's go ahead and cancel this 2 with this 2. And we'll say this is equal to negative 1 plus or minus I times the square root of 3. So coming back up here, let me erase this, and I'll just rewrite this. So I'm going to say f of x is equal to, so we have x plus 5, that quantity, times the quantity x minus 2, and then times the quantity x squared plus 2x, and then plus 4. And again, you could change this over to minus a negative 5 if you want to make that crystal clear when you write out your zeros. Again, let me just do that so nobody's lost. So let's go x minus a negative 5. And so for the zeros, you'd have a negative 5, you'd have a positive 2, and then again, for this guy right here, you'd have negative 1 plus I times square root of 3. And then you'd also have negative 1 minus I times square root of 3. All right, let's take a look at problem 8. So we have f of x equals x to the 4th power plus 6x cubed plus 6x squared minus 12x minus 16. So this is actually one you can factor. Not obvious, so I'm going to do it both ways. If you see something like this, so let's say you have a 4th degree polynomial, just think about the fact that you could see something that's quadratic in form. So in other words, let me try to group x to the 4th power plus 6x squared and then minus 16 together. So then I would say, well, what's left? We have this plus 6x cubed and then minus 12x. So I'll group those together. And then let me see if I can find something that's common. And then maybe I can factor this. I'm just going to tell you in advance that you can. So this right here, I'm just going to use substitution. Again, when I don't, people get confused. So let me just say that I'm going to let u be equal to x squared. And again, this is x squared squared plus 6x squared minus 16. So let's just say this is u squared plus 6u minus 16. Okay, just so it's not hard to factor, let me move this up here. I know you can do it without it, but a lot of times when I do that, I get people saying that they're lost. So just use the substitution if that's happening to you. Okay, so this is u and this is u. And then you want two integers that sum to 6 and have a product of negative 16. Well, that's going to be positive 8 and then negative 2. Okay, so because u is equal to x squared, all you have to do, we're going to erase this, and everywhere there's a u, you just put x squared. So this is going to factor into x squared plus 8, and then this would be x squared minus 2. Okay, get rid of this. Now, from this guy right here, what can you pull out? You can pull out a 6x. So 6x gets pulled out. You're going to have x squared and then minus 2. So notice that this right here and this right here, that's the same. So you have a common binomial factor, so we can go ahead and pull that out. So this is x squared minus 2. Let me fix this. And then we're going to have what's left. If this was pulled out, you'd have this x squared plus 8, and then you'd have this plus, again, this is pulled out, the 6x. Now I'm going to reorder this because this is going to be something we can factor. And now, sliding down, we're going to have what? This x squared minus 2. You could actually factor that. I'll talk about that in a moment. This guy right here, you can factor. It's pretty easy. So x here and x here. Two integers that sum to 6 and have a product of 8. Of course, that's going to be 4 and then 2. So if you want to factor this, of course you can. You don't have to use the square root property or the quadratic formula. You can just say that this is x plus the square root of 2, and then times x minus the square root of 2. And then this would be times x plus 4. So plus 4, and then times x plus 2. And of course, if you're trying to get the zeros, I would recommend just writing them in that format so you don't make a mistake. You can also set this equal to 0 and solve. That's up to you. But I like to just do it this way. So x, let's go minus, let's go the negative of the square root of 2 like that. And then this quantity would be x minus the square root of 2. Don't need to change anything there. This would be x minus a negative 4 like that. And this would be x minus a negative 2. Okay, so now you can just go through and take these values here for your zeros. That's all you have to do. So let's slide down. Let me actually move this over so it fits, kind of flowing off the screen there. So let's say that the zeros are going to be, you have the negative of the square root of 2. So that's this right here. This is just the square root of 2. So the square root of 2. You can go plus or minus the square root of 2 if you want to do it that way. Then you have negative 4. And then you have negative 2. So those are your zeros. All right, let's go through this the long way. So here's f of x. So how many sign changes do you have? Well, you're just going to have one. So we're basically going to have one positive real root. And then for f of negative x, let's see, you're going to have one sign change, and then another one, and then you have one right there. So that's 3. So 3 or 1. Okay, so what I like to do, again, if I have one positive real root, I don't know if it's rational or irrational, so I don't know if it's going to be on the list, but I would just start with positive. Because this one, it's 3 or 1. So I would start with this one. Again, if you get it, then you know you're done. You can just eliminate that. So it makes it go a little bit quicker. All right, so looking at this, again, this is always going to be a 1 for these problems. So I'm just looking at factors of, forget about the fact that it's negative 16. What are the factors of positive 16? So you have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and then plus or minus 16. So those are the possible rational zeros. Okay, so checking 1, if you want to start that way, you're going to see that you get a remainder of negative 15. So this is not a 0, and the upper bound test is inconclusive. Okay, checking 2, what you're going to find here is that although it's not a 0, you have a remainder of 48, this is an upper bound. And we know this is true because, coming back up to what we did earlier, this right here is the positive real zero that Descartes' Rule of Signs is telling us about. It's the square root of 2. So the square root of 2, let's just say that's about 1.41. So clearly 2 is larger than that. So it makes sense when we do the test for the upper bound that we would say that there's no real zero that's greater than 2. So what that tells me, if I go back, I can eliminate all the positive possible rational zeros from this list and just say, okay, I want negative 1, negative 2, negative 4, negative 8, and negative 16 now. This is what I'm going to work with. So I'm just going to start with negative 1, and you see you get a remainder of negative 3, so that does not work. And the lower bound test would be inconclusive. We check negative 2, and we see that we do have a 0. So this allows me to get a cubic, right? So this would be x cubed plus 4x squared minus 2x, and then minus 8. So this right here, again, allows me to rewrite it. Let me just paste this in here. Again, the reason this is x plus 2 is because the k value is negative 2. So it's x minus the negative 2, which is x plus 2. And then this right here, again, that's this right here that I just copied down. So x cubed plus 4x squared minus 2x minus 8. So now this is what you're going to work on. This right here. So your synthetic division is going to change. So I would now check negative 2 again, because you might have a double root. So coming down, we check negative 2, and you're going to see that it doesn't work. So you get a remainder of 4. Again, the lower bound test is inconclusive. And then now we're going to go to the next number, which would be negative 4. So negative 4 does work. You see that the remainder is 0 here. And although the lower bound test is inconclusive, because this is positive, 0 could be either positive or negative as you need it to be. So you could treat this as a negative, but then this is a negative. You would need a positive, negative, positive. So this is where it would not pass the test. Again, that would be inconclusive, but it doesn't really matter because at this point, we have enough information to get it to a quadratic. This would be the coefficient for x squared. And this right here, it would be plus 0x, you can leave it off, and then minus 2. So x squared minus 2. So coming back, now you have this x plus 2. Then you have times the x plus 4, again, because we had x minus a negative 4, so that's x plus 4. And then this is your x squared minus 2. So at this point, you could just say x squared minus 2 is equal to 0. Again, you can always solve that with factoring, but you can also use the square root property. So just add 2 to both sides of the equation. You get x squared is equal to 2. Let me fix that. And then you could just say by the square root property that x is equal to plus or minus the square root of 2. So if you look at the zeros, from this right here, you're going to get, let me just rewrite this. So this is x minus a negative 2. And then this is x minus a negative 4. And then this right here, you can just say it's x minus the negative of the square root of 2. And then this, let me slide this over. And then this would be x minus the square root of 2. So again, however you do it, whether you figured out from factoring or you went through it the long way, it doesn't matter. You can find the zeros. So negative 2, negative 4, negative square root of 2, and then square root of 2. Let me write them out once again. So here are the zeros. So negative 2, negative 4, the negative of the square root of 2, and then the square root of 2. Of course, if you want to put plus or minus the square root of 2, that's fine as well. All right, for problem 9, we have f of x equals x to the 4th power plus 8x cubed plus 11x squared minus 32x minus 60. So once again, just looking at this, I see that this is a 4th degree polynomial. So I'm going to try making something that's quadratic in form. So I would go x to the 4th power plus 11x squared, and then I'm going to have minus 60. So I'm going to group those together, and then what's left? You have this 8x cubed, and then you have your minus 32x. So I'll just do this one by factoring, and I'll let you do it the other way if you want. But again, once you understand how to factor like this is the way to go on this type of problem. You can't always factor, and that's why you have to do it the long way sometimes. Again, this is quadratic in form, so let's split this up like this. And I think we can do this without substitution. If you need it, you can do it, but just pretend for a moment that you had x squared plus 11x minus 60. What would you do? You would put an x here and an x here, and then you'd say, what two integers would sum to 11 and give me a product of negative 60? Well, that would be positive 15 and negative 4. So you can put plus 15 and then negative 4. The only difference is that this is x to the 4th power and this is x squared. So you're just going to put a squared here and a squared here. That's the only difference. Because when you go through, the first terms, x squared times x squared is x to the 4th power. Then for your outer, you have negative 4x squared. Your inner is 15x squared, so that combines to give you the 11x squared. And then your last, 15 times negative 4, that's negative 60. So hopefully you can do that without substitution. If you need it, you can always pause the video and do it that way. So then plus here, we can pull out 8x. And so what's left is you're going to have x squared minus 4. Okay, so you see there's a common binomial factor. So we're just going to pull that out. So you would have x squared minus 4. And then what's left? You have x squared plus 15. So x squared plus 15. And then here you're going to have plus 8x. Again, I would reorder that and just say it's plus 8x and then plus 15. And then here, x squared minus 4, we already know that that would be factorable. So this is the difference of squares. That's x plus 2 and then times x minus 2. And this right here, we can factor that. So x and then x. And so two integers that sum to 8 and have a product of 15, well, that's going to be 5 and 3. So plus 5 and then plus 3. So let's just go ahead and rewrite it so we can get the zeros. So let's go x minus a negative 2 like that, and then x minus 2 like that, and then x minus a negative 5 like that, and then x minus a negative 3 like that. So for the zeros, you have negative 2, you have positive 2, you have negative 5, and you have negative 3. So let's go through here and just say that for the zeros, we're going to have negative 2, 2, negative 5, and then negative 3. All right, for problem 10, we have f of x is equal to x to the 5th power plus x to the 4th power minus 5x cubed plus 5x squared plus 4x minus 6. So for this one, you can factor it a little bit. You just can't get it all the way to where you need it. So I would recommend trying that in this case. Again, the factoring is maybe not so obvious because if you see something like this, you might be thinking, well, what do I do? If I put the first two as a group, and then let's say I go plus negative here and put those as a group and then this as a group, are you going to be able to get a common binomial factor? No, that's not going to work. So then you might be thinking, can I do something with quadratic in form? And that's actually going to be what you can do here. So you could set this up and say that you have x to the 5th power, and then let's go minus 5x cubed, and then let's go plus 4x. So that's one group, and then plus the other group would be x to the 4th power plus 5x squared, and then minus 6. So this will allow you to factor this thing down to a cubic, and then from there you could just go through your steps to get it down to a quadratic, and then of course you can use the quadratic formula, or in some cases you can factor, but in this case you won't be able to. So what I would do here is pull out, let's see, from the first group, you can take out an x, and then let me just say that that would be x to the 4th power minus 5x squared, and then plus 4. and then plus, I'm going to factor this further. Let me just catch this one real quick. It's not too bad. Again, this is x to the 4th power. So if you want to use substitution, you can. I'm just going to put this as x squared, and this is x squared. And then just think about two integers that sum to 5 and give you a product of -6. Well, that's going to be +6 and then -1. Okay, so this would be equal to x times the quantity. If you think about this, again, you can go x squared here, and then x squared here. Two integers that sum to -5 and have a product of +4. Well, that's going to be -4 and then -1. So then plus, you have your x squared plus 6, and then your x squared minus 1. Okay, so at this point, you're going to see that you have a common binomial factor. So that can be pulled out. So let's say that this is going to be equal to the quantity x squared minus 1, which of course we can further factor, and then times what's left. You're going to have this right here plus this right here. Now, I would just go ahead and distribute this back in. So this would be x cubed, and then you're going to have minus 4x. And then over here, you're going to have plus x squared plus 6. And you could just reorder this. So it would be x cubed, and then plus x squared minus 4x, and then plus 6. You can't really do anything with this. So this is where you're going to be stuck. You can factor this further, of course, and say this is x plus 1 times x minus 1. And let's say this is x cubed plus x squared. Let me fix that. And then minus 4x, and then plus 6. So if you want, you can already say that you're going to have a zero of +1 and also -1. And then you just need to figure out what are the zeros for this. Well, that's pretty easy to do because this 6 right here, if you think about it, you only have ±1, ±2, ±3, and then ±6. So those are the possibilities. If you think about the sign changes in this guy, you're going to have two of those guys. So for the positive, let me fix this real quick. Positive real zeros. And again, I'm talking about for just this right here, you're going to have a sign change, which is going to occur from right here to right here, and then from right here to right here. So it's 1 and then 2. So it would be 2 or 0. And then if you think about negative, so negative real zeros. If you think about, let's just call this g of x. So what would g of negative x be? Well, this would be negative x cubed, and this would be plus x squared, no change there. And this would be plus 4x, so this would change. And then you'd have plus 6. So you have one sign change. So this is exactly 1. So because there's one negative real zero, I would just start with checking -1 to see if it works. Of course, -1 was a root of the original, so you could have something like a double root. So let's just check that real quick. So you have 1, and then you have 1, -4, and then you have 6, and come here like this. And we'll check -1. Let's just drop this down. So I don't have these written out because I'm going to do it the long way. I have that written out. So -1 times 1 is -1. 1 plus -1 is 0. -1 times 0 is 0. -4 plus 0 is -4. -1 times -4 is 4. 6 plus 4 is 10. So that does not work. Again, now you can check -2 and see if that works. And so 1 comes down. -2 times 1 is -2. 1 plus -2 is -1. Let me fix that. -2 times -1 is 2. -4 plus 2 is -2. -2 times -2 is 4. 6 plus 4 is 10. So that doesn't work. So let's try -3 now. So this comes down. -3 times 1 is -3. 1 plus -3 is -2. -3 times -2 is 6. -4 plus 6 is +2. -3 times 2 is -6. 6 plus -6 is 0. Positive, negative, positive. And again, this can be treated as positive or negative. So -3 is a lower bound. And of course, we know that we only have one negative real zero. So now I know that this would be x squared minus 2x plus 2. Let me grab this and come back. You can actually delete all this information now because you can erase this and put in x. It was -3 you checked. So x minus a -3 is x plus 3. And then let me paste this in right there. So that right there. So I'm going to rewrite this. Let's say this is x minus a -1. And this is x minus 1 like this. And this would be x minus a -3. And then we're going to figure this one out. So let me just keep this one in there like this. So x squared minus 2x plus 2. Again, this is an irreducible quadratic. So we can just use the quadratic formula. So let's go x squared minus 2x plus 2. Let's set that equal to 0. And of course, you're just going to plug in. This is your a, your b is -2, and your c is 2. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so looking at this, b is -2. So the negative of -2 is 2. And then negative 2 squared would be 4. And then here, a is 1, so you can just erase it in each case. Let's go ahead and move this down. And I'm going to go plus negative 4 like that. Your c is positive 2. And so basically, negative 4 times 2 is negative 8. So this is negative 8. 4 plus negative 8 is negative 4. So this is negative 4 here. And the square root of negative 4, you can go ahead and say that that's going to be 2i. So this is 2i. So what I'm going to do is pull out a 2 and say that inside you'd have 1 plus or minus I. And this is over 2. And of course, this is going to cancel with this. And so you get 1 plus or minus I. Okay, so coming back up, again, if you want to rewrite this, we're going to say that this is x, let's go minus a negative 1. This would be x minus 1. This is x minus a negative 3. Let me fix that. You could just put the zeros for this if you want, or you can write them out using the same form. You just have to be really careful. So x, again, you can go minus. You can have 1 plus I like that, and then you're going to have x minus your 1 minus I like that. This is a good way to just grab your zeros when it's in this form. So this is a 0, this is a 0, this is a 0, this is a 0, and this is a 0. So let's put these zeros here. You'd have negative 1, 1, negative 3, 1 plus I, and then 1 minus I. So that's one way you could do it. Okay, I'm going to go through this problem again, just pretending like we didn't know we could factor it. So for the sign changes with f of x, you see that you would have 1 right here, and then 1 right there, and then 1 right there. So that's 1, 2, 3. So for positive real zeros, it's 3 or 1. Then for negative real zeros, looking at f of negative x, you've got a sign change there, and then you've got a sign change there, so there's 2, so 2 or 0. So thinking about the possible rational zeros, again, you have a leading coefficient here. We're looking at f of x of 1. So we're only looking at the factors of the constant term. Forget about the fact that it's negative 6. Just think about it as positive 6. So looking at that, you have possible rational zeros, plus or minus 1, plus or minus 2, plus or minus 3, and then plus or minus 6. So you could start with the negatives if you want. Let's just start with negative 1. And you see that that does work. Looking at this, we have a remainder of 0, but the lower bound test is inconclusive, so you would keep going. So this right here, you can really rewrite this as x minus a negative 1, which is x plus 1, and then times, this would be a 4th degree, so x to the 4th power, and then plus 0x cubed, so just leave that off, then minus 5x squared, plus 10x, and then minus 6. What I would do is now work on this part right here, and just using synthetic division, let's just try negative 1 again. You always want to test to see if you have a double root. So we check that, and it does not work. And again, the lower bound test here is going to be inconclusive. So let's go to the next one, which would be negative 2. That does not work. Lower bound test is also inconclusive. So let's now go to negative 3, and that does work. And if you look, you have positive, negative, and this can be used as either, so we can just treat it as a positive. So negative 3 will be a lower bound. There will be no real zero that is less than negative 3. So we have x plus 1, and then x, again, minus the negative 3 is plus 3. And this would now be a 3rd degree. So you'd have x cubed minus 3x squared plus 4x, and then minus 2. So just coming down here, I've rewritten this. So now we're working on this guy right here. So why am I not going to test negative 3 again? Again, for the negative real zeros, it's 2, which we just found, or 0. So we know it's 2. So coming back, now I can move on to the positives. So I would just start with positive 1, and that one happens to work. So I know that x minus 1 is going to be a factor. So this right here, this would be a quadratic, x squared minus 2x plus 2. So now we have f of x equals x plus 1 times x plus 3. And this one would be x minus, again, the k value is 1. And then this is our quotient. So x squared minus 2x plus 2, again, coming from right here. So this, again, we've already seen this with the quadratic formula earlier, but let's just do it again. If you have x squared minus 2x plus 2 is equal to 0, you get x is equal to the negative of b. Again, b is negative 2. So the negative of negative 2 is plus 2. Let me just get rid of that. And then you have plus or minus the square root of, you have b squared. b is negative 2. Negative 2 squared is 4. Minus 4. Let me just go plus negative 4. Times a is 1, so just leave it off. Times c is 2. This is all over 2a. A is 1, so this is just 2. So we know how this turns out. Let's just do it again. So negative 4 times 2 is negative 8. And then negative 8 plus 4 is going to be negative 4. So we know the square root of negative 4 is going to be 2i. Actually, let me shorten this. We know we can pull out a 2, and inside you'd have 1 plus or minus I, so this is over 2, and let's cancel this with this, and so we're left with, let me fix this real quick, we're left with 1 plus or minus I. So, just looking at this, again, you can rewrite it if you want into a different form, but I think it's obvious. This would be x minus a negative 1, so again, for the zeros, you'd have negative 1 coming from this, then you want x minus a negative 3, so it's negative 3, and then you have x minus 1, so here you can just take the 1. And then for this one, again, you can rewrite it if you want, or you can just use this, so it's 1 plus I, and then 1 minus I. So I think in this case, it's probably close to equal in terms of the amount of time, because although factoring does save some of those steps, it does take a while to factor, and a lot of times for these, it's not obvious what you need to do to factor, so maybe you spend more time trying to figure out how to get the factoring done versus just going through the steps. So it's really going to be something that you have to practice in terms of factoring, and I would say that if you don't see it within a minute in terms of what you need to do, just forget about it and go through the normal steps. It's likely that if you could factor it, it would have taken you longer to do it that way.